Kickstart your software development career. Coursera and Amazon have partnered to bring you the Junior Software Development Professional Certificate, uniquely mapped to the key job skills required for junior software developer roles. This program offers a hands-on learning experience designed to prepare you for a rewarding career in this rapidly expanding field.
Each course in this certificate is designed and developed by subject experts to lay a solid foundation for future learning in this dynamic field. Throughout the professional certificate, you gain practical skills and hands-on experience through labs, activities, and quizzes. These opportunities will not only deepen your understanding, but also allow you to apply your knowledge in real-world scenarios.
Finally, you will have the chance to showcase your creativity and problem-solving abilities through a course project, demonstrating your readiness to tackle challenges in software development. In this software development program, you'll work on exciting, real-world problems that bring Java programming concepts to life. One of the projects you'll tackle is building a virtual zoo management system. This project is designed to test your coding skills while introducing you to essential software development concepts.
You will start by learning how to design classes that represent different animals in the zoo, like lions, elephants, and eagles. Each class will define the attributes and behaviors of these animals, helping you understand the importance of classes and objects in programming. You will then use these classes to create actual animals called objects in Java, making your virtual zoo come alive.
As you progress, you'll implement user interaction features, allowing users to navigate your zoo, select animals, and learn interesting facts about them. This hands-on project will also introduce you to advanced techniques like file I/O operations and serialization, which enable you to save and retrieve animal data efficiently. Here's a brief overview of what you'll learn.
You'll begin by understanding the core responsibilities of a developer and setting up your own Java development environment. You'll learn Java syntax and structure to write and run your initial simple programs. For example, you might create a basic calculator that can perform arithmetic operations.
You'll also explore variables, which are containers for data, and data types, like numbers or text. And you'll learn about operators, symbols for calculations. This foundational knowledge will enable you to manipulate data effectively in your programs. For instance, you could write a program to manage a list of zoo animals and their characteristics.
Then you will uncover control flow mechanisms like conditional statements for making decisions based on conditions and loops for repeating tasks. This will help you write code to manage different scenarios. For example, you might write code to handle different animal feeding schedules based on the time of day.
What's more, you'll explore advanced techniques to keep your code tidy and easy to manage. Learning object-oriented programming, or OOP, principles will help you create flexible and reusable code. For example, you might create a general animal class that includes common attributes like name, species, and habitat.
Then you can create specific classes for lion, elephant, and eagle that inherit these attributes but also have their own unique features. This approach makes your code more efficient and easier to update or expand. OOP helps in organizing your code by using classes and objects, making it easier to handle complex projects.
You'll also develop skills in understanding the entire software development lifecycle and various methodologies used in the industry. Imagine you're organizing a big concert with your friends. You'll learn how to plan each step, from booking the venue to managing the guest list, similar to how you would manage each phase of a software project. This way, you'll know how to keep everything on track and ensure the concert or your software project is a success.
As you progress, you develop skills in Java programming to manipulate data types, implement control structures, utilize object-oriented programming concepts, and manage errors effectively. Additionally, you will analyze and evaluate data structures and algorithms in Java to ensure efficiency in your applications. For example, You might write an algorithm to sort and search through large lists of animals efficiently.
Moreover, you'll gain proficiency in Git, enabling you to manage version control, track changes, and collaborate effectively on projects. For instance, you learn how to use Git to keep track of different versions of your code and work on team projects without conflicts. Later on, you'll create full-stack web applications, integrating server-side logic and front-end technologies, preparing you for real-world web development tasks. For example, you might build a web application that allows users to view and interact with your virtual zoo online.
Lastly, you will gain insights into implementing generative AI tools for task automation, further expanding your skills and keeping you at the forefront of modern software development. For instance, you might learn how to use AI to automate the generation of animal feeding schedules based on various factors. Throughout the program, you'll use tools and techniques that are standard in the industry, preparing you for real-world software development challenges. Get ready to dive into Java programming and build something amazing with your newfound skills.
So gear up, grab your laptop, and let's make some magic with Java. Who knows what you'll build? To be successful in this program, having some coding experience can give you a head start, but it's not a must-have. We recommend having a fundamental grasp of programming concepts and an openness to learn and develop your skills. The demand for software development professionals is on the rise. The United States Bureau of Labor Statistics anticipates a 25% increase in jobs by 2032. In today's digital age, software drives innovation across industries, making foundational software development skills essential for career advancement and success.
Join us to gain a competitive edge in securing software development internships or advancing your technical skills within project teams. Whether you are a junior software developer, an entry-level professional, or someone just starting out in the field, our program equips you with the knowledge and expertise to succeed. Amazon, known for its innovation and technological leadership, brings a wealth of practical knowledge to this program. Amazon software developers are instrumental in creating customer experiences, designing architecture, and implementing products used by millions worldwide. By partnering, Coursera and Amazon leverage their respective strengths to create a powerful learning experience for aspiring junior software developers. This collaboration combines Coursera's flexible, high-quality content and interactive learning experience with Amazon's real-world technological expertise.
The primary advantage lies in acquiring practical skills and knowledge essential for launching a career as a junior software developer. This professional certificate not only equips you with the expertise needed for entry-level roles, but also provides a recognized certification, bolstering your credibility within the industry. This credential can significantly enhance your prospects for securing internships or apprenticeships, offering hands-on learning experiences under the guidance of seasoned professionals. On completion, you'll possess the skills and knowledge needed to develop software applications independently, troubleshoot technical issues, and collaborate effectively in software development teams. Additionally, you'll receive a professional certificate that can bolster your resume and career prospects in the tech industry.
Wondering what makes this program stand out? Here are some unique features that will benefit you. Online assessment preparation. Get ready to excel in online technical assessments used by top companies in their job interviewing process. Insights from Amazon software developers. Gain valuable first-hand knowledge and practical insights directly from seasoned Amazon software developers.
Embark on your journey to a rewarding career in software development with a program that equips you with the skills and knowledge needed to succeed in the tech industry. Get excited, get started, and get ready to make your mark in the world of software development. Have you ever wondered what powers your favorite apps or keeps your social media buzzing? Perhaps you've pondered what goes on behind the scenes to make all of this possible. If questions like these have sparked your interest, then you're embarking on a journey that could redefine your understanding of technology. Java stands as a cornerstone in software and technology innovation worldwide. It's known for being a versatile, fast, and reliable programming language, powering everything from the apps on your phone you use to share photos to big banks that manage your money. This course is crafted to help you apply the fundamental concepts of Java programming and essential software development practices. Starting with the basics, it offers practical, hands-on learning experiences designed to get you started on your software development journey. By completing this course, you'll gain the confidence and skills to start applying essential programming concepts using Java. This groundwork lays the foundation for upcoming courses in the Professional Certificate Program and for launching a fulfilling career in software development. So let's explore what awaits you. You'll start with an introduction to software development. This is where it all begins, the foundation of your coding adventure. You'll explore the day-to-day activities of software developers and get a real-world glimpse into the life of a developer. You'll learn about a developer's key tasks and responsibilities and explore the different areas of expertise within the field, ranging from user-centered apps like those on your smartphone to programming the back end that stores and processes all the data needed to make an app function. One of the highlights of your first lesson is the Software Development Lifecycle, also known as SDLC. For the course project, you're going to create a virtual zoo and manage different types of animals. This is where the SDLC comes into play. The SDLC is the blueprint behind every successful software project. You'll learn about the software development lifecycle phases: planning, analysis, design, development, testing, deployment, and maintenance, giving you a comprehensive overview of the entire process. To start building your app, a foundational knowledge of programming is essential. Beginning with Java's fundamental building blocks, variables, data types, and operators, you'll acquire the tools necessary for efficient data handling. This foundation enables you to handle information effectively. For instance, you could begin organizing data such as animal habitats or dietary preferences within your zoo app. And since text is integral to every interaction, from user inputs and displaying content to users to back-end data processing, you'll explore how to manipulate text using tools like strings and arrays in Java. This skill will be crucial when you want to provide informative descriptions, fun facts, or interactive quizzes about different animal species. Now let's say you want to enhance your zoo app with a feature that lets animals tell the user if it's hungry or not. You can create this functionality with a concept known as control flow. Control flow lets you specify how your app navigates through different scenarios based on specific conditions. You'll explore Java's if, else if, and else constructs, which allow your app to respond intelligently to various situations. For instance, you could create a road trip program that helps you decide whether you can afford to visit Las Vegas or Area 51 instead. What's more, you'll discover how to make your app flexible so it can adapt to changing circumstances by configuring change conditions and switch statements. This means evaluating multiple criteria, like the weather, visitor interactions, and so on, to enable your app to respond dynamically to different situations. You'll also learn about automating repetitive tasks in your code. This could be creating an assembly line of cars or populating your zoo with animals. You'll discover how while and for loops empower you to streamline these processes efficiently within your app. These loops enable your app to execute specific actions repeatedly until certain conditions are met, ensuring tasks are automated effectively and reliably. You'll learn about object-oriented programming, or OOP, where code becomes a canvas for creativity and innovation, empowering you to design dynamic and scalable solutions. At its core are classes and methods, which act as blueprints for creating objects and defining their behaviors. With classes, like an animal class, you can organize data about each animal species, such as habitat preferences, dietary needs, and behavioral traits, making your app more organized and easier to maintain. Methods enable you to define actions, like making your lion go roar. You'll also unpack more complex concepts that facilitate code reuse and flexibility by establishing relationships between classes. This may seem a bit technical at the moment, but everything is explained, and you'll engage with practical examples and hands-on activities designed to simplify these concepts. This approach will empower you to apply OOP effectively in practical, real-world scenarios. As you progress through this course, you will transition from writing simple code to building a functional application. Each module, meticulously crafted by subject experts, lays the foundation for your future learning in this dynamic field. Mastering these foundational skills marks your initial steps toward preparing for internships and apprenticeships, essential milestones for becoming a junior software developer. Throughout the course, you'll gain practical skills and have the opportunity to showcase your creativity through a final project. This final project will integrate all that you've learned, demonstrating your ability to apply Java programming concepts and software development principles to solve real-world problems. By the time you complete your project and finalize the course with a quiz, you will have a solid grasp of the essentials necessary to excel in software development. This knowledge will deepen your understanding and boost your confidence in tackling more advanced programming in future courses in this professional certificate. Welcome to the exciting world of software development. Whether you're just dipping your toes or diving headfirst into this field, this video will guide you through what it entails and what you can expect to do as a developer. Let's get this party started. First, let's demystify what software development is all about with a definition. At its core, software development is the process of creating, designing, implementing, and maintaining software applications or systems. For instance, imagine developing a navigation app that helps users find the fastest routes in a city, or creating a healthcare management system that securely stores patient records and facilitates efficient medical service delivery. It's like being a digital architect, crafting solutions to real-world problems using the language of computers. What this translates to is that you get to build cool stuff on your computer that runs on other computers. And to allow you to build software, you're going to use other software. Tools like this integrated development environment, or IDE as it's commonly known, allow you to manage your files, view a single file or multiple files, and also to view the output of your program or the piece of code you are currently working on or testing. So let's unpack what the key tasks of a developer involve. As a developer, your journey often starts with understanding what the end users need. You'll work closely with clients or stakeholders to grasp the problem they want to solve or the functionality they want to achieve. Whether you're working on sensor technology for nighttime lighting, creating interactive web apps, or designing tools for travel planning, it all starts by listening closely to your clients or stakeholders. This helps you grasp exactly what challenges or features are required. Once you have a clear picture, there are 3 main types of requirements to consider. Functional requirements. These are the specific features your software must have, such as detecting light levels, user interaction buttons, or trip planning tools. Non-functional requirements. These cover how your software should perform, like ensuring sensor accuracy, website responsiveness, or data security. And technical requirements. These detail the technology aspects and constraints guiding your choice of hardware for sensors, web development frameworks, or database integrations. Now it's time to put on your creative hat and design a solution. Imagine you're planning a new music streaming app called Airwaves. Here's how you would approach it. To start, you'll conceptualize the overall architecture by outlining its core features: playlist creation, song library access, track search, and personalized recommendations. Next, you'll break down Airwaves into smaller, manageable components. These include user authentication for secure logins, ensuring data protection, high-quality music streaming that adapts to different internet speeds, playlist management for a personalized music experience, and recommendation algorithms that learn from your behavior to suggest new music. Finally, you'll determine how these components interact seamlessly. For example, once you log in, you can access your playlists, stream music without interruptions, manage playlists in real time, and receive tailored recommendations based on your listening habits. And then comes the fun part, coding. This is where you bring your designs to life using programming languages like the one you will use in this certificate, Java. There are many different programming languages out there, and no matter which one you use, you'll write lines of code to implement the logic, functionality, and behavior of the software. This might be new territory, but remember, practice makes perfect. Once you've written the code, it's crucial to ensure that it works as intended. Testing involves running various test cases to identify bugs, errors, or unexpected behavior. Debugging, on the other hand, is the process of fixing these issues by tracing through the code, identifying the root cause, and making the necessary corrections. Next, let's talk about something that might surprise you. Contrary to the stereotypical nerdy picture of a software developer alone behind big screens, software development is rarely a solo endeavor. You'll often find yourself collaborating with other developers, designers, testers, and project managers. Communication skills are key here. Effective communication ensures that everyone's efforts align, whether through meetings, emails, or collaboration tools like Slack or GitHub. It's crucial for ensuring all stakeholders are working towards the same goal. And guess what? Another key task in your day will be what you are doing right now. The world of technology is constantly evolving, with new languages, frameworks, and tools emerging all the time. As a developer, having a growth mindset and being open to learning new things is essential. Whether attending workshops, reading blogs, or experimenting with personal projects, continuous learning is the secret sauce to staying ahead in this field. Let's move on to the last two essential software development tasks, starting with version control. Ever worked on a project, made a change, and then realized you've messed something up? Version control systems like Git come to the rescue. They allow you to track changes to your code, collaborate with others seamlessly, and revert to previous versions if needed. Trust me, mastering version control will save you a lot of headaches down the road. Last, but certainly not least, documentation is your best friend as a developer. Writing clear and concise documentation ensures that your code is understandable not only to others but also to your future self. It includes things like technical documentation for fellow developers, like the example displayed on screen. And it also includes comments within your code and README files outlining how to use your software. This video walked you through the bigger picture of software development. You now know about the key tasks that software development entails, stretching from understanding requirements, designing solutions, the actual coding, to testing and debugging. Moreover, it involves collaboration, continuous learning, version control, and finally documentation. While this field may seem completely unfamiliar at first, remember that every great developer was once a beginner too. Embrace the challenges, celebrate your victories, and never stop learning. With dedication, curiosity, and a sprinkle of creativity, you'll be crafting incredible software solutions in no time. Welcome to the world of software development. It's going to be an exciting journey. Hey there. So you've been unraveling what it means to be a software developer. It's one heck of a ride in the tech world, filled with coding marathons, team huddles, and those aha moments when you solve a bug that's been bugging you for days. Now let's narrow the focus and explore what your typical day as a software developer might be like, spotlighting the skills you'll need to rock this role. Of course, a large part of your day will center around crafting new code, but you will also need to spend time on fixing bugs and optimizing existing code. But software development is rarely a solo endeavor. You'll need to sync up with your team to discuss what you're working on and draw on each other's skills and expertise. You may also need to collaborate to solve particularly tricky issues. But collaboration doesn't end with meetings. It also extends to code reviews. In these sessions, you will review their code, they will review yours, and together you will ensure everything is top-notch and up to the latest standards. Every day brings a new puzzle. Maybe there's a feature that's supposed to predict user trends, but it's not quite hitting the mark. You'll need to dive deep, think critically, and find a clever solution while ensuring the quality and reliability of your code. Your day might also include testing your code as you run through everything to ensure it works smoothly. You can then fix anything that's gone awry. Tech waits for no one. It changes fast, and your skills will need to keep pace. You will often need to set aside time in your day to catch up on the latest in tech through blogs, videos, or workshops. Staying current is crucial, but equally important is leaving a trail for you and others to follow. As you work, you'll create guides or notes that help your future self and others understand what your code is supposed to do. These will be especially valuable if you have to revisit a project in the future. To excel in the diverse and constantly changing job of a junior software developer, you'll need to develop a diverse set of skills that go beyond just writing code. So what essential skills will you need? The first is a deep understanding of programming languages. Depending on your specialization, you may need proficiency in multiple languages. For instance, developers use HTML, CSS, and JavaScript to design interactive web pages. And languages like Java and .NET are used to build the back-end systems of such web pages. On the other hand, Python is often used to write scripts for large data processing. You will also need to be able to break down complex problems into smaller, manageable tasks and devise effective solutions to work through them. Sharpening your problem-solving skills through practice and experience will set you apart as a developer. For example, figuring out why a web page isn't displaying correctly by checking each part of the code step by step helps you identify and fix the issue efficiently. Software development also requires meticulous attention to detail. A single misplaced semicolon or typo could cause your code to break. So being detail-oriented is crucial for producing high-quality code. For example, carefully reviewing your code and catching a small error before it goes live can save hours of troubleshooting later and ensure the application runs smoothly. Effective communication is another vital skill. Whether you're explaining technical concepts to non-technical stakeholders or collaborating with fellow developers, clear communication ensures everyone is on the same page. Providing clear instructions in your code comments helps your teammates understand how a particular function works, making it easier for them to collaborate and build on your work. The tech landscape is constantly evolving, so being adaptable and open to learning new technologies and methodologies is essential. Embrace change, stay curious, and be willing to step out of your comfort zone. You might need to learn a new programming language or framework as it becomes popular to enhance your productivity. Now let's discuss the need for teamwork in software development. To succeed, you must be able to work collaboratively, communicate effectively, and contribute positively to a team dynamic. Participating in code reviews helps improve code quality and fosters a collaborative environment. Finally, time management is crucial. Projects often have tight deadlines, so good time management skills are essential for prioritizing tasks, staying organized, and meeting deadlines without sacrificing quality. For example, breaking down a project into smaller milestones can help you track progress and stay on schedule. By sharpening these essential skills, you'll be well prepared to thrive in a dynamic and rewarding career as a software developer. As you progress through your learning journey, it's natural to start thinking about how to apply your new skills in the real world. Internships are a fantastic way to gain hands-on experience and see how your Java programming knowledge can be put to work. Here are some potential internship opportunities you might consider. To be considered for an Amazon internship upon completion of this course, you should be a current undergraduate student, preferably in a math or technology-related major. At Amazon, you will have the chance to work on innovative projects that push the boundaries of technology, gaining hands-on experience in software development and collaborating with industry experts. This internship is a gateway to learning best practices in a fast-paced, cutting-edge environment. Beyond Amazon, there are numerous other exciting internship opportunities for junior software developers. Imagine working at a dynamic tech company, assisting in the development of new features for an internal tool. As a Java development intern, you'll write code, fix bugs, and collaborate closely with senior developers. This role will immerse you in best practices in software development and give you valuable insights into the daily life of a software developer. Picture yourself at a healthcare startup, optimizing database queries for a patient management system. In this role, you will delve into server-side programming and database management, learning how to create efficient, reliable back-end systems that support critical healthcare applications. Imagine being a front-end developer at a digital marketing agency. There, you'll create and maintain interactive web applications for marketing campaigns, crafting the latest interactive interfaces to engage users effectively. As a full-stack development intern, you'll gain experience in both front-end and back-end development, working with Java and related technologies to deliver comprehensive solutions. This position will help you understand the entire stack of web development, making you a versatile and highly sought-after developer. These roles offer junior developers and interns the opportunity to apply their Java programming skills in real-world settings, preparing them for successful careers in software development. By engaging in these internships, you'll not only hone your technical abilities, but also develop essential professional skills that will serve you throughout your career. With a blend of technical expertise, problem-solving prowess, and effective communication, you're set to excel in this ever-evolving field. So take a deep breath and get ready. You're already on your way. Have you ever visited a new city? Imagine walking the streets, visiting local restaurants or main tourist attractions. When you're new to the world of programming, starting out in the landscape of programming languages can feel a bit like exploring a bustling city for the first time. There's a lot going on, many paths you can take, and countless things to see and learn. Let's stroll through this city, exploring key programming languages and understanding how everything connects. Just like in a city, you'll find older, more established suburbs that have been used for a long time, alongside new shiny ones that pop up all the time. Each building has a unique architecture, fit for its purpose. Let's start by exploring the classics. C and C++ are like old, sturdy buildings that have stood the test of time. They are foundational languages that many modern software systems are built on. C's ability to directly manipulate hardware makes it ideal for systems programming. Unlike higher-level languages, C allows you to interact directly with the computer's memory and system processes. This gives you much power and speed, making your programs run very efficiently and giving you precise control over how they work. C++ builds on C, adding features for object-oriented programming, which organizes code around data, or objects, rather than just functions and logic. This makes it easier for developers to organize and manage complex projects. Java is like a reliable city bus, getting you where you need to go without needing to know the mechanics of how the bus works. Java is all about portability and ease of use. Its write once, run anywhere philosophy allows you to write your code once and run it on any platform with a Java Virtual Machine, or JVM. This makes Java a favorite for large enterprises with complex needs, simplifying many processes like memory management and multi-threading. Java's robustness and scalability make it ideal for building large-scale enterprise applications, web applications, and Android apps. Java is also the language of choice, used to build the server-side logic of web applications. It handles database interactions, user authentication, and business logic. Java's diverse capabilities and extremely wide use is one of the main reasons making it the language of choice for this certificate. Python is the friendly neighborhood cafe where everyone hangs out because it's easy to get into and always welcoming. Python's simple, easy-to-read syntax makes it a favorite for beginners. Unlike more complex languages, Python's straightforward nature allows newcomers to quickly grasp programming concepts. Python's versatility sets it apart. It can handle a variety of applications, including web development, data analysis, artificial intelligence, scientific computing, and more. Next, let's explore a few of the trendy neighborhoods. In newer parts of the city, you find modern developers flocking to trendy spots. Here, JavaScript is like the main street, bustling and full of life, essential for any business or website to thrive. Originally created to make web pages interactive, JavaScript has revolutionized front-end development. JavaScript runs directly in the web browser. This allows it to quickly respond to user actions like clicks, typing, and mouse movements, making it easier to create highly interactive user interfaces for applications. And thanks to platforms and frameworks like React, Angular, and Node.js, JavaScript now powers complex web applications and even server-side technology. Go, or Golang, designed by Google, is like a modern, efficient transit system designed to get you places fast with minimal fuss. Go is known for being fast and efficient, as it executes code quickly and manages system resources effectively. Its simple syntax and powerful built-in tools make it ideal for developers who need to create software that can simultaneously manage many tasks, like handling thousands of user requests. Consider Rust the city's best construction material right now. Rust is recognized for its safety and performance, especially in system-level work, like developing operating systems where mistakes can cause software to crash or slow down. It's increasingly popular for its promise of memory safety without sacrificing speed. Now let's enjoy a few of the city's cultural spots. Every city has its cultural gems, and in programming, these are the languages especially beloved in specific communities. Swift, for Apple products, is like visiting a museum of technology, showcasing all the most modern tech. It's the go-to for developing apps for iOS, macOS, and other Apple platforms. Developers prize it for its performance, safety features, and ease of use compared to its predecessor, Objective-C. Last but not least, there is Kotlin, which might be the popular new gallery everyone's talking about. Kotlin works seamlessly with Java, but has a simpler, cleaner syntax. It's also become the preferred language for Android app development, taking over from Java due to its modern features and safety, which reduce the likelihood of common programming errors. That concludes this tour through the landscape of programming languages. From the foundational stability of C and C++ to the versatility and ease of use of Java and Python, the dynamic power of JavaScript, the modern performance of Go and Rust, and the robust app development capabilities of Swift and Kotlin, each language has its unique strengths. You've made a great choice for extending the tour into Java. As you continue, think of Java as learning to navigate a reliable and versatile vehicle in our city of programming languages. Java has been a cornerstone in the software development world for decades and is still of utmost relevance today. Understanding Java will provide a solid foundation for your programming skills and open many doors in various tech sectors. By now, you should have a pretty good idea about the fascinating range of tasks software developers perform daily. This video will take you through a helpful framework known as the Software Development Lifecycle, or SDLC, to help you understand where all these tasks fit into the bigger picture of software development. The software development lifecycle is a structured process for designing, developing, and testing high-quality software. It is a methodology that defines the entire step-by-step procedure of software development. It might help to compare SDLC to playing with Lego blocks as a kid. Can you think of an experience where you built a car, plane, or perhaps a spacecraft? What did the process entail? You most likely started with a plan, right? Then you might have gathered the pieces and followed various steps to bring your creative ideas to life. As your creation took shape, you tested it out. Then, the fun part, playing with it. And finally, if something broke, you fixed it. SDLC follows these same steps. This simple diagram demonstrates the 7 phases or steps of SDLC. Let's unpack each phase as it relates to playing with Lego building blocks. So, imagine you're about to build something incredible out of Lego. First, you'd sit down and decide what you want to make, right? That's the same as the planning phase in software development. It's like setting your goals and deciding what your software should do. This involves thinking about who your targeted customers are and what the main components of your software need to include. Say you want to build an awesome castle. You'll start by imagining how big it should be and what color bricks will look impressive. You might even draw a little sketch. Similarly, in software development, you need to plan your resources. This involves determining the infrastructure, the number of developers, testers, project managers, and other costs required at different stages. An essential part of this phase is estimating and optimizing the end-to-end cost of the project. It's also crucial to connect with different stakeholders, to identify risks, and put plans in motion to mitigate them. Once you know what you're building, you need to determine what pieces you'll need. In software development, the analysis phase is where you gather all the information about what the users want and need from the software and document these requirements. And then, before you start building, you make sure that you have all the necessary building blocks. You might even make a list of the missing pieces or ask someone to find a specific part you'll need later. This process mirrors the analysis phase in software development, where you identify all essential resources, including hardware, human resources, and applications needed for the project. Just as you would sketch your Lego creation before building it, in the design phase of software development, you create a detailed plan or blueprint of how the software will look and function. When you decide how your castle will look and where each tower will go, you're engaging in the design process. It's the same with software, but instead of drawing your plans on paper, you use lines of code to design the software structure and functionality. This includes database design, where you determine aspects like the column sizes and the number of columns in each table. You also consider external dependencies, such as integrating SMS or email services. So the entire blueprint is set out here. And with the blueprint ready, the next step is where the magic happens, writing the code. This takes place in the development phase, where you've got all your pieces sorted and it's time to start building, like assembling Lego pieces to create your masterpiece. Each line of code is like a Lego brick. Putting them together is just like snapping those bricks into place. Additionally, you need to ensure your software can communicate or integrate with other software, such as databases and files. After you build your software, you need to make sure it actually works, right? This is where testing comes in, trying out different parts of the software to ensure they perform as expected. Imagine you've finished building your castle, but before you show it off to your friends, you want to make sure everything stays together and the drawbridge goes up and down smoothly. That's testing, making sure everything works as it should. Okay, so now you've developed an outstanding software application and it's time to let users experience it. The deployment phase is like showcasing your finished Lego creation to the world. It's making your software available for everyone to use. Deployment involves making your software accessible and operational for your audience. However, the process doesn't end with deployment. Just as a Lego structure might need occasional repairs and enhancements, software requires regular updates. The maintenance phase involves making adjustments or improvements to software components over time to keep up with changing requirements and ensure optimal performance. Maintenance is all about keeping the software running smoothly and fixing any problems that pop up from time to time. This includes adding new features that enhance the user experience or fulfill previously unaddressed needs. In conclusion, software development involves careful planning, analysis, design, development, testing, deployment, and maintenance. Each phase is crucial for creating a program and making sure it works correctly. By following these steps, you can ensure that the software you create is not only functional, but also reliable and enjoyable for users. So whether you're constructing a towering castle from Lego blocks or crafting innovative software solutions, the principles remain the same. creativity, attention to detail, and dedication to seeing your project through from start to finish. If you use a mobile phone, laptop computer, or browse the internet, you most likely rely on Java without even realizing it. In this video, you'll explore some of Java's foundational features and why it powers so many devices and apps used every day. First, let's talk about what Java is. Java is an in-demand and versatile programming language and computing platform that was first released by Sun Microsystems in 1995. In the simplest terms, Java is a set of instructions that tell computers what to do. Java uses Object-Oriented Programming, or OOP. This means it organizes programs using blueprints called classes and creates objects from those blueprints. A class is like a blueprint for a car. It specifies the properties, like color and brand, and the actions, like start and stop, that all cars have in common. An object is like a specific car created from that blueprint. For example, the car standing in your driveway is an object of that specific car's class. You'll learn more about Object-Oriented Programming, or OOP, later. Let's talk more about how Java is used all around you. The wonderful thing about Java is that it uses principles that enable developers to create modular, reusable, and maintainable code. This makes Java a powerful tool for building complex applications with clear, organized architecture. Whenever you stream a video, play an online game, or even just browse the web, there's a good chance Java is working in the background to make everything run smoothly. Java plays a huge role in the technology used every day. It powers and is embedded into billions of devices, including credit cards and SIM cards, mobile phones, TV sets, and computers. To put it into perspective, there are more Java-powered devices in use today than the over 8 billion people on planet Earth. However, Java isn't only used to run everyday devices like mobile phones and laptops. It also works behind the scenes on millions of powerful computers worldwide. These high-end computers store and process data for websites, apps, and numerous other digital services. And that's not all. Both small and large organizations use Java as a programming language to develop their own custom software and run various web applications and services. Now that you have a good picture of how widely Java is used, let's explore some of the features that make Java so popular and versatile. Java is robust, meaning it is designed to handle errors and manage runtime exceptions gracefully through its built-in exception handling and garbage collection mechanisms. Before a Java program runs, the code is checked for errors, allowing any mistakes to be fixed beforehand. If something goes wrong while the program is running, Java can catch and handle those errors, preventing the program from crashing. This makes Java great for creating reliable, stable, and secure software, enhancing both the developer and end-user experience. Java also comes with a rich standard library. This is like a huge toolbox filled with pre-written code that you can use to build your applications. Instead of writing everything from scratch, you can use these ready-made tools to handle common tasks, like working with data, connecting to the internet, or creating graphical user interfaces. This makes it much faster and easier to develop complex software. What's more, Java has a strong and active community. This community includes millions of developers, many of whom share their knowledge and help each other out. There are countless online forums, tutorials, and open source projects where you can learn more about Java and get help with any issues you might encounter. This support network is one of the reasons Java has remained popular for so long. Java is used in many different fields. Let's explore some of the key areas where Java shines. Many large businesses use Java to build enterprise-level applications. These are systems that help companies manage their operations, like customer relationship management, also known as CRM, and systems or enterprise resource planning, or ERP systems. Java is a powerful tool for building websites and web applications. Technologies like Java Server Pages, or JSP, and servlets allow developers to create dynamic, interactive web pages. And did you know if you have an Android phone, you've used Java? Because of its reliability and performance, most Android apps are built using Java. Java is also used to create desktop applications, like media players, games, and productivity tools. Great examples are programs like Minecraft and Eclipse, which are written in Java. In summary, Java is a versatile and powerful programming language that plays a vital role in the tech world. Its robust features, rich standard library, and strong community support make it a top choice for developers. Whether you want to build enterprise solutions, websites, mobile or desktop applications, Java can open up a world of possibilities. You have taken your first step into that world, embarking on a journey that can transform your programming career. Have you ever organized different types of food in your kitchen by placing them into separate jars? If you're fancy, you might even have descriptive labels like flour or corn flour to help you distinguish the contents of the containers. Similarly, in any program you develop, you'll use different types of data. And to organize these data types, you'll use something called variables. In this video, you'll learn how to use variables to store various types of data, making it simpler to use your data when coding in Java. Let's start with the basics. What are variables? In programming, variables are like containers that hold different types of information. Think of them as labeled jars, where you can store and retrieve data whenever you need it. Just like you might have a jar labeled cookies in your kitchen, in a program, you might have a variable labeled player score to keep track of points in a game. Notice the keyword int on screen. It's one of the many data types in Java, and it is used for whole numbers. But more on this later. Let's first discuss two key terms: declaring and initializing variables. Declaring a variable means creating it with a given name or label and assigning it a data type, which defines the kind of data it will contain. You first type the data type and then the title of the variable as int placeScore and a semicolon. So in this case, placeScore is a container that can only carry whole numbers. When you assign a value to a variable, it is also known as initializing the variable. After you've declared the variable, you can give it a value. You simply type the name of the variable =, and the value followed by a semicolon. Now, here is the great thing. Java allows one to declare and initialize variables in one step. To do this, type int placeScore =, 150 followed by a semicolon. This code creates the variable and assigns a value to it at the same time. Just like neat containers in your kitchen cupboard, variables make coding better in many ways. Firstly, variables are reusable. Instead of typing the same value over and over, you can store it in a variable and use the variable name wherever you need it. This makes your code cleaner and easier to maintain. Second, variables are flexible. Variables can change their values as your program runs, allowing your code to react to different inputs and conditions. And finally, variables make code clear and easy to read. Using descriptive names for your variables helps make your code easier to read and understand. For example, notice how using player score is much clearer than just using the letter X. So far, you've learned about the int data type used for storing whole numbers, but there are many others. Let's explore some of them now. First up is the double data type for storing decimal numbers. For example, let's name this variable as currency in USD and assign it a value of 34.25. Another important one is the char data type to store single characters. For example, if a user needs to complete A, B, C, or D on a form. Let's create a char variable and name it as ampersand. Notice that the value of a card data type must be between two single quotation marks. Then there is the string data type to store short or long sentences or a name like Margaret Hamilton. Now for string values, you have to place the value between double quotation marks. And finally, you use the Boolean data type to store a value that is either true or false. Let's call this Boolean variable isAbsent and assign it a value of true. When naming or labeling your variables, it's important to follow certain conventions to make your code more readable and maintainable. Let's explore a few of these. First, choose names that clearly describe the purpose of the variable. For example, use distance in meters instead of just d, and isGameOver instead of flag. Next, use camel case for variable names. This means starting the first word in lowercase and capitalizing the first letter of each subsequent word. For example, total amount, username, and number of items. So the first part of the name, like total, should start with a lowercase, and the second part, like amount, starts with an uppercase. Then only use letters, numbers, and underscores in your variable names. But the names should not start with a number or contain spaces or special characters. For example, user age and max underscore value are valid variable names, while second place and max percentage sign value are not. And finally, Java is case sensitive, which means the total amount, where total starts with a lowercase, and amount with an uppercase, are considered as a different variable than total amount, where total and amount starts with capital letters. In this video, you've learned how to use variables to store various data types in Java. Here are some key points to take away. Variables are like labeled containers that hold specific data types and can be accessed whenever needed. Variables make data easy to reuse, provide flexibility, and help make your code clear and easy to read. In Java, the common data types include int, char, double, string, and Boolean. Remember, declaring a variable involves creating it with a specific data type, and initializing means assigning it a value. And finally, using proper naming conventions ensures that your variables are readable and maintainable, just like organizing different types of food in your kitchen jars. Using variables helps you manage various types of data efficiently in your programs. Think about your favorite computer game. What makes it so fun and competitive? It likely features a leaderboard that ranks players by their scores, right? Players with the highest scores might even qualify for the next level based on specific criteria. If you had to program this feature, how would you go about it? Well, you'll need a way to add a player's scores, and you'll want to compare the scores of different players to determine who has the highest score. Then you will also need a way to determine if players qualify for the next level based on more than one condition. By now, your programming brain is probably imagining the kind of variables to store these values, how to name them, and so on. But how do you perform operations like adding and comparing values or making decisions based on certain conditions? You need operators, and that is exactly what this video is about. There are several types of operators in Java, but this video focuses on three main categories: arithmetic, relational, and logical operators. Let's explore some simple examples to understand the problems each of these operators helps to solve. First up is arithmetic operators. You use these to perform basic math operations like addition and subtraction. Think of them as the tools you use to solve maths problems in Java. However, you can also use the addition operator with strings. This will combine the strings, which is referred to as concatenation in programming. Let's explore an example. If you use the addition operator with strings, like Tom and Harry, this will result into Tom Harry, combined as one word. But if you use the addition operator with two int like 5 plus 7, this will result in the sum of the two numbers, 12. Now, this is where you need to take extreme care. Say you use the addition operator as 5 plus 7, but both values are written as string values inside double quotes. This will result in the string 57 and not 12. So because the values are strings, they get concatenated with the addition operator. The addition operator can also be used in the print line to add the values of different data variables as a single combined output. Let's go over a simple example. The variable called player1 level 1 stores the value 50, and the variable player1 level 2 stores the value 45. The addition of these two variables will result in an output of 95. Observe that there is an addition sign in the print line, and it concatenates two elements, the word sum, a string, and the actual output of this variable named sum. Now consider another example where you subtract values. Say player1 score stores the value of 95, and player1 penalties stores the value 7. The subtraction of player1 penalties from player1 score results in the output of 88. Next, you need to know about relational or comparative operators. These operators are used to compare two values. They can solve problems like, is this number greater than that number? Let's first go over an example of the greater than relational operator that compares values to determine which is larger. Consider the variables player1 score and player2 score, which stores values 95 and 85 respectively. Now let's play with them. We can compare these two variables using the greater than operator and get either a true or a false. Let's test what happens. Player1 score greater than player2 score results in true. Cool, right? Let's try another one. This time, let's compare the values using the less than operator. Since the values are the same, the output of player1 score less than player2 score will result in false, right? Okay, let's move on to the last type, logical operators. They are AND, written with two ampersands in Java, or typed as two pipe characters, and NOT, signified by an exclamation mark. You use these to combine multiple conditions. They help you make decisions based on more than one condition. Imagine there are 3 players, and you need to check who has the highest score. In other words, the first condition is to check if player 1's score is higher than player 2's. Then you need to check if player 1's score is higher than player 3's. Logical operators are perfect for that. So let's test them out. But listen carefully. Here is the tricky part. The AND operator will always result in either true or false. The result will only be true if the expression on the left and right sides of the AND operator are both true. In any other case, the AND operator will result in false. So here, 3 variables are declared, initialized and assigned values. Player 1's score is 95, player 2's score is 85, and player 3's score is 73. Now let's add a print line statement that prints the results of both expressions using the AND operator. Player 1's score larger than player 2's score and player 1's score larger than player 3's score. And the result is true. Just like the AND operator, the OR operator's result will always be either true or false. And it will also be true if both expressions on its left and right are true. But here's the difference. Even if only one is true and the other is false, the result will still be true. And it will result in false only if the expression on both sides of the OR operator is false. Got it? Let's go over another example. This code checks if a user has access to the game's premium feature, which is only available to admins or those with premium membership. You can use the logical OR operator to find out if a player either has admin rights or has a premium membership. The output will print true if one of the expressions is true and the other false. If both are false, it will print false. Very useful, don't you think? Let's test out one more example, the NOT operator. The NOT operator inverts the value. So true becomes false and false becomes true. Let's test how it works. Consider the variable is authenticated and it is initialized to true. So here, the print line inverses the value of the variable is authenticated to false. So exclamation mark is authenticated will result in false. In this video, you've learned about 3 main types of operators in Java. Arithmetic operators perform mathematical operations like addition, subtraction, multiplication, and division, like adding a player's scores from multiple levels. You also covered relational operators that compare two values, determining if one is greater, less, or equal to another. Think leaderboard. And lastly, you discovered how to use logical operators. These combine multiple conditions using and, or, and not. For example, to determine if a player's score is higher than the scores of two other players. These operators are essential tools in programming, and learning how to use them will allow you to perform a variety of tasks efficiently and effectively. Keep practicing, and soon you'll be creating features like leaderboards with ease. Imagine you're building a social media web application. Every profile, post, comment, and message involves text, right? Even before that, users will need to sign up. But to enable signups in your app, you must work with text, which is where strings come in. By now, you know that strings are the primary data type for managing text in Java. Working with text is essential to create interactive and user-friendly applications. In this video, you'll learn what strings are and how to create and manipulate them in Java. First, let's define an array. An array is a collection of elements of the same type stored in contiguous memory locations. It allows efficient access and manipulation of data using an index and is useful for handling multiple values with a single variable. So, what is a string in Java? A string is a sequence of characters represented internally as an array of the char data type. Characters include letters, numbers, symbols, and spaces. Strings are used to store and manipulate text in Java programs. For example, Java is interesting is a string. Strings are super important, whether you're displaying messages, taking user input, or processing text data. To create a string in Java, you put double quotes around the text. These examples show different strings stored in variables, named string greeting, string name, and string message. Strings in Java are immutable. This means you cannot modify a string. Once a string is created, it cannot be changed. Instead, you must create an entirely new string with the desired changes. This might seem restrictive, but it ensures that strings are safe to use in various parts of a program without unexpected changes. For example, if you have a string representing a file path, see users moly, and you need to change the user to Anli, you cannot modify the original string directly. Instead, you create a new string with the desired change. So how then can you manipulate strings? Well, strings in Java are also objects. You will learn more about objects later, but for now you just need to know that this means they come with built-in methods that allow you to perform various operations on them. These operations include finding string length, accessing individual characters, comparing strings, and many more. Remember how strings are sequences of characters? Well, this means that each character in the string has a specific position in the sequence, called index, starting from 0. Now, you may have noticed something unusual. While J is the first character in the string Java, its index position is 0, not 1. This is because the index in Java starts at 0 and goes up to the length of the string -1. In other words, J is at position 1, which, when you -1, is index 0. A is at index 1. V is the third character in the string, but its index position is 3 - 1, or 2, and the final A is at index 3. Understanding character positions, also known as an index, helps access and manipulate individual characters in a string. The char@ method lets you select and check individual characters from a string. All you need is the character index, the character's position, to return to the character at that position. Let's go over a simple example. Consider the string Java. To call the string's first letter or character, you would use char@0. This returns J, the first character of the string. Subsequently, char@1 returns A, char@2 returns V, and char@3 returns A. Let's go back to your social media application. Suppose there is a restriction that usernames can have a maximum of 10 characters. If a user enters a username longer than 10 characters, an error will occur, and they will be prompted to enter a shorter username. How do you know how long the string or username is? To find this out, you use the length method. This finds the length of a string, which is the number of characters it contains, and returns it as an integer. Let's examine an example using the Java string. Calling the length method gives a length of 4 because Java has 4 characters, J, A, V, and A. It's as simple as that. Gaining hands-on experience working with strings will make it easier to apply these concepts in your programs. So let's finish this video with another quick example. You can create a program to count the number of characters in a name. Let's declare and initialize the string variable with the name Charlie, making sure Charlie is in double quotes. To store the length, you also need to declare an int variable. Let's call it length. Now, to use the length method, simply type equals name.length, followed by a set of parentheses and a semicolon. Next, you print the result. Okay, let's execute the program. Notice the output is your name has 7 characters. In the social media app you're building, working with text is crucial. Whether it's setting a username and a password or sending a direct message. Understanding strings and how to create and manipulate them is essential to enhance your app. In this video, you learned what strings are, how to create them, how to use the char method to call a specific character in a string, and how to check the length of a string. Understanding strings and learning how to create and manipulate them makes text-related tasks easier in Java programming. Imagine you're organizing a Java workshop for new coders. You've asked the attendees to fill out a digital form with their names. To create name tags, you must combine their first and last names into one string of text. This process, called concatenation, joins text together. Concatenation is a fundamental concept in Java, especially when working with text. In this video, you will learn how to concatenate text in Java and how to use the plus symbol for printing. So, what exactly is concatenation? You may have encountered it before in your Java journey, but let's reiterate its meaning here. Concatenation is the process of linking things in a series. Specifically in Java, concatenation refers to joining 2 or more strings into one string. For instance, if an attendee's first name is the string Kelly and her last name is the string Swagger, concatenating these strings results in Kelly Swagger. To concatenate strings in Java, you use the plus symbol. Let's see what basic concatenation looks like in an example. Let's create a string variable called first name, assign the value Kelly, and a string variable called last name, assign the value Swagger. To concatenate these, enter first name plus a space, denoted by 2 double quotes, plus last name to create a new string variable, full name. The space double quotes add a space between the strings when concatenated. Let's take a look at the output. The print line statement prints the value of full name, Kelly Swagger, the first name and last name combined. Note the space between Kelly and Swagger. And there you have it. You have concatenated 2 separate strings into one. Now, the plus sign concatenates strings, but as you know, is also an operator used to perform simple addition in your program. In fact, concatenation is a lot like adding strings together. We know the plus symbol is used when concatenating strings and adding numbers. So what happens if you concatenate variables that are numbers? Here, it's essential to understand the order of operations. Let's look at an example to explore this. Let's create a string variable called level 1 score, assigned the value 5, and a string variable called level 2 score, assigned the value 10. To concatenate these, enter level 1 score plus level 2 score to create a new string variable result. Let's print this out. Now, the output should be 15, right? As 10 plus 5 is 15. However, the output is sum 510. This is because the variables level 1 score and level 2 score are treated as strings and concatenated the same way Kelly and Swagger were. To correctly add numbers before concatenating, you must add parentheses around the relevant variables, in this case, level 1 score and level 2 score when concatenating. When we print this out, the result is sum 15, because the expression in parentheses, level 1 score plus level 2 score, is evaluated first and then concatenated with the string sum. The parentheses told Java to execute the addition first before concatenating the strings. Let's return to the Java workshop example. When filling in the digital forms, many attendees used upper, lower, and mixed cases when adding their names. To maintain consistency across all printed items at the workshop, including name tags, workshop guides, and schedules, you decide to convert the first and last names to uppercase before concatenating them. Let's see how to do this in practice. This program takes a first and last name, converts them to different cases, and then concatenates them. First, the names are converted to uppercase using the To Uppercase method. So, Ashley in sentence case becomes Ashley in all capitals, and Brown in sentence case becomes Brown in all capitals. These two strings are then concatenated with a space in between, resulting in Ashley Brown in all capitals. The print line statement prints the final string. The plus operator is used here to concatenate full name with the value of the full name variable. The plus operator, when used with the print line method, combines or concatenates multiple strings and variables into a single output statement. And there you have it. One program that can convert the strings to different cases and then concatenate them. It should be simple to have all the attendees' names in the correct format, ready to print. One final point before wrapping up. You can only use plus in strings. Other operators, like minus, asterisk, and backslash, would not work and would result in errors. Grasping concatenation and using the plus symbol for print statements are key skills for handling text in Java. By mastering these basics, you can create dynamic and formatted text, making your programs more interactive and user-friendly. Congratulations on finishing the Getting Started with Java module. Time flies when you're diving into the world of coding, right? In this video, you'll recap and review all the exciting things you've covered, from what software developers do to the beginnings of how they do it. First up, in Lesson 1, you explored the role of a software developer. You learned that being a developer isn't just about writing code. It's about solving problems, collaborating with a team, and constantly learning. You also touched on the main areas of expertise in software development: front-end, back-end, and full-stack. Each area has its own unique roles and responsibilities, giving you a good idea of where you might want to focus your skills. Next, you moved on to the software development lifecycle, breaking down the 7 key phases: planning, analysis, design, development, testing, deployment, and maintenance. Understanding these phases shows the bigger picture of how software is created and maintained. With this introduction to software development in place, you could move on to the foundations of Java. In Lesson 2, you took a running jump into the basics of Java. You started with a simple Java program to get familiar with the Integrated Development Environment, or IDE, and basic syntax. Remember your first program? It was a great way to see the structure of a Java program, from the main method to using built-in libraries. Java's versatility was another theme. You now know that Java powers billions of devices worldwide, from mobile phones to TV sets and Blu-ray players. You explored Java's platform independence and its strong support for object-oriented programming. Pretty impressive, right? Next, you explored variables and data types. You learned how to declare and initialize variables and got hands-on with different data types like int, float, double, and string. Understanding variables is crucial because they're the building blocks of any program. You also explored operators in Java, arithmetic, relational, and logical. These operators help you perform various tasks in your code, such as adding numbers, comparing values, and making decisions. With the basics locked and filed away, you could begin to specialize a little and focus on text in Java. Lesson 3 was all about handling text with Java. You learned that strings are essentially arrays of characters. You use methods like length to find out how many characters are in a string and caret to assess individual characters. You also practice string manipulation, seeing how strings are immutable. Once created, they can't be changed. You continued your journey with strings by focusing on concatenation. Combining strings using the plus operator helped you create more complex text outputs. Then you moved on to arrays, creating arrays of strings like arrays of names, and expanding this concept to other data types was super useful. Arrays help you manage collections of data efficiently. Finally, you put everything together in practical labs and a practice quiz. You got to code the missing pieces in scenarios, like booking movie tickets. These exercises helped reinforce your learning and gave you a taste of real-world coding challenges. Nicely done. You've covered a lot in this module, from understanding the role of a software developer to manipulating strings and arrays in Java. Keep practicing, and soon you'll be handling text and arrays in your Java programs with confidence and ease. Thanks for watching, and happy coding. Decisions help us do or avoid things based on our expectations. You take your umbrella because you don't want to get wet. If you decide not to take that umbrella and it rains, you get wet. Decision-making in Java works much the same. Here you use conditions to either execute a part of the code or avoid the execution of a part of a code. This video will introduce you to decision-making in Java using simple if and else statements. But before getting into the technical stuff, you need to meet Tony. Tony lives in New York and is planning a long road trip over Christmas to visit his family living across America. Tony is planning his first stop in Columbus, Ohio, to visit Tony's brother and sister. Since Tony's uncle also lives here, that counts as stop 2. Stop 3 is 2 aunts living in Kansas, Missouri. Stop 4 is in Salt Lake, Utah, to visit another uncle. Finally, Tony plans to spend the longest time over Christmas at his parents' home in Los Angeles. This process of moving from one stop to another on the trip in a linear fashion is an example of sequential flow in Java. What a trip! Clearly, Tony is a family person. But guess what? There is also a wild side. Tony hasn't told anyone, but if time and budget permit, Tony would love to add a diversion to Las Vegas. Tony has a lot of decisions to make while driving along the national highways. Decisions like, is there enough gas? Or do I have enough money? Can change the flow of his trip. And that is exactly what you call conditional flow in Java. The question is, since Tony is only planning to drive along the national highways, at which point of the trip will it be appropriate to decide if a diversion to Las Vegas can be afforded? As indicated by the black line on the map, it makes no sense to go to Las Vegas from Kansas, Missouri for 2 reasons. First, Tony must travel the black marked route twice to get back on the national highway. Second, visiting Las Vegas too early on the trip might blow his budget to complete the later part of his trip. Thus, it would make sense for Tony to check the conditions for going to Las Vegas when Tony is at the nearest point on the highway to Las Vegas. At this point, Tony needs to determine whether there is enough money left after accounting for the expenses for the entire trip. Herein lies an important programming lesson. There is a specific place and time for checking conditions for the program to execute effectively. For example, if you were to check your change after buying something in a shop, you would have to wait until you were given the change. Can't check it until you have it. So, following the path marked orange on the map makes more sense because it is a shorter path and eliminates doubling back on his route. Now that you've got the basics down, let's shift the focus on how you can make decisions using code. One option for making a decision in Java is to use an if statement. which has its own syntax or programming grammar. You type if and the condition in parentheses, followed by a set of curly braces where you add the code that should be executed when the condition is true. Here, the word condition should replace an actual condition. For example, to use an if statement to check if Tony can go to Las Vegas, you type if, open parentheses, amount of money, add a larger than and equal sign, and then number 300, close parentheses. Now let's put this code in a program. You know that when creating a program, there must be a public class. Let's name it main and a main method. So you type public class main, public static void, main string args. This should be familiar by now. You also need to define a variable to store the value of the money. Name it amount of money and assign 300 to it. Go inside the curly braces of the main method and add the code for the variable amount of money here. Now create the condition if amount of money is greater or equal to 300 and then add a set of curly braces for the code that must execute when the condition is true and put the display inside it. This gives you the full program, which displays go to Las Vegas only if the amount of money is greater or equal to $300. Let's test it. Here, the condition, namely amount of money, is larger than or equal to 300 is true. So go to Las Vegas is displayed. Fantastic. You just gained a very valuable tool in your Java toolkit. But how do you get the program to do something different when the condition is not met? What if Tony shouldn't take the diversion to Las Vegas? You use the else statement. The else statement is added immediately after the if statement. You type else, followed by curly braces, where you add the code that needs to be executed if the condition stated in the if statement is not met. So, the else statement allows you to do something when the if statement fails. To help Tony, why don't you put an else statement after the if statement to display the words think of the money spent when the condition of the if statement fails? Poor Tony. Let's hope this is not the case. Let's try it out. Start by putting an else statement with the curly braces directly after the curly braces of the if statement. Now, put a display inside the else statement, which gives you the entire program. If you make the value of amount of money less than 300, the condition in the if statement is false. So the code under the control of the else statement will execute instead and display think of the money spent. It's important to know that an else statement cannot exist alone. It is always associated with an if statement. As such, the code displayed on the screen would be invalid. Next, let's explore else if statements. These are useful for checking multiple conditions together when you have more conditions to check and the previous condition fails. The syntax is as follows. It starts with an if statement followed by one or more else if statements, and finally, an else statement. Let's explore the order in which the code will execute. In this example, the code starts with an if statement with the condition 1. If condition 1 is true, then the code inside this if statement is executed. And then the control goes to the very last line, after the closing curly brace of the else statement, skipping all the else if statements in between and the last else statement. But if the initial if statement with condition 1 is false, then the program progresses to the else if statement with condition 2 below it. And if condition 2 is true, the code under the control of that condition is executed. After which the control is handed to line after the curly brace of the last else statement. But if condition 2 is false, it goes on to test the next else if statement with condition 3 and continues as before. Now, say the first if statement and all the subsequent else if statements are false. What do you think will happen then? Well, this is when the last else statement is executed. Got it? Let's try it out by putting an if statement to go to Las Vegas to test if the amount of money is greater than or equal to $300. Alternatively, Tony can go to Hoover Dam if his money is less than $300. but greater than or equal to $200. Let's add this condition to an else if statement. Type else if amount of money greater than or equal to $200 and a print line, go to Hoover Dam. There are many options. Let's add another else if statement for when Tony's money is less than $200 but more than $100. In which case, he can still go to Area 51 and look at some aliens. Finally, if his money is less than $100, Tony cannot divert and needs to go directly to his parents' house. And this is where the last else statement comes into play. In this video, you learned how to use code to execute decisions in Java. What a milestone! You discovered how to use a simple if statement to execute a piece of code if its condition is met. You also discovered that you can use the else statement to execute alternative code if the condition is not met, and add multiple else if statements in between to test more conditions. Grasping these concepts sets the framework for the rest of the lesson. Moreover, you will use these principles many times in your software development career. Imagine planning your morning drink. First, you have to decide between coffee or tea. Let's say you choose coffee. You have to decide whether to have it black or with milk. However, if you opt for tea, your next consideration is whether to add lemon. Each decision builds upon the last, creating a series of choices where each one depends on the previous, like navigating a path where each turn is guided by the one before it. In programming, when you have to make one decision after another, you call the next decision nested. In this video, you will learn how to use nested conditional statements for complex decision-making in a real-world example. This is an example of a nested if statement, where the if statement with condition 2 is nested within the first if statement with condition 1. If necessary, an if statement can also be nested within an else statement. For example, notice that here the first if statement has an else statement and the second if statement is nested within the else statement now. Remember Tony's last trip? Deciding on a destination depended on available time and money. With a budget equal or greater than $300, Las Vegas was the top choice. Budgets between $200 and $299 offered the flexibility to visit either the Hoover Dam or Area 51. However, budgets under $200 meant skipping additional plans. This is the perfect opportunity to use nested if and else statements to help Tony make the right decision. Let's get coding. To demonstrate how nesting conditions work in programming, first create the main method inside the main class and save it in a file with the exact same name as that main class. Next, create a variable called amount of money inside the curly braces of the main method and assign it a value of 300. To check if the amount of money is smaller than 300, put the condition inside the parentheses of the if statement like this. If this condition is true and the amount is still above $200, Tony can choose between visiting the Hoover Dam or checking out Area 51. But if Tony has less than $200, you need to warn him by printing no diversions. To do this, you will add a nested if statement to check if the amount of money is less than $200. However, if the second level if statement for money less than $200 is false, it could mean Tony could have between $200 and $299. This will give Tony the option to visit the Hoover Dam or explore Area 51. But if Tony's budget is more than or equal to $300, handle that with an else statement, corresponding to the first level if statement. Let's discuss the flow of this program. The first level if statement checks if Tony has less than $300. If true, it progresses to the second level or nested if statement, which checks if Tony has less than $200. If true, it displays no diversions. But if the nested if statement is false, it means that Tony has between $200 and $300. and so it progresses to the second level else statement that tells Tony to either visit Hoover Dam or Area 51. If the first level if statement is false, it skips the nested code, which includes the second level if and else statement, and progresses to the first level else statement to give Tony the good news to go to Las Vegas. Now, what if you want to add further options? Let's refine the second level else statement to check Tony's interest in history. If so, Tony should visit the Hoover Dam. If not, Area 51 could be interesting. To do this, first remove the previous print line statement and set up a Boolean variable named has interest in history with a value of false. This variable will help you decide where Tony should go based on his potential historical interest. Now, inside this second level else statement, which handles Tony's budget between $200 and $300, add a third level if statement to check for an interest in history. If this check is true, display go to Hoover Dam. Next, create an else statement for the second level if statement after the curly brace of the second level if statement to handle the scenario where Tony isn't interested in history. Add a print line to display go to Area 51. Okay, let's run this code. Observe the output is go to Area 51. Why is this? Remember, you've set has interest in history to false. So, Tony will be directed to Area 51 based on the results of the conditions. You now know how to use nested conditions. But you should know that too much nesting in code can make your code hard to follow. To keep logic clear and easy to read, it's best to keep things simple and avoid nesting more than 3 levels. The golden rule is that your code should be easy to understand for others and yourself in future. Sometimes you'll come across a series of if-else statements where parts of the code seem like they should run, but they don't. This is called unreachable code. It happens when the earlier conditions result in the latter conditions being skipped entirely. It's like following a roadmap where the route you choose doesn't lead to certain destinations. So even though the code might seem okay, those unreachable parts just linger, never getting their chance to be used. Observe the example displayed on the screen. The first if statement checks if a number is greater than 200. Inside the else statement, there's another if statement that checks if the number is greater than 300. If the number is greater than 300, it won't reach the else part because it's already larger than 200, which the first level if statement handles. Therefore, the code inside first level else that checks if the value of the variable is greater than 300 will never run. In this video, you learned about nesting conditions. It's when you place one if statement inside another if statement or inside an else statement. This helps manage situations where one condition depends on whether another condition is true or false. When you eat at your favorite restaurant, would you like to be served the same food each day? Or would you prefer a waiter to ask what you'd like that day? If you prefer having the same meal every time, it's similar to setting fixed values in a program. But if you like being asked, what can I get you today? That's like a program prompting the user for input. Programs use input to let users provide data in the same way a waiter asks for your order. Essentially, getting input in programming enables the user to provide data, which the program can then use to perform actions or calculations based on that input. In this video, you'll learn how to read values from the keyboard and assign them to variables. In Java, there are plenty of external libraries you can include in your programs. One of them lets you interact with user input. This tool is found in the util library, and it's called the scanner. It's a special tool that lets your program listen to what users want. Let's dive into how to get input directly from a user. To start, at the very top of your Java program, you'll want to include an import statement like this. Import java.util.scanner . This import statement is necessary to use the scanner class in Java, which lets your program read input from the keyboard. You'll learn more about import later. For now, however, if you want to capture input from the keyboard, this import is essential. It's like readying a microphone before a performance. It prepares your program to listen. Now, inside the main method of your Java program, set up a way to read what the user enters on the keyboard. To do this, create a scanner variable within the curly braces of the main method like this. Let's name the scanner variable keyboard, but you can name it anything you like. Here's how to set it up. The variable keyboard of type scanner has various utilities to read different types of data type values from the keyboard. If you're interested, just type in the word keyboard and press the dot key. Your IntelliJ will display a pop-up that suggests the available utilities. Pretty cool, right? It shows you what's available as you type. For example, if you type the word next after the dot, you get all the options for reading from the keyboard. A next int would read an int data type, while a next double would read a double. A next float would read a float, and a next string would read a string, and so on. You can use the keyboard scanner to capture details from the user, like their age, how much money they have, or even their name. But let's say you want to start with their age. Create a variable named age of type int, and assign keyboard.nextInt, open and close parentheses, to the variable using the assignment operator like this. The nextInt method of the scanner type enables you to read a number from the keyboard. Similarly, for getting money, assign a variable money of type float to scanner variable .nextFloat, open and closed parentheses. Next, assign a variable name of type string to scanner variable .nextLine, open and closed parentheses. And finally, display all the values. Sometimes you may notice that the scanner variable will miss a string input after taking in a number. The program didn't wait for input after asking for a name. If you encounter this, there is an easy fix. Just place a keyboard.nextLine before you ask for the string. This will reset the scanner and allow it to take the string input. This would have come in really handy when planning Tony's trip. In Tony's scenario, instead of collecting the age, money, and name, you could have used this method to collect input from Tony about available time, budget, and interests, and then use that information to help Tony plan where to go. In this video, you learned how to read values from the keyboard and assign them to variables using Java Scanner. This skill allows you to create interactive programs that adapt to user input, make informed decisions, and enhance overall user experience. Mastering this fundamental technique empowers you to build more dynamic and responsive Java applications. In the same way an ice cream shop menu can offer different flavors based on the day, a switch statement in Java allows you to execute different blocks of code based on the value of a variable or expression. Let's use Tony's trip as an example. He's reached Las Vegas to visit Area 51. The temperature is around 90 degrees Fahrenheit, and ice cream is becoming a good idea. Tony finds an ice cream stand and asks the server about the flavors for that day. The server starts to mention each flavor: strawberry, vanilla, mango, chocolate. But before the server can continue listing flavors, Tony asks for a specific flavor, even though it's not on today's menu. When the server confirms they don't have that flavor, Tony opts for a glass of cold water instead. This analogy illustrates how a switch statement works in Java. Different actions are taken based on the value of the variable or expression, or in this case, Tony's preferred flavor of ice cream. Up to this point, you've learned how to use chained and nested conditional statements. But you might agree that when dealing with multiple equality checks, it can get messy. In this video, you will discover how to condense multiple equality if statements into a single switch statement. One option to code the ice cream shop scenario is to use multiple if statements, one for each condition, like demonstrated on screen. This example combines equals ignore case with if statements to perform certain actions depending on the chosen flavor of ice cream. You also need a condition to cover the situation where none of the conditions match. You can combine all the if statements using OR and reverse it using the NOT operator. But of course, a shorter way to code this scenario would be to use if else, and else like this example. However, an even shorter way to do multiple equality checks is to use the switch statement. The syntax of the switch consists of the keyword switch followed by parentheses. Add the variable or value you want to compare between the parentheses, and then add a set of curly braces. The curly braces delineate the scope of the switch statement. Inside the scope, you include case statements structured as follows. The keyword, case, followed by a space, then the value of the case, and finally a colon. It can also have the word default, followed by a colon. A case statement, or a default statement, after the colon can contain any number of lines of code. The code within a case statement executes only if the value after the case, like value 1, matches the value of the variable being checked, as in variable to check. The code after the colon in the default statement executes when none of the case values match the variable being checked. Take note, you can only perform equality checks in a switch statement. This is equivalent to using the equality operator in an if statement. To grasp this better, imagine the ice cream stand had put up queue rails for different flavors. Then Tony could have just used the correct queue from the start, right? And if there was no queue for his desired flavor, he could have asked for cold water from the start. Similarly, you can create queue rails per flavor using a switch statement. Let's do it. Type in the main class and method. Then, between the curly braces, create a scanner variable and input the desired ice cream flavor using the variable ice cream flavor. Now create the switch statement with the first flavor, which is strawberry. You have one flavor so far, so copy and paste those 2 lines to cover the other flavors and change the flavor names. Then add the condition when none of the values of the case statements match the value of the variable ice cream flavor. Add a default to specify an action for when none of the case statements have a value equal to ice cream flavor. In that case, it should display, I will have a glass of cold water. Now let's run the program. Observe what happens when the user inputs strawberry in lowercase. You get the result, I will have a glass of cold water. Aha! This demonstrates that strings are case sensitive in a switch case. It compared all the values of the switch one by one, starting with the first one, strawberry, with a capital S, which is not the same as strawberry, all in lowercase. It then checked all the other cases, vanilla, mango, and chocolate. Because none of them matched, it executed the default case. Next, input strawberry with a capital S. Notice what happens. All the code in the case statements below the strawberry case executes too. Why? The switch statement starts matching the value of the variable, ice cream flavor, from the top with the case statements, one by one. Then it matches the value of the first case statement, strawberry with a capital S. But then all the code below this line executes until it reaches a break or the closing curly brace of the switch statement. This is known as fall through. Let's correct the fall through by putting a break statement after every case, except the last one. Simply add the keyword break and a semicolon after the code of each case statement. Run it again using strawberry with a capital S, and it should run properly. In this video, you learned how to optimize conditional statements using the switch statement for multiple equality checks. You've experienced how a switch statement allows you to alter the flow of a program's execution, similar to an if-else statement. It determines whether to execute specific code based on whether a certain value matches a value being compared. You now know how to use essential keywords, such as switch, case, default, and break, to optimize the program flow in a switch statement. Of course, the same thing can be done with multiple if statements, but the switch statement handles multiple equality checks with conciseness, clarity, simplicity, and efficiency. You've recently learned about switch statements and how they help simplify code when dealing with multiple equality checks. This video dives deeper into switch statements and explores how they are used in real-world coding scenarios. Let's consider a practical example, a simple calculator. A basic calculator supports various operators, such as addition, subtraction, multiplication, and division. Using multiple if statements to determine which operator to apply can clutter your code and make it less readable. Instead, switch statements offer a cleaner and more organized approach. To better understand this concept, let's build a simple calculator. The calculator will take two numbers as input and perform the operation specified by the user using plus for addition, minus for subtraction, asterisk for multiplication, or / for division. If the user enters an operator that isn't one of these four, the calculator will inform them that the operator is invalid. The calculator will be configured to accept input for exactly two numbers from the keyboard and the operator to be used. To begin, set up the main class and method. Next, set up the scanner. Inside your main method, initialize a scanner variable named keyboard. Alright, now you need to ask the user for the initial input. To do this, create a prompt that tells the user to enter their first number. Prompt the user first with a string, like enter the first number. Then, in the place where the prompt stops, enter the numeric value you desire and press the enter key. Follow the same approach to gather input for the second number. Sometimes the keyboard next line skips the input when reading a string after the input of a number. Put an empty keyboard next line to avoid that. You will learn more about why this works later. Next, you need to prompt the user to enter the operator they want to use for the calculation. Then create a variable to hold the result, assigning a default value of 0. Now that you've set up all the components to gather the necessary input, it's time to determine which operation to perform: addition, subtraction, multiplication, or division. While you could use multiple if statements like if operator equals plus, you've learned that a switch statement is more efficient for multiple equality checks. Let's implement a switch statement for this purpose. To set up the switch statement, type switch followed by parentheses. Inside these parentheses, place the variable operator, which will be compared against the values in your case statements. After the parentheses, add curly braces to enclose the switch block. Now it's time to add the cases. Inside the switch block, create cases for each operator: plus, minus, multiply, and divide. Now insert a break after each case, except the last one, to prevent more than one case statement from executing. Within each case block, perform the corresponding calculation. For addition, set the result to equal number 1 plus number 2. For subtraction, number 1 minus number 2. For multiplication, number 1 is multiplied by number 2. And for the division case, set the result by dividing number 1 by number 2. After the cases, add a default case to handle any operator that isn't explicitly listed. Include a break statement after the default code block. Following the switch block, display the calculated result by using a print line statement for the result is plus result. Okay, let's test it. Run the code with the addition or plus operator and numbers 2 and 3. It should output 5. Try running the code again with 2 and 5, using the multiply or asterisk operator. It should output 10. Now test the calculator with 2 and 4, using an invalid operator like nope. It should display the operator is invalid. In this video, you've explored using a switch statement to create a simple calculator that supports 4 fundamental operations: addition, subtraction, multiplication, and division. While this example focused on basic functionality, switch statements are indispensable for handling diverse programming challenges, which you will learn about more in future lessons. For now, all you need to know is that switch statements provide a structured way to manage multiple conditions efficiently in your code. Iterative tasks help you to perform a specific action a definite or known number of times. For example, you want to email a flyer advertising your Java programming skills to a list of 20 recipients. As you have a predefined list of email addresses, you can send a personalized email to each recipient by changing the email address and the recipient's name. This allows you to be consistent and use iterative structures. In this video, you'll learn that in Java, if a code is to be repeated a definite number of times, you can use the for loop as an iterative structure. Imagine Tony bought a robot with an integrated AI named Psychic. However, to accomplish tasks successfully, Psychic needs clear, precise, and step-by-step instructions. Tony would love to send Psychic to go and buy 30 bottles of beer. However, Psychic can only carry up to 5 bottles at a time and must make 6 trips to the store to complete the task. Tony tells Psychic to check the number of bottles, starting at 1 and stopping at bottle number 30 to ensure he buys the correct number of bottles. Armed with Tony's credit card details, Psychic goes shopping while Tony sleeps. 2 hours later, Tony wakes up to 195 bottles of beer in Tony's room and a $290 credit card bill. As Psychic is still buying beer, Tony presses Psychic's stop button. What went wrong? Tony forgot to tell Psychic to increment the number of beer bottles for every bottle bought. Therefore, the number of bottles counted for Psychic always remained at 1. Such a mistake is called a logical mistake. It is an expensive logical mistake. Tony learned his lesson during the beer episode and will remember to give Psychic clear instructions. In preparation for a family get-together, Tony sends Psychic to buy 5 turkeys. Psychic can carry only 1 turkey at a time. Therefore, Tony writes the following program. Buy 1 turkey at a time, start counting from 0. Increment the number of turkeys by 1 each time a turkey was bought, and repeat the program 5 times. Remember, when coding, you start counting at 0. The first turkey Psychic buys will be number 0. The second turkey, number 1, and the 5th turkey will be number 4. Therefore, a total of 5 turkeys were bought and the program stopped. Tony can use a for loop as the number of repetitions is known. Before we look at how Tony uses a for loop to complete this task, let's look at the structure of a for loop. The structure of the for loop consists of 3 components: initialize, check, and change, each part separated by a semicolon. Initialize is used to set a value to the variable to count the repetitions in the loop, which is executed only once when the loop starts. Check is a condition to see that the variable value is within the range and if the loop should continue running. Change modifies the variable's value so that the condition fails after the number of repetitions required. Let's return to how Tony needs to program Psychic only to buy 5 turkeys. Tony specifies the variable number of turkeys bought inside the for loop with the initial value set to 0. The check indicates the maximum number is less than 5. Remember, you have to specify the index number here. The change is made by an increment of 1. Tony doesn't want a repeat of the credit card bill episode. Let's run the program. The program ran 5 times as Tony intended. Java starts counting from 0. Therefore, the +1 simulates human counting. The loop stops when the maximum value of 5 is reached, indicating that only 5 turkeys were bought. As Psychic brought the turkeys home, the number increased by 1 due to the ++ or increment operator. If you want the number to decrease by 1, use the - or decrement operator. Therefore, the loop will count backward, starting at 4 and stopping at 0. What is important is that a loop executes for the required number of times. Remember, counting from 1 and incrementing by 1 is easier. Let's explore how to change the code to accommodate the decrement operator. The for loop will look different. The initializer is set to 5, the check is now greater or equal to 1, and the change showcases the decrement operator or --. The print output is changed by removing the +1. Remember that you want to show a decreasing number of turkeys. The number of repetitions is still 5. Now Tony can instruct Psychic to do all kinds of repetitive tasks, freeing up his time and energy for more engaging activities. In this video, you learned how to apply a for loop based on a practical example. You learned that the for loop has 3 parts: initialize, check, and change. An increase operator can increase the number of turkeys bought, while the decrease operator counts down the number of turkeys bought. This video's key takeaway is that a for loop cannot be used if the number of repetitions is based on a condition. The repetitions need to be based on a definite number. When you visit an ATM, there is a menu with options like deposit, withdraw, check your balance, or opt out. This process continues until you quit. In Java, you can use iterative structures like a while loop to repeat code and create menu systems, like the ATM menu. In this video, you'll learn how to use while, infinite while, and do while loops as iterative structures to repeat code based on a specific condition or user input. First, let's explore the while loop. It has the while keyword, a condition, and repetitive code between the curly braces, defining the loop's scope. When the condition is met, the program stops. Let's return to Tony and his robot, Psychic. Tony's latest adventure involves cleaning out the attic and removing all the boxes. Psychic must move the boxes from the attic to the backyard. Tony has no idea how many trips it will take Psychic to clean the attic. The only condition is that Psychic cannot stop until it is clean. How would you go about coding instructions into Psychic for this task? Well, the while loop is the perfect solution for a scenario like this, where a task needs to repeat until the job is complete. Over the next few minutes, you will learn how to code this. Let's pinpoint the conditions. 1. Psychic can only carry 5 boxes at a time, and 2. The program needs to stop when the attic is clean. First, you create a variable named total trash and assume the initial trash item's value is 22. The while loop condition indicates that the action should continue while total trash is greater than 0. With each trip, Psychic removes 5 boxes. Therefore, each iteration of the loop decreases 5 items from the collection of junk. Next, add a message to keep track of the number of remaining boxes. Let's run this. After the first cleaning trip, 17 items remained, then 12, and then 7. So far, so good. However, after the last trip, it indicates that -3 items remain in the attic, which is obviously a mistake. It should be 0. Why did this happen? Because when the value of total trash was 2, the condition was still true, causing the loop to repeat one more time, resulting in 5 being deducted from 2. So, to prevent this, you need to check whether there are 5 items left for Psychic to carry. How can you do that? Oh yes, you can add an if statement. To modify the code, add a new variable, trash to carry, with a default value of 5 to indicate the item Psychic carries per trip. Now add an if statement to test if total trash is less than 5. If true, the value of trash to carry should change to the same value of total trash. So, with the next round, the while condition will be false and stop the loop. Lastly, you should add a print statement to indicate that all the items were cleared. Awesome. Psychic cleared the attic as Tony intended, and now the loop stops when the total trash is 0. Next, let's try to create an iterative menu, like the ATM example. To create something that should continue indefinitely until the user wants to exit the loop, you use a Boolean variable. To keep the loop running, you keep the Boolean value true and make it false to stop it. The while loop syntax stays the same when creating a menu, except the condition will be true until the user decides otherwise. Say Tony also wants to use Psychic to clean other parts of the house. The repetitive menu should specify clean the attic, clean the living room, and clean the bedroom. First, you create the cleaning option variable to store the user's menu choice. The Boolean variable run loop is set to true and controls the while loop, ensuring that the loop runs at least once. Next, you insert a while loop. This loop will continue executing as long as the run loop condition is true. Inside the loop, add the repetitive menu. Prompt the user to enter an integer between 1 and 4 to store the input in the cleaning option variable. Next, add a switch statement to evaluate the value of the cleaning option variable and execute the corresponding case block. Insert the 4th option to make the loop exit. Note that each case ends with a break statement to activate the switch block after executing the code. For example, if Tony selects 1, case 1 will be executed. The default option only activates with a selection outside the range of 1 to 4. Observe that the user can terminate the loop by choosing 4, which changes the value of the variable run loop to false. So, the next time the while condition repeats, it reads the false value and stops the loop. Let's run the code. The menu displays a repetitive menu. Say Tony enters 1, which will instruct Cyclic to clean the attic. Let's test the other values. 2, clean the living room. 3, clean the bedroom. Finally, when choosing 4, the menu no longer displays and the loop ends. So far, you've seen how to apply a while loop to repeat an action and how to create an iterative structure with a Boolean variable. Next, you'll explore the do-while loop. The do-while loop consists of the do keyword followed by the while loop. The code to be executed is inserted before the while loop, ensuring it runs at least once and checking the condition after execution. A typical application of the do-while loop is when you need to prompt a user at least once, like when entering a password. The user is prompted until the correct password is entered. Let's explore this with an example. To illustrate this concept, let's assign the variable total trash in room an initial value of 0. Add a print line statement to display I will take out some trash inside a do-while loop, which should execute until the value of total trash in room is greater than 0. But wait, since the value of total trash in room is not greater than 0, you should not get the display, right? But you will. Why? Well, a do-while checks a condition after executing the code. Want to test it? Observe, it executed the code. In this video, you learned how to apply while and do-while loop. You learned that a while loop runs if a Boolean condition is true. It is used for repetitive menus, and a do-while loop is used to prompt a user at least once. Iterative structures like menus are crucial to any software. They allow humans to interact with the program and dataset. Mastering the while and do-while loop is important whether you plan to develop user interfaces, manage databases, or implement real-time data processing. Congratulations on finishing this module on control flow, statements, and loops. Throughout this module, you explored foundational concepts that form the backbone of Java development, and you've gained a new understanding of some Java essentials. You've worked through a lot, so let's take a moment to recap what you've learned in preparation for the module quiz. In Lesson 1, you learned about conditional statements, like if and else. These are fundamental tools for executing decisions based on conditions in Java and will allow you to control program flow dynamically and responsively. Next, you moved on to techniques for manipulating strings. Through reading and practice, you learned about identifying, indexing, isolating substrings, and comparing strings based on specific criteria. These skills are essential for text processing, data manipulation, and implementing robust programming logic in applications. You furthered your knowledge of conditional statements by exploring nesting conditions. Nesting if statements within each other or inside else statements helps manage complex decision-making scenarios. This technique allows conditions to depend on other conditions, improving the flexibility and logic of your code. Then you explored logical operators. Logical operators reduce complexity and enhance code clarity by testing multiple conditions simultaneously. They provide a concise way to evaluate complex conditions, improving the readability and efficiency of your Java code. You also learned about switch statements, which offer a structured alternative to multiple if statements for handling multiple equality checks. They emphasize clarity, simplicity, and efficiency, especially useful for scenarios like menu options or state-based logic. Switch statements are foundational for managing diverse programming challenges efficiently in Java applications. Next, you explored the scanner class. Java's scanner class enables interactive programs that adapt to user input, improving user experience and decision-making. Knowing how to use Scanner effectively helps developers create applications that interact dynamically with users, making them responsive and adaptable based on input. In Lesson 2, you started exploring loops. The statements within loops define the actual tasks or operations that are repeated, making loops fundamental to a program's overall structure and logic. The for loop in Java consists of 3 parts: initialization, condition check, and iteration change. It is useful for executing a block of code for a fixed number of iterations based on a definite count. Remember that you use a for loop if the number of repetitions is defined before the loop starts. On the other hand, you found that while loops run as long as a Boolean condition remains true, making them useful for repetitive tasks where the number of iterations is uncertain. Notably, do-while loops ensure the block of code runs at least once before checking the Boolean condition, which is helpful for user prompts and menu-driven applications. You also discovered that strings and conditional statements, like if and for loops, can be used together to write concise and effective Java programs. Furthermore, using the printline method produces more readable output, improving the clarity and usability of your programs. Toward the end of this lesson, you learned how to manipulate strings by using nested statements to complete tasks, such as counting vowels and checking palindromes. Learning how to manipulate strings is crucial for text processing and application validations. Great job! These are valuable fundamentals that, when combined, will empower you to write more robust, scalable, and maintainable Java applications. Revisit an item if you need to refresh a concept before attempting the module quiz that follows. Good luck. I love sandwiches, especially ones with lots of cheese in them. Don't you? Imagine you're hungry and craving a delicious chicken and cheese sandwich. So you decide to make one yourself. How would you start? First, you gather all the ingredients, like bread, chicken slices, cheese slices, and some lettuce. This is like having a checklist of items you need before you start. Then you'd begin assembling the sandwich by layering the chicken, cheese, and lettuce between the slices of bread. Kind of like following a recipe to combine the ingredients properly. And finally, you'd place the finished sandwich on a plate and serve it. Then you can savor the delicious sandwich to satisfy your hunger. Did you notice that the whole process is divided into 3 tasks? Gathering ingredients, assembling the sandwich, and serving it. You could think of these tasks as methods when you talk in terms of a programming language. And just like you followed these steps to make a sandwich for yourself, in this video you'll learn how a computer program uses methods to perform specific tasks to achieve a goal. So both you and the computer can create something wonderful. Let's begin by answering the question, why use methods? Firstly, these tasks are smaller when compared to the larger process, therefore easier to understand and execute. It's make a sandwich versus gather ingredients, layer them inside bread, and serve. Which one sounds more clear? Next, they are manageable. Suppose you'd like to have ham instead of chicken in the sandwich. You just make changes to the ingredients and that's it. You're done. The next 2 tasks don't have to change. Finally, once these tasks are ready, you can perform them as many times as you or your computer wants. Meaning, once you've made a sandwich, you'll remember the recipe. You can then keep on making as many sandwiches as you want. Now that you are aware of the basics, let's code the sandwich making process using methods. You're already familiar with writing your code using the main method. Yes, main is also a method. It is a task for a Java program that is performed as soon as you run your code. A little secret for recognizing methods in a code is that methods always have a pair of parentheses suffixed to their names. Methods also have a pair of curly braces used to write the instructions for accomplishing the task. As you're about to create your own methods, you must move out of the main method. But you'll stay inside the main class because you cannot write instructions outside of a class in Java. So, make some space above the main method. You will create 3 methods because you have 3 tasks at hand. But how? There are a few things to consider that you will explore later in this course. For now, you'll mostly stick to how the main method is written. You'll only change the name from main to something meaningful, indicating the purpose of your method. Method names are essentially verbs because they indicate an action to be performed. So, your first method will be named gather ingredients. First, type public static void, then gather ingredients, followed by parentheses and curly braces. Press enter. There it is, your first method. You'll notice that gather ingredients does not contain spaces. That's Java's way of writing method names. If there's more than one word, the first word is written in small letters, and the first letter of every consecutive word is capitalized. Just as variables are named using camel case, so are the methods. For the second one, type public static void assemble sandwich, followed by parentheses and curly braces. For the third one, type public static void serve sandwich, followed by parentheses and curly braces. You also need to store the names of the ingredients so that you can check whether enough and accurate ingredients are available to assemble the sandwich. As there are 4 ingredients to be stored, you can use an array of strings. So, type static string, square brackets, name the variable ingredients, and add a semicolon to end the statement. Don't worry about the static. You'll learn more about this later. For now, just understand that you're writing static here because this variable will be used inside a method that also has static attached to it. Also, you need to store the readiness status of the sandwich. For this, you'll need a Boolean variable. Type static Boolean, name the variable sandwich ready, and add a semicolon. The skeleton of your program is now ready. You only need to fill it out with instructions. So begin by gathering ingredients. Inside the gather ingredients method, you'll populate the array and print that you have all the ingredients. Start by telling the program that the array will contain 4 ingredients. So ingredients equal to new string and 4. Then ingredients of 0 equals bread. Remember, arrays start at position 0. So the very first ingredient will be stored at index 0. And since this is a string array, the value goes inside double quotes. Now you'll duplicate this statement 3 times. You need to change the index positions and the ingredients now. So, 1 in place of 0 and chicken slices instead of bread. Next is 2, cheese slices, and 3, lettuce. Done. The ingredients have been stored. Now write a print statement, double quotes, and type all ingredients arranged. You have now defined the method. Now let's move on to assemble sandwich. First, you'll check the availability of the correct number of ingredients. In this case, that is 4. Inside the method, type if, and inside the parentheses of if, check the length of the ingredients array. So, ingredients.length, then equal 4. If the length is 4, you check if the ingredients are exactly bread, chicken slices, cheese slices, and lettuce in that order. So, another if, and you have 4 conditions, all of which must be true. So you're going to use the AND operator to combine the conditions. Here goes. Ingredients of 0. Now this is a string value, so you must use the equals method from the string class. So dot equals bread, then the AND operator. Ingredients of 1, dot equals chicken slices. Another AND, ingredients of 2, dot equals cheese slices. One more and ingredients of 3 dot equals lettuce. The condition is now complete. If all the conditions are true, you assemble a sandwich. So print line and type in a message saying, assembling the sandwich, and set sandwich ready to true. Else we will say print line and oops, missing required ingredients. Next is serve sandwich. For this, you check if the sandwich is ready. So, Inside the method, type an if sandwich ready. If it is true, you can print a message, serving the sandwich. Else you'll print, it's taking some time, please wait. That's it. You've defined all the necessary methods for making a virtual chicken cheese sandwich. Now let's make sure that these are executed. To execute a method, you must call the method, meaning type its name along with the parentheses wherever it is needed. In this example, you're going to call these methods inside the main method. Yes, a method can be called inside another method. So, going back to the main method, you'll gather your ingredients. Gather ingredients. Ensure that there are no spelling mistakes, followed by parentheses and a semicolon. The method has been called. Similarly, you'll type assemble sandwich, followed by parentheses, and serve sandwich, parentheses. Done. Now you can run the program by clicking the play button. The output is as expected. All ingredients arranged, assembling the sandwich and serving the sandwich. Observe that the main method is crisp, concise, and clear. This is the beauty of methods. Go ahead and compare it with any code that you've written so far. In this video, you've gained insight into how using methods adds clarity to your code. Here are some key points to take away from what you've learned. Firstly, each method represents a clear and precise step in the whole process, making it easy to understand and follow. Next, by breaking down the process into methods, you can manage each part independently. This advantage of methods is called modularity. And finally, you can reuse the methods as and when you want, without the need to rewrite the instructions, like creating loads of sandwiches just by calling a few methods in a loop. No need to worry about all the other steps. This advantage of methods is called reusability. Like making a delicious sandwich, using methods in your code makes the process clear, manageable, and reusable. Now you're all set to create your own recipe for any task you want your program to perform. Happy coding! Now it's time to explore arguments in Java methods. Imagine methods as your superhero sidekicks, each with a special skill. But just like any good sidekick, they sometimes need extra information to do their job perfectly. This extra information is called arguments. This seems like a good analogy to build a simple Java program. In this video, you'll explore how to implement methods with multiple arguments in a fun scenario, where you'll face off against a menacing villain. You'll have a sidekick method called calculate punch damage that determines how much damage the superhero's punch causes. Let's get started. First, open IntelliJ and click the plus button above the New Project label. In the resulting window, name your project Superhero Project. Select the language as Java and the build system as IntelliJ. For JDK, select 21 and tick the Add Sample Code checkbox if not already ticked. Next, untick the Generate Code with Onboarding Tips checkbox. Click Create and the project opens up with the main class. You'll be working inside the main class and outside the main method for now, so make some space above the main method. Now to code your sidekick, the method. Type in public static int calculate punch damage parentheses and pass an integer argument strength to represent your punching power. Yes, the arguments also have a type. The return type of the method is int because it calculates the damage caused as a number based on the strength of the punch and returns the same as a result. Notice there's a red squiggly line under the closing brace because the return statement is missing. Next, to calculate the damage, multiply the strength by 2 and store it in a variable, damage, and return the damage. This allows the code to accommodate varying rates of damage, depending on the amount of strength with which you punch. This makes the program more flexible. Notice there's a warning at line 3. To view the warning, hover over the variable name. It means that the variable damage is unnecessary, as it's only being used to store a result and return it. That could be done directly. IntelliJ is quite an intelligent integrated development environment, or IDE. It's suggesting to use inline variable instead. Simply click on that and voila, the code is sorted. Now let's begin equipping your psychic and examine arguments in action. To call the method and provide the argument, the main method comes in handy. Some variables are required here to store the initial health of the villain and your punch's strength. Delete the already written print statement and declare int villain health equal to 100 and int punch strength equal to 20. When you punch the villain, their health is going to reduce. The logic is to subtract the damage caused from the villain's original health and store the remaining health in a variable to display it later. Therefore, write int remaining health equal to villain health minus. Call your psychic, the method here, because it calculates the damage caused. Calculate, punch, damage. IntelliJ helps with code completion, so hit enter each time a suggestion comes up and equip the psychic by passing in the punch strength as the argument inside parentheses. The method calculates the damage and returns it in place of the method call. It's like saying the remaining health is equal to the villain's health, minus the value returned by the method. Here it would be 40, so 100 minus 40 is 60. Now, to display the remaining health, write a print statement and the message villain's remaining health, concatenation, remaining health. Next, run the program and the output is as expected. Just like a superhero's psychic can have different abilities, like a fire punch and an ice blast, methods can also have multiple arguments of various types, such as numbers, text, and more. Let's go about introducing the special attack psychic. This is a new method that calculates the damage caused by a special attack. First, type public static int and name the method calculate special attack damage. It will take two arguments, int strength, representing your base punching power, and string attack type, representing the type of special attack you're using, like fire punch or ice blast. Think of it as choosing the right tool from your psychic's attack kit. Initially, the damage can be kept equal to strength, and then it can be increased based on the attack type. So, int damage equal to strength, then an if statement, attack type dot equals fire punch. Make damage equal to damage times 3, else if attack type equals ice blast, damage equal to damage times 2, and return the damage. Next, let's equip for the attacks. Call the methods and provide the appropriate arguments. For calling calculate punch damage, strength is already declared as punch strength, so you can call the method calculate punch damage, open parentheses, and type punch strength. And to store the result, declare an int variable, name it damage by punch. Because methods don't care about argument names, they can be the same or different while defining and calling the methods. Now prepare for a special attack. To call calculate special attack damage, you again need the strength and also an attack type. So declare a string attack type equal to, say, fire punch. And call calculate special attack damage, pass in punch strength to represent the strength argument and attack type. Then store the result in an int variable, name it damage by special attack. Try changing the order of the arguments to this method. It gives a red squiggly line indicating that there is an error. Hover over the line and observe the error. It says permute arguments, meaning the order of the arguments is incorrect. The method expects an integer and then a string in the exact same order. So, you need to adhere to this requirement. And that concludes this introduction to arguments in Java. Let's explore some important points from the example that you should remember. Firstly, the method signature. It acts as a blueprint for your psychics. It outlines the expected arguments or tools, their types, and their order. Next, order matters. Don't mess with the psychic's attack kit. Methods have a defined order of arguments that cannot be changed while calling them. Messing up with the order will result in errors. Additionally, there's argument names or inside jokes for psychics. Remember that methods don't care about the argument names. Whether they're the same or different while defining and calling a method, it doesn't matter. Like the strength and punch strength in calculate punch damage are different, the attack type in calculate special attack damage is the same. And finally, there's the return statement, the psychic's trophy. Methods can return values, like a trophy after a successful mission. The return statement specifies the value the method returns. In this example, it's a number representing the damage caused. In this video, you learned that arguments are essential for Java methods to work effectively, and that they provide versatility to a method. The method signature is very important to follow. It identifies the method name, return type, and the number and type of its arguments. You also explored that arguments to a method must be provided in the exact order specified by the method signature. And finally, you learned that argument names inside the method don't matter. They're like nicknames. If you provide them in the correct order, the method works effectively. It's time to promote yourself from being the psychic to being the main hero of your programming story. Happy coding. Remember when you were battling those villains? You used methods as your psychics to handle your hero actions, and all the methods were written inside the main class. While it worked, what if you need to master new skills to conquer even stronger enemies? Sure, you could just keep adding methods to the main class, but it would become cluttered and hard to manage. Think of your program as a monster fighting game. The main class would be the game's control center. It is where you can call upon your abilities to fight the monsters and not define them. So, where should you define your superpowers? The answer is in a class. A class acts like a blueprint, defining your hero's characteristics and actions. Think of it like a dedicated training ground, separate from the main battle arena. Let's examine this hero class in more detail. First, open your superhero project in IntelliJ. You'll notice that the main class is already there. You only need to create a dedicated class for defining a hero. Right-click on the SRC folder on the left. Select New, Java class, enter the name of the class as Hero, and press Enter. Now your newly created class opens up. To identify your hero, add some attributes to the class. Every hero has a name, so type string name equal to hero. Every hero possesses strength and health, so simply write int strength equal to 20 and int health equal 100. Next, true heroes need powerful attacks, so for this you'll need a method. You already have one in the main class, so copy and paste it here. Remove the static keyword. Think of this static method as a punching bag training routine that's pre-built on your hero's training ground. Anybody can use it to practice their punches and determine the damage they cause. But a super strong hero might require a different training routine to maximize their potential. This is where non-static methods become important. Let every hero have their own punching bag routine. Remove the argument from the method because the strength variable is already available in the class. Therefore, it's not required as an argument. Next, copy the second method. Remove static as you might want to personalize special attacks for different heroes. With a non-static method, you can adjust the damage based on the hero using it. Next, delete the strength argument. The attack type must remain intact, as it is not available in the class and needs to be provided while calling the method. Now it's time to bring your hero to life with object creation. Objects are also called instances of a class. Therefore, the process of object creation is referred to as instantiation. Think of the hero class as an academy that details the curriculum for aspiring heroes. It doesn't represent a single hero. An object is like a hero who has graduated from the academy after completing the curriculum with flying colors. Let's take a deep dive into object creation. First, open main.java and delete all the methods. They're present in the hero class. Next, remove the code inside the main method. Type hero, followed by the name of your hero. For example, fire fist equal to new hero, a pair of parentheses and a semicolon. In this example, fire fist is a reference variable because it refers to an object. The new keyword tells Java to create a new object of the class mentioned right after it with parentheses, which in this case is hero. If this reminds you of a method call, you'd be correct. But here, the method's name matches the class name exactly. And you didn't code it. These methods are called constructors. When you create a class, Java internally provides one constructor without telling you, and its purpose is to create an object of a class. The constructor works its magic to bring your hero to life. Try printing its name on screen. Write a print statement, name of the hero, plus firefist.name. Yes, you can access your hero's properties by using the dot operator along with their reference variable. Now you can run the program and observe the output. It says name of the hero is hero because you stored it inside the variable. But don't worry, you can change it now. Before the print statement, type firefist.name equal to firefist. Now run the program again and observe the output. It is as expected. You can try changing the value of other properties too. Next, to call the methods, use the dot operator with the reference variable. To do this, type int punch damage equal to firefist dot calculate punch damage, then print ouch. Your punch caused plus punch damage plus double quote % damage. Now let's create one more hero. Type hero frost blizzard equal to new hero parentheses. Set its name frostblizzard.name equal to frostblizzard. Next, set its strength. Frostblizzard.strength equal to, let's say, 35. Now, frostblizzard.calculate special attack damage and pass ice blast as argument. Store it in a variable int special attack damage equal to and print your ice blast scorches for plus special attack damage plus double quote % damage. Finally, let's run the program and observe the output. As you can see, the damage is in proportion to the strength. Congratulations, hero in training. You've learned how to organize your code with classes and objects, keeping things clean and manageable. In this video, you learned that classes are the blueprints defining the characteristics and methods of an object. Objects bring classes to life. They help customize the characteristics and perform actions by calling the methods. You also explored how objects in Java are created using the new keyword and the constructor of the class. The purpose of the constructor is to create an object, and object names are called reference variables. Keep practicing by creating more classes and objects, and watch your skills grow. Happy coding, and may your programs always be powerful. Imagine the company you work for has just landed a contract with a large fitness group. As a new developer, you've been assigned to write some of the functionality for one of the new fitness apps. Your app needs to calculate various users' body mass index, or BMI. Where would you start? In this video, you'll explore exactly what to do to complete this task. You'll gain valuable insights into how grouping methods is a way to organize your code by creating a dedicated class with reusable methods. Let's get started by exploring how you can build your BMI calculator app. First, open IntelliJ and create a new Java project named Fitness App Project. Create the main class with the main method. You might write the logic for calculating the BMI directly into the main method. To calculate the BMI of an end user, you'll need two values, their weight and their height. These can be decimal point values, so create two variables of type double. For the first user, this is double weight in pounds 1 equal to, for example, 154.0, and double height in inches 1 equal to 70.0. Next, calculate the BMI as double BMI 1 equal to weight in pounds 1 divided by open parentheses, height in inches 1 times height in inches 1, close parentheses, then multiply by 703. This is the BMI formula used in the imperial system, when weight is measured in pounds and height is measured in inches. Now, for the second user, double weight in pounds 2 equal to 187.0, and double height in inches 2 equal to 74.0. Double BMI 2 equal to weight in pounds 2 divided by, open parentheses, height in inches 2 times height in inches 2, close parentheses, and multiply by 703. Finally, print the calculated BMI for both users. To do this, write a print statement, BMI for user 1 plus BMI 1, and, again, write a print statement, BMI for user 2 plus BMI 2. You'll notice how the BMI formula is repeated for both users. But what if you have many users? Writing the same BMI calculation for each user would be repetitive, inefficient, and it would make the code look messy. Also, what if the user requires you to use the metric system instead, which has a completely different formula? You'd have to make changes in multiple lines of code. You briefly touched upon the fact that grouping methods is a way to organize your code by creating a dedicated class with reusable methods. These are called utility classes. Now let's explore the benefits of grouping methods. First, there's reduced code duplication, meaning that you write the code once in your class, eliminate repetition, and make your code more streamlined. Next is improved readability. Having clean and organized code makes it easier for you and your teammates to understand. And finally, there's easier maintenance. Do you need to modify the BMI calculation? You can simply update the relevant method in your class. A single change for maximum impact. To explore how grouping methods can help, let's return to your project. Inside your project, create a new class called BMI Calculator. Next, create a method called Calculate BMI Imperial. This method requires 2 arguments, both of type double. As the calculated BMI is a double value, the method's return type must be double. It should look like this: public double calculate BMI Imperial, open parentheses, double weight in pounds, comma, double height in inches, and inside the curly braces, return weight in pounds divided by open parentheses, height in inches times height in inches, close parentheses, multiply by 703. Similarly, to accommodate the metric system, create another method, public double calculate BMI metric. The metric system measures weight in kilograms and height in meters. Therefore, type open parentheses, double weight in kilos, comma, double height in meters, and for the logic, type return weight in kilos divided by, open parentheses, height in meters times height in meters. Next, in the main method, delete everything and create an object of the BMI calculator class by typing BMI calculator equal to new BMI calculator. Now create variables. Double weight in pounds equal to 154.0. Double height in inches equal to 70.0. Double BMI imperial equal to BMI calculator dot calculate BMI imperial, and pass weight in pounds and height in inches as arguments. Similarly, create another set of variables for the second user's BMI to be calculated using the metric system. That is, double weight in kilos equal to 70.0, double height in meters equal to 1.82, double BMI metric equal to BMI calculator dot calculate BMI metric, and pass weight in kilos and height in meters as arguments. Finally, write the print statements for displaying both the BMIs. Print line BMI in imperial system plus BMI imperial, then print line BMI in metric system plus BMI metric. Now let's run the program, and you can see that the output displays both of the BMIs. There are many digits after the decimal because you use double values. This approach keeps your code clean, making it easy for anyone reading your code to understand the purpose of these methods at a glance. In this video, you learned that grouping methods under utility classes are a powerful tool to organize and streamline your code, making you a more efficient programmer. By creating reusable methods, you can save time, improve code readability, and enhance your project's maintainability. Remember, this is just a basic example. You can create many different utility classes with various functionalities to conquer repetitive tasks in your Java adventures. So, the next time you find yourself copying and pasting code, unleash your inner Java champion and create your own utility class. Imagine a brave hero in a game. In Java, this hero is represented by an object, a powerful tool for modeling real-world entities. In this video, you'll explore the components of an object and gain an understanding of these concepts to help you create robust and well-organized programs. So, let's dive into the exciting world of objects in Java, using the Superhero project as your guide. But first, what is an object? An object holds the data or properties that define its characteristics and the methods that define its actions. Now, let's examine how this applies to your code. You've already defined a hero class as a blueprint for creating the hero objects. This class is like a template for all the heroes you will create. It defines the characteristics and the abilities that every hero will have. Now it's time to break down the components of an object. Every object has 3 components: identity, state, and behavior. Let's examine each component in more detail. First, there's identity. When you create a hero object using the hero class, it gets a unique identity in your computer's memory. Think of it like giving each hero a distinct name tag and an address. Remember, in your code, you created hero objects, Fire Fist, and Frost Blizzard. Although they belong to the same class, they are separate objects with unique places in the memory. Do you want to verify this? Try printing the values of Fire Fist and Frost Blizzard. Type println, double quote, Fire Fist, plus Fire Fist, one more print, double quote, Frost Blizzard plus Frost Blizzard, and run the program. Notice the last 2 lines of output. When you print a variable, you get its value as output, and the same thing happens here. Fire Fist and Frost Blizzard are reference variables that store the reference to the object as a value, meaning their identity in the memory. Java represents an object's reference as an alphanumeric value. Therefore, here at 6E8CF4C6 indicates that this object belongs to the hero class and stays at address 6E8CF4C6 inside the memory. You'll notice that both values are different, which proves that both objects have a unique identity. The next component is the state. An object's state represents the current value of its properties. These are like the hero's unique traits. Your hero class has member variables such as name, strength, and health. These store the state of each hero object. When you create them, you initialize them with specific values. Therefore, as soon as you create a hero object, its state is initially defined by these values. You can customize these values for different heroes as you did in your main method after creating the objects Fire Fist and Frost Blizzard. You modify the name of Fire Fist using the dot operator with the reference variable. Similarly, you altered the name and strength property of the Frost Blizzard. So, the state of one object can differ from that of another, even though they belong to the same class. The final component is behavior. This refers to the actions an object can perform. These actions operate on the object's state or data to achieve something. For example, the hero class represents a hero character in your application. The methods calculate punch damage and calculate special attack damage represent the behavior of this hero character. These methods don't exist in isolation. They use the hero state, in this case its strength, to calculate the damage caused by the hero's punch or special attack. You'll notice that both methods calculate the damage caused by a hero's punch by multiplying its strength by a number. This means the behavior of causing the damage is dependent on the hero's state of strength. Therefore, if the strength is high, the damage caused will also be higher, and vice versa. In this video, you learn that each object has a unique identity in memory. For Java, this identity consists of the class name followed by an @ symbol and an alphanumeric value. This can also be called a reference of an object. You also explored how the state of an object is represented by the values of its properties stored inside the class's member variables. The dot operator enables you to customize these values for each object. Finally, you learned that an object's behavior is defined by its methods, which use its state to perform some action. Understanding these concepts will help you create robust and well-organized Java programs. Remember, objects are the building blocks of object-oriented programming, and mastering these concepts will make you a more superpowered Java hero. Ever get told you have your mom's eyes or dad's laugh? It's like a mini-me situation. That's because you inherit traits from your parents. Guess what? Code can inherit characteristics too. It's not your funny bone, but something just as cool: functionality. You've learned about the building blocks of code called classes. These classes create unique objects, like a car or a hero, that can perform actions using methods. This way of organizing code is a core principle of object-oriented programming, or OOP. In this video, you will learn about inheritance, a powerful concept in object-oriented programming, or OOP. Inheritance allows you to reuse code. Think of it as building on top of a basic structure and gradually adding more. Essentially, it's a powerful concept that lets you create new things by inheriting or reusing the features of something already built. Imagine you're building a car with a Lego set. You have a bunch of basic bricks and an instruction booklet for a car. Inheritance in code is like using this instruction booklet as a blueprint. It tells you exactly how to assemble the car's basic parts, such as the wheels, chassis, and steering wheel. These instructions are like methods in code that define how something works. Now imagine building your car using these instructions as a starting point. Your car might be a fire truck or a monster truck. It inherits all the building steps from the car, but can also have its unique features, like a ladder for the fire truck or giant tires for the monster truck. You could say your fire truck or monster truck essentially is a car with unique additions. This is a relationship is key for code reuse. You just focus on defining new, unique features and skip rewriting code for common functionalities. In coding, the general blueprint is called a superclass. It defines common properties, like the basic car structure, and functionalities, like the car's movement. Also, your new fire truck or monster truck, inheriting the car's essential properties and methods, would be called a subclass. A subclass inherits these features and adds its unique elements to create specialized versions. Remember the car class you created before? It had attributes defining a car's make, model, and color, along with accelerate and turn methods. Notice how these properties and methods are common to all vehicles worldwide. Suppose you want to create different types of vehicles, like a car or a truck. You can use inheritance instead of writing all these methods again. With this foundation in place, let's explore how you can create a new class called Vehicle that acts as a blueprint for all your vehicles in the future. Your class could be coded like this, holding the fundamental properties like make, model, color, and speed. Additionally, it could include the basic movement methods, such as accelerate, brake, and turn, that are common to all vehicles. It can also have a method to inform about the vehicle's current speed. Next, you can make car to be a subclass of the vehicle class. Here's how it's done in Java. The extends keyword ensures that all functionalities from the vehicle class are inherited. This means the car class can now use the properties and methods defined in the vehicle class without rewriting them. The car class can also specify some unique features, like an adjust seat method, which can change the position of the car's driver's seat using an adjustment value. For instance, if the adjustment value is greater than 0, the seat moves forward, and if it is less than 0, the seat moves backward. Otherwise, the seat position remains unchanged. Let's examine the main method. It first creates a car object, references GT, and sets its properties, make, model, and color to forward, GT, and black, respectively. Then it invokes the accelerate method defined in the vehicle class on the GT. This reuse of the accelerate method is possible via inheritance from the vehicle class to the car class. Overall, inheritance gives you several benefits: code reuse, scalability, and maintainability. This means that you don't have to rewrite common code, like the properties and movement methods, for each vehicle type. As you add more types of vehicles, you create new subclasses, like truck and sports car, keeping your code organized. And if you need to update the movement logic, you only change it in the vehicle class, which automatically applies to all subclasses. Now that you can create multiple vehicle type objects, like cars, it would be wise to have a garage to store and repair them, right? Let's explore how to do just that. The repair method here takes any vehicle object, so you can also pass a car object to it, because eventually a car is a vehicle. So let's create a garage object inside the main method and send your GT car for repair. To do this, you can call the repair method on your garage object using the dot operator and pass GT as an argument. This cool Java feature where you can pass a car object as an argument instead of a vehicle object is called polymorphism. It's another powerful OOP concept that builds on inheritance. Together, inheritance and polymorphism make your code more reusable, flexible, and easier to maintain. But more on this later. In this video, you learned about inheritance, a powerful concept in object-oriented programming that allows you to create new classes and/or subclasses by inheriting the properties and methods of an existing class or superclass. The subclass is a type of superclass with additional unique features of its own. By understanding the is-a relationship and the benefits of code reuse, you can leverage inheritance to create well-structured code. Thanks for watching and happy coding. Welcome back, aspiring programmer. By now, you've learned about the basics of inheritance and how constructors work with the super method. But there's more to inheritance than just creating objects. Have you ever wondered how you can enhance and reuse the functionality of your superclass? Well, this video is all about that. You'll explore how to call methods from a superclass within a subclass, making your code more efficient and versatile. Imagine you're upgrading a standard car into a high-performance sports car. You keep all the features of the standard car, including those inherited from the vehicle, and add some thrilling new capabilities, like a turbo boost feature that kicks in while accelerating. In Java, this is like creating a subclass that extends a superclass. To recap, here is your vehicle class with the common attributes: make, model, color, and speed. It has a parameterized constructor and methods like accelerate, brake, turn, and get speed. Now, here's your car class, which extends vehicle and adds its own attribute: seat position, and a method, adjust seat. Let's create a sports car that inherits from the car class and contains an additional attribute and method. This additional method will demonstrate how to explicitly call a superclass method, which is not a constructor, using the super keyword. Right-click on the SRC folder, select New, and then click on Java class. In the window that pops up, name your new class as Sports Car and press Enter. Use the Extends keyword and inherit your sports car from the car class. Define an integer attribute named Turbo Boost in the sports car class. This attribute simulates a high-performance feature that temporarily increases the car's speed significantly. Notice the red squiggly line? Hover your mouse over it. An error indicates that there is no constructor matching the superclass constructor. So, create a parameterized constructor with 3 arguments: type public sports car, parentheses, string make, string model, string color, curly braces. Now, use the super method to call the superclass constructor. So type super, parentheses, and type make, model, color to it. This will initialize the attributes in the vehicle class. You must also initialize the turbo boost attribute to 0 here. This sets the default state with no active boost when creating a new sports car. Type this .turbo boost equal to 0 and add a print line statement to print the sports car created. It's time to define a method to activate your sports car's turbo boost feature. This method will not take any arguments or return anything. So, on the next line, type public void activate turbo boost, parentheses, and curly braces. This method is supposed to accelerate the sports car and boost the speed significantly. Remember, your vehicle class already has a method named accelerate. You can call it here. Just type super.accelerate, parentheses, and semicolon. The super keyword is used to call the superclass's method explicitly. In this case, super.accelerate ensures that the accelerate method from the vehicle is executed. This is the intended behavior when activating the turbo boost in the sports car class. Now you can increase the value of the sports car's turbo boost attribute. Type this .turbo boost plus equal to, say, 50, semicolon. The boosted power must also be reflected in the sports car's speed. To do this, you can modify the value of the inherited speed attribute using the super keyword again. So, on the next line, type super.speed plus equal to turbo boost and semicolon. Now add a print line to display turbo boost activated. Utilizing the super keyword here allows you to use the inherited functionality while adding new behaviors specific to the sports car, such as increasing the turbo boost. It also allows you to access an attribute from the superclass and modify its value to suit the requirements of your sports car. To observe the action, you must create an object for your sports car using the main method and call the activate turbo boost method. So, open your main class. It already contains some code. You can comment it out by simply typing a double slash in front of each line. Now make some space after line 16. Type sports car space Ferrari equal to new sports car, parentheses, and pass double quotes, Ferrari as make, comma, double quotes, F8 Tribito as model, comma, double quotes, yellow as color, and put a semicolon after the closing parentheses. Now call the activate turbo boost method. Type Ferrari dot activate turbo boost, parentheses, and semicolon. Add a print line statement to display the Ferrari's current speed. Type system.out.println, parentheses, Ferrari.model plus double quote space is running at plus Ferrari.getSpeed, parentheses, plus double quote space miles per hour, and put a semicolon at the end of the line. Run the program and observe the output. The vehicle is speeding up, appears first, followed by turbo boost activated. This shows that the accelerate method was successfully called within the activate turbo boost method. Also, the fact that the F8 is running at 55 miles per hour confirms that calling the accelerate method increased the vehicle's speed by 5, and then the turbo boost value of 50 was added to make it 55. In this video, you learned how to call methods from a superclass using the super keyword. This powerful feature allows you to extend and customize inherited functionality, making your code more modular and reusable. Keep on experimenting with calling superclass methods and explore how you can leverage this feature to create sophisticated and efficient Java applications. Happy coding! Imagine a universal remote that controls your TV, sound system, and air conditioner. Each device responds differently to the power button, but the remote just sends a signal. This is similar to polymorphism in programming. In this video, you'll dive into another essential concept in object-oriented programming called polymorphism. By the end, you'll be able to identify what polymorphism is, understand its benefits, and be aware of its complexity. Polymorphism is a term derived from Greek, where poly means many and morph means forms. Thus, polymorphism essentially means many forms. Consider a musician who can play multiple instruments, such as guitar, piano, and drums. When asked to perform, you don't need to specify which instrument to play. In programming, polymorphism allows a single method to work differently depending on the object it acts upon. This means you can write code that works on the superclass type and automatically with any subclass type. Recall the repair method in the garage class explained earlier. This method takes a vehicle type of object as an argument. Because the car is a subclass of the vehicle, you could easily pass a car object as an argument to it. The repair method demonstrates polymorphism because it works on the superclass type vehicle, but automatically works with the subclass type car. Polymorphism in Java is implemented using method overloading and method overriding. Method overloading is like a Swiss Army knife. It has multiple tools, such as a knife, a screwdriver, and a bottle opener. Each tool serves a different purpose, but all are part of the same Swiss Army knife. In programming, method overloading allows a class to have multiple methods with the same name but different arguments, just like the Swiss Army knife has various tools for several tasks. Here you have a class called shape with two methods named draw. The first one takes no arguments and prints drawing a shape. The second takes a string argument and prints drawing a shape with color, followed by the color. The method name is the same, but the arguments are different. Hence, it demonstrates method overloading. The main method creates an object of the shape class, referenced as random shape, and calls both variations of the draw method. The second call to draw passes red as an argument. The output confirms that both methods are working as expected. The one with no arguments prints drawing a shape. The overloaded method that takes the shape's color as an argument prints drawing a shape with the color red. Method overriding is like hiring a new chef in a restaurant. The restaurant has a standard recipe for a dish, but the new chef decides to add a twist to it. The dish is still known by the same name, but has a different flavor. In programming, method overriding allows a subclass to provide a specific implementation of a method already defined in the superclass, just like the new chef's unique twist on the standard recipe. Returning to code, consider a class named circle that inherits from shape and rewrites the draw method without arguments to print drawing a circle. Observe the annotation at the rate override. It indicates that the following method exists in the superclass and is being modified in the subclass. Getting back to the main method, the shape reference bangle refers to the object of the circle class and calls the draw method without arguments. Yes, the superclass reference can refer to the object of its subclass. Observe the output. It says drawing a circle because the draw method with no arguments is overridden in the circle class to print. Remember that when you override a method in the subclass and call it using a reference to the subclass's object, as bangle here refers to the circle object, the overridden version of the method will always get called. Now that you've explored polymorphism and how it works, let's explore why it's such a powerful concept in programming. Understanding its benefits can help you write more flexible, reusable, and maintainable code, making your development process smoother and more efficient. Polymorphism enhances code reusability by allowing the same method names for different tasks, similar to a universal remote controlling multiple devices. It adds flexibility, enabling easy handling of new cases without needing new code, such as setting up a new device to work with the same remote. It also improves maintainability, as changes in the superclass reflect in all subclasses, like updating universal remote software benefiting all controlled devices. However, polymorphism complicates your code, requiring careful design and understanding of class relationships. Improper use can lead to code that is hard to understand and maintain. It's like a sophisticated universal remote with many buttons. If you don't use it carefully, you might press the wrong button and get unintended results. In programming, this means ensuring class relationships are well defined and methods are used correctly. To summarize, polymorphism enables objects to be treated as instances of their superclass, providing many forms of the same method. It includes method overloading, where methods have the same name but different arguments, and method overriding, where a subclass can redefine a method already defined in its superclass. While polymorphism offers significant benefits regarding reusability, flexibility, and maintainability, it also introduces complexity that requires careful design. It's like using a universal remote control, extremely powerful and convenient, but only if you know how to use it properly. Have you noticed how your phone's camera automatically switches between portrait, landscape, and night modes? This adaptability is like polymorphism in Java, especially method overloading, where methods share a name but differ in arguments. In this video, you'll explore how this concept makes your code flexible and powerful. As previously discussed, method overloading is a type of polymorphism that lets you create multiple methods with the same name but different argument lists. It's like your camera adjusting its settings to take the best photo based on the situation. Let's dive into coding this camera to gain a deeper understanding. The first step is to kick off a new project called Camera App. Start by creating the camera class. The camera usually captures photos, so you need to create a method that can be overloaded to handle various modes, such as portrait, landscape, and night, as well as different resolutions, such as 12 megapixels. Type, public void, take picture, parentheses, string, mode, curly braces. This method will simply print a message indicating the picture is being taken in the selected mode. So, type, println statement, double quotes, taking picture in, plus mode, plus double quotes mode. This version of the method allows you to adjust the camera's mode. Let's create another version that allows you to set the resolution. Type public void, take picture, parentheses, int resolution and curly braces. The resolution is a number, so the argument is of type int. To experiment, try writing string instead of int. Notice the error in both methods. This was not the case when int was written. Hover over the code at line 7, because that is the one you changed and caused errors. The error message indicates that the take picture method with a string argument is already defined in the camera class. Therefore, there can only be one version of the overloaded method, take picture, with a single argument for string type. This means that while overloading methods, if two versions of your method accept the same number of arguments, which is 1 in this case, the type of those arguments must differ. To rectify the error, change it back to int. Now, within the method, type system.out.println parentheses, double quotes, taking picture in, close double quotes, plus resolution, plus double quotes, space, megapixels. Next, create one more variation of this method that allows you to adjust the mode and choose the resolution as well. Type public void, take picture, opening parentheses, string mode, comma, int resolution, closing parentheses, and curly braces. Then, to define the method, type a println parentheses, double quotes, taking a, closing double quotes, plus resolution, plus double quotes, space, megapixels, picture in double quotes, plus mode, plus double quotes, space mode. Although these methods share the same name, each has a different argument list that makes them unique. This is method overloading in action. To grasp the process, start by creating the main method. Right-click on the SRC folder, choose New, and then select Java class. Name your class as main and press enter. Type main inside the class and IntelliJ's suggestion should be displayed. Press enter to accept it. This feature is known as IntelliSense. And just like that, you created your main method. Now, inside the main method, create an object of the camera class. Type camera, my favorite camera, equal to new camera, parentheses and semicolon. Then call all three variations of the method on this object individually. For the first one, type my favorite camera, dot, take picture, parentheses, double quotes, and let's say portrait. Similarly, on the next line, type my favorite camera, dot, take picture, parentheses, and make the resolution 12. To call the third variation, type my favorite camera, dot, take picture, parentheses, double quotes, landscape for the mode, and comma 24 for the resolution. When you call the take picture method on your camera object, Java decides, during compilation, which method to execute based on your arguments. This is called compile time polymorphism. Click on the Run button to execute the program and observe the output. When you pass a single argument of type string, Java recognizes that you're adjusting the camera mode. If you pass a single number, it understands you're setting the camera's resolution. Likewise, with two arguments, Java knows you're modifying both the mode and the resolution. This logic perfectly explains the output. In Java, method overloading is the first introduction to polymorphism. It allows a method to perform different tasks based on the arguments passed using the same method name. This concept is essential as it demonstrates how Java enables flexibility and adaptability in code. By mastering method overloading, you prepare yourself to understand method overriding. In method overriding, subclasses can redefine methods to suit their specific needs. This progression from overloading to overriding deepens your understanding of polymorphism and enables you to write more versatile and powerful code as you advance in Java. By now, you've grasped the fundamentals of inheritance and polymorphism, but you might be curious about how these concepts translate into real-world programming. Think about software for an online shopping platform, a social media app, or even a video game. These aren't just abstract ideas. They're the driving force behind many applications you use every day. In this video, you'll dive into how inheritance and polymorphism are applied in these scenarios. Let's begin by examining inheritance with a relatable example, an online shopping platform. Imagine you've been assigned the task of developing a system to manage various products on the platform. First, create a new Java project and name it Online Shopping Platform Simulation. Then create a general product class that can serve as a blueprint for all products on your platform. Once that's done, define two attributes, string name and double price, to store a product's basic information. Now, add a parameterized constructor to initialize these attributes. Type public, product, parentheses, string name, comma, double price, and the curly braces. To complete the constructor, type this.name equal to name and this.price equal to price. Finally, add a method to display product information. Type public void, display info, parentheses, curly braces, and add a println statement to display the product name and price on a single line, separated by a comma. Next, let's extend the product to create two specific types, electronics and clothing. Both inherit the product's common features, but also add their own unique attributes. Start by defining the electronics class, which extends the product, and add a new attribute, int warranty period in months, specific to electronics. Then add a parameterized constructor that accepts three arguments. Type public electronics, parentheses, string name, comma, double price, and comma, int warranty period in months. Now use the super method to call the constructor of the product class, ensuring that the common attributes are set. Type super, parentheses, name, comma, price. On the next line, type this dot warranty period in months equal to warranty period in months to initialize its value. Next, override the display info method to add warranty details to the output. Make space after line 7, right-click, and select the Generate. From the resulting pop-up, select the Override Methods option. Then select Display Info and click on the OK button. Notice that IntelliJ has defined the method for you with the annotation and a call to product's display info method using super. To print the warranty information, you only need to add a println, parentheses, double quotes, warranty, plus warranty period in months, plus double quotes, space, months. Now define the clothing class. Extend the product and add a new attribute, string size, specific to clothing. Then add a parameterized constructor that accepts 3 arguments. Use the super method to call the constructor of the product class and initialize size using this keyword. Override display info using IntelliJ as before. This time, display the size of the clothing item. Great! You've programmed inheritance by extending electronics and clothing from the product and tapped into the basics of polymorphism by overriding the display info method. Let's explore polymorphism further by creating a shopping cart class that can handle any product type. First, create the shopping cart class, then define an add item method, because you add products to a shopping cart, right? So it must accept any product as an argument. Type public void add item, parentheses, product. Name the reference as item and add curly braces. The method displays the product added to the cart and a confirmation message. So, call the display info method on the reference item. Type item.displayInfo, parentheses, semicolon. Add a println statement that says, item added to cart. When you call add item to add an electronics or clothing object to the shopping cart, polymorphism ensures that the correct version of display info is called based on the actual object type. Let's create a main class with the main method to test your code. Start by creating an electronic object. Type electronics laptop equal to new electronics, parentheses, double quotes, laptop, comma 1200, comma 12 as a warranty in months. Next, create a clothing object. Type clothing t-shirt equal to new clothing, parentheses, double quotes, t-shirt, comma 20, comma double quotes, and add M as size. Now create a shopping cart object. Type shopping cart, cart equal to new, shopping cart, parentheses. Call the add item method twice on the shopping cart object and pass the laptop and t-shirt objects. Let's run the code and observe the output. Here, polymorphism allows the cart to treat these different objects as products while still calling the correct display info method for each type. With this example, you've witnessed firsthand how inheritance and polymorphism work together in real-world programming. You started with a base product class and extended it to create electronics and clothing classes, each with its own unique attributes. Polymorphism then enabled you to override the display info method, customizing it for each subclass. This blend of inheritance and polymorphism allows you to write more flexible and maintainable code, making it easier to manage a variety of objects in real-world applications. If you're keen to experiment further, try adding more subclasses and observe how polymorphism and method overriding can enhance the power and manageability of your programs. Building on your understanding of inheritance and polymorphism, it's time to take the next step, designing a well-structured program that minimizes complexity. The secret lies in mastering polymorphic design. Let's dive in. Imagine you're creating an app to manage different media types like books, movies, and music. Without a clear structure, your code could quickly become tangled. Polymorphic design offers a solution, enabling you to keep your code organized and logical. It allows each media type to share common functionality while still maintaining its unique characteristics. Let's create a basic class structure to witness polymorphic design in action. Here's the media class, the foundation for all media types. It captures the common attributes all media types share, like title and creator. The media class includes the parameterized constructor to initialize its attributes and a play method that offers a basic action suitable for any media type. This serves as your foundation for creating more specialized media types. Next, let's examine how we can extend the media class to create specific media types, such as books, movies, and music. First up is the book class, which inherits from media and introduces an additional attribute, page count, an integer representing the number of pages. The play method is then overridden to simulate reading a book, demonstrating how polymorphism enables you to tailor behavior to fit the specific needs of each media type. Next in line is the movie class, which also inherits from the media class and adds a unique attribute, duration in minutes. The play method is overridden to simulate watching a movie, giving you details about its length and illustrating how polymorphism allows each media type to offer a tailored experience. And finally, here's the music class, which inherits from the media class and introduces a new attribute, genre. The play method is overridden to simulate listening to music with a focus on the genre. Once again, polymorphism shines by allowing you to customize behavior for each specific media type, ensuring each one delivers a unique experience. With all your media types now set up, this structure serves as a clear example of hierarchical inheritance in action. The superclass, media, is inherited by multiple subclasses, book, movie, and music, each adding its own unique attributes and behaviors. Now let's focus on how polymorphic design can simplify your program structure, especially when methods return objects. You can define a media library class with an add media method that accepts and returns a media object. Thanks to polymorphism, this method can handle objects from any subclass of media, whether it's a book, movie, or music, and return the object regardless of its specific type. Let's add one more method named playMedia to the media library class. This method is responsible for playing a media item. It leverages polymorphism to call the appropriate play method based on the specific type of media object. The media library class provides two key advantages. First, it promotes the separation of concerns by clearly dividing the responsibilities of adding media to the library and playing it, which enhances code readability and maintainability. Second, it offers flexibility. By keeping these concerns separate, you can modify how media is played without impacting how it's added to the library, and vice versa. Let's find out how this all comes together using the main method. In the main method, create 3 objects, one for a book, one for a movie, and one for music. Then, create an object of the media library class. Next, use the add media method on the media library object to add the book, movie, and music items to the library. Since the add media method returns a media object, be sure to store the returned value in a variable of the media type. Finally, Call the Play Media method to play each media item added to the library using the media objects returned by the Add Media method. This method automatically calls the applicable play method in the background based on the specific type of media object. When you run the program, 3 media objects, a book, a movie, and a music item, are created. Although these objects are instances of their specific classes, they are treated as media types thanks to polymorphism. Because the Add Media method is called 3 times, once for each media object, the method prints a message confirming that each media item has been successfully added to the library, as reflected in the first 3 lines of the output. Then, the Play Media method is called for each media item, triggering the play method specific to the class of the media object. The last 3 lines of the output illustrate the process. For instance, when the added book is passed as an argument, Play Media calls the play method from the book class, resulting in the output, Reading The Great Gatsby by F. Scott Fitzgerald with 180 pages. And just like that, you've learned how to use polymorphic design to create a logical and maintainable program. By building a media class and extending it with subclasses like book, movie, and music, you leveraged polymorphism to keep your code adaptable and scalable. The Add Media method handles different media types, returning them as common media type, which simplifies interactions while maintaining flexibility. This approach is key to building efficient and manageable software. The program also shows how polymorphism allows the Play Media method to behave differently depending on the object type, demonstrating the power and versatility of polymorphism in object-oriented programming. Think of the last time you used your phone. You could perform various functions like sending an email, calling, taking a photo, and more. You didn't need to know how it worked internally to use it. Consider Tony's robot, Psychic. Does Tony need to know its internal functionality to use it? Consider the BMI calculator you developed. Do users need to know what calculations are made, or can they just input their data and get the result? The answer to these questions is no. They don't need to know how it all works, only how to use it. This is all made possible because of encapsulation, which is the selective hiding or showing of properties and actions or methods. Encapsulation is crucial because it restricts direct access to some of the object's elements, which is a way of preventing unintended changes in data and functionality. For example, if anyone could access Psychic's internal state or operations, they could modify its workings without you knowing about it. Let's investigate an example with Psychic's battery recharge function. The code consists of a property called battery charge, a method, recharge battery, and another method, display battery level. Let's start with the method, recharge battery. Specific steps lie within the method. For example, plug into a socket. A loop is used to display the charge level, unplug the socket, and display a message that the battery is full. Say a team of coders needs to work on Psychic's programming. Whoever needs to use the recharge battery method in their code only needs to use its name without knowing anything about the steps inside it. This is an example of encapsulation of the method. You only need to call the methods into the main method after you create the class object. For instance, suppose the object name is Psychic object. You can use Psychic object dot recharge battery or Psychic object dot display battery level to call the appropriate method. You can also use encapsulation on the properties of a class by using access modifiers. The private access modifier restricts the visibility of class members. When a class's properties are in private, any programmer could modify it from outside the class. For example, they might set the battery charge of a Psychic robot to a negative value, such as -2, which is invalid and would cause the robot to malfunction. To stop this from happening, you can declare the property battery charge as private. This allows access only within the curly braces of the class Psychic. You can use public methods called getters and setters to ensure the property can only be accessed or modified from outside the class to maintain encapsulation. Getters allow you to read the values of private variables, while setters allow you to change the values of them. Let's explore this further. By convention, a getter method returns the value of a property. The method name is created by adding the prefix get before the property name, using camel case. The return type of the getter method is the same as the data type of the property. On the other hand, using the setter method, you set values to properties. You can add rules to ensure the correctness of the value. For example, you can ensure that if an attempt to set battery charge to less than 0 is attempted, it does not fall below 0. By convention, a setter should use the prefix set followed by the property name in camel case. In practice, each property should have the one corresponding setter method and one getter method. Think back to the examples discussed. Using your phone, operating Tony's Psychic, and the BMI calculator. In each case, you saw how encapsulation allows us to use these tools effectively without understanding their internal workings. This selective hiding or showing of properties or methods ensures that data and functionality are protected and used appropriately. As you move forward, reflect on how encapsulation can enhance the robustness and security of your programs. Consider how you can apply these principles to your own projects, ensuring that you protect and manage the internal state of your objects effectively. Do you have a secret? Maybe something you keep private or share with only a select few people? Of course you do. We all do. Some things we share in public, some we keep private, and some we only tell close friends or family. Similarly, Tony's robot Psychic has some secret internal information and functionality, as well as some public information. In other words, Psychic keeps some of its properties and methods hidden and shares some with certain people, like Tony or maybe a specialized robotics engineer. In this video, you'll explore access modifiers, a control mechanism that determines who gets to see and use certain parts of a program. Just like in real life, in programming, some things are public, some are private, and some are protected. In fact, public, which you've seen before, private, and protected are the actual keywords used for access modifiers. They can be used on properties and methods of a class. If used on methods, they do not change how the method works, but only modify the area from which it can be accessed. You'll see what this means shortly. Before you get stuck into access modifiers, you must understand packages. When you have classes that are related closely, like performing similar tasks, you put them together in a group called a package for easier management. In fact, you've already grouped methods together. In the object challenge earlier in Module 3, you grouped related methods together and put them into one class, a utility class. If we take it to the next level and group classes together with a name to identify the grouping, it is called a package. That's how packages work. Related classes are grouped together and put in a package. Packages are everywhere in Java. Ready-made classes like math, string, and system are placed in collections called packages. For example, the math class is in the package java.util, and the string class and the system class are in the package java.lang. When you use a class from a package, all the other classes in that package are identified as part of the same package by the package name. However, if you don't use any package name for a class, all the classes in the same folder belong to a special package called the default package. Let's return to Psychic. Let's imagine Psychic has a child class named NewRobot. Psychic also has a property called battery charge. What will happen with this property in the child class New Robot? Will the property be made public or kept private, or maybe protected? Let's see how each access modifier affects access to the property. If this property is public, it is accessible from within the class Psychic and by child classes like New Robot, whether they are in the same package or a different one. It's also accessible through objects of the same class Psychic from outside the class. On the other hand, if the battery charge property is private, it is only accessible within the scope, or curly braces, of the defining class Sidekick. This means no child class, including New Robot, has access to a private property. Neither do objects of the class created outside of the class Sidekick. During compilation of the program, if you try to access the property from outside the class, you will get an error indicating that the property has private access. If you use protected for the battery charge property, it is accessible by Psychic, its subclasses, child classes, regardless of package, and objects of the defining class in the same package, but not a different one. For instance, if you create an object of Psychic in the main method of the main class, this object will have access to battery charge. And that's access modifiers in a nutshell. Let's recap quickly. If Psychic's properties were accessible from anywhere, they would have the public access modifier. Public means that the information or method is available to everyone, like a public library where anyone can read books. Now, what about private? Private means that the information is only accessible within Psychic's own programming. It's like Psychic's personal diary, which only it can read. No other robot, even Psychic's child robot, New Robot, can access this private information. The protected access modifier is a bit special. It's like a family secret. Psychic can share this information with its child robot, New Robot, and other robots in the same family tree, which inherit from Psychic, but not with robots outside the family. It's like your own personal collection of books that you lend to friends or family members, but definitely not strangers. In summary, packages help organize related classes together, and access modifiers allow you to control who can see and use different parts of your code. Now you know that just like yourself, your program can have secrets and also share information. Happy coding! Suppose you want to make both a chocolate cake and a strawberry cake. Would you start from scratch each time for each cake? Isn't it better to handle the common tasks together? Cream the butter and sugar, add the eggs, mix in the flour and baking powder, and then add the milk. Now you have the base ready for the cakes. This generalized cake base is like an abstract class. It's not too appealing on its own, but you can divide it into two parts and mix chocolate into one and strawberry into the other. This way you use the same effort to create two specialized cakes with less work and repetition. It reduces effort by moving common tasks to a shared process. Abstract classes in Java offer a powerful way to design flexible, reusable, and maintainable code. By consolidating common functionality, you can ensure a consistent interface through abstract methods. In short, abstract classes are fundamental tools in object-oriented programming that cut down on code repetition. Let's bring this concept into a more familiar context. Remember Tony and Psychic. Although Tony is happy with the cooking, cleaning, and shopping that Psychic handles, Tony still has to drive Psychic everywhere. What if Tony could use a second robot to be a driver pilot, almost like a personal chauffeur? To solve this, Tony purchases a second robot named What a Driver, but needs help to program it. Now you will help Tony write a Java program to code the functionality of both Psychic and What a Driver. Just like with the cake example, it's not efficient to code everything twice. You need to move the common code to a common area. To do this, First, you must identify the common properties between Psychic and What a Driver. For example, both robots need to recharge, have a mode of operation, and provide a user interface. This raises two questions. Do you code the exact same functionality twice? And what if one robot doesn't implement a required feature, like the menu system? This would result in Tony being unable to interact with the robot then. In answer to question 1, you can avoid duplicating code by moving the common properties and functionalities to a parent class called Robot. This will be your foundation. As the Robot class will contain all shared properties and methods, it will have no specific functionality of its own. Now, what does anyone do with a robot that just charges and has a mode of operation without performing any tasks? Nothing, right? The purpose of the robot class is just to hold the common properties and functionality. That's where abstract classes come in. An abstract class serves as a blueprint, holding common code and ensuring certain methods are implemented in the subclasses. By declaring robot as an abstract class, you prevent an object of it from being created directly. Therefore, it only serves as a foundation for Psychic and What a Driver, and allows them to work with less code. You can implement extra specific properties and functionalities in the subclasses. Let's break this down further. The concept of an abstract class brings to the forefront two things. First, the abstract class is a placeholder for all the common code, properties, and functionalities. And secondly, if it only declares a functionality or method, it ensures that the method is implemented in the child classes. For example, the menu system has to be implemented in both the classes, which are the subclasses of the robot class. So how does this translate to Java? Let's start by creating the parent class robot and move the common code to it. To ensure an object of the class cannot be created, even accidentally, put the keyword abstract before the keyword class. This keyword abstract prevents an object of this class from being created. The second part is to ensure the functionality for the menu and the action to be undertaken is always implemented in the child classes, although the implementation may differ. You can do this by declaring abstract methods in the class robot. Let's start by declaring the method for the setChoice as a public abstract setChoice, open parenthesis, close parenthesis, semicolon. Next, you can declare the takeAction method as public abstract, takeAction, open parenthesis, close parenthesis, semicolon. Remember that an abstract method does not have the curly braces or body. If a method has no body, it must use the keyword abstract. This applies to the class as well. It is important to remember that a class may become abstract without any abstract methods inside it. Next, you can inherit Psychic and What a Driver from this abstract class robot. When you inherit from an abstract class, then you need to implement the abstract methods of the abstract methods, if such abstract methods exist. If you do not implement the methods, then the subclass would itself become abstract, and no objects of it can be created. Implementing the methods means giving the curly braces to the method. Java does not care whether there is code inside it or not. However, you have to include code if you want to perform an action. In this video, you learned how to use abstract classes to reuse code and force a subclass to implement a functionality by using abstract methods. Remember that the abstract class is the foundation that is used in all the subclasses, but never directly. In essence, abstract classes is not only a powerful way to design flexible, reusable, and maintainable code, but also a fundamental tool in object-oriented programming. By implementing abstract classes, you'll become an expert at reusing existing code. Tony has two robots you've been helping him program, Psychic and What a Driver. Psychic can cook and clean, while What a Driver can, you guessed it, drive you around and take you places. But what if Sidekick could also drive? And what a driver could whip up a meal. Sounds like a dream, right? Well, in Java, this can be achieved with a little help from interfaces. In this video, you'll explore how interfaces allow us to implement multiple inheritance in Java. But what exactly is an interface? An interface in Java is a type of class that's defined using the keyword interface instead of class. But there's a twist. Unlike classes, interfaces can only have abstract methods, which means these methods don't have any code inside them. Let's code an interface. Imagine you have an interface called fly. Instead of defining it like a regular class by writing class fly, open curly brace, close curly brace, you'd write interface fly, open curly brace, close curly brace. Simple as that. But something else needs to change here. You must change the interface name from fly to flyable. Now, why do you do this? It's all about Java's naming conventions. Using descriptive names and adding the suffix able when representing a capability or behavior is recommended. This helps make your code more understandable to other programmers who also use Java naming conventions. Here's something else to remember about interfaces. They can't have regular properties or instance fields. When you declare a field in an interface, it automatically becomes a constant that is public, static, and final, even without explicitly using those keywords. For example, if you declare a field in an interface as int max meters per hour equals 240, the field automatically becomes public, static, and final. In other words, a constant that can't be changed. Since fields in an interface are final constants, they must be assigned a value at the time of declaration. If not, the code will result in a compilation error. Inside an interface, all methods may only be declared and not implemented. You declare methods by putting a semicolon at the end and not curly braces after the method signature. At this point, you may be wondering how you implement interfaces. Let's find out. To use an interface in a class, you use the implements keyword after the class name, followed by the interface's name, and then the class's opening curly brace. This tells Java that your class will provide the actual code for the methods declared in the interface. If the class inherits from another class, the keyword implements should be written after the keyword extends and the name of the parent class. A class in Java can implement multiple interfaces. For example, a class could implement both flyable and walkable interfaces by separating them with commas. This is how you can give your robot both the ability to fly and walk. So far, so good. You've learned what an interface is and how to implement one or more interfaces. Now let's dig into some of the rules for implementing interfaces. Here's a key rule. Classes can only implement interfaces, not extend them. What does this mean? Remember that an interface contains only method declarations or abstract methods and not method definitions. When a class says it implements an interface, it is an agreement or contract that the class will define or give body to all the methods of an interface. Giving body or defining a method means adding curly braces after the signature of the method in the implementing class. Java doesn't require you to write any code inside the curly braces, but the method must include them to be considered implemented. If the implementing class does not fulfill the agreement of defining all the methods from the interface in the class, Java steps in with a penalty. It will mark the implementing class as abstract, which means you can't create objects from it. And if your class becomes abstract, you'll also need to add the keyword abstract before the class name. Enough about penalties. Let's learn more about interfaces, specifically inheritance. You saw earlier that a class cannot inherit or extend an interface using the extends keyword. However, one interface can inherit from another interface. If you implement an interface that inherits from another interface, you must implement methods from both the parent and child interfaces. For example, if Sonic Speed Flyable extends Flyable, a class implementing Sonic Speed Flyable must handle methods from both interfaces. In short, when a class implements an interface, it must implement all the methods in the inheritance chain of the interface or become abstract. Now, you might wonder, can you create objects of an interface? Yes, but not directly. You can only create an object of a class that implements the interface and assign it to a variable of the interface type. This variable can only call the methods defined in the interface. For example, if you have a class duck, which implements the interface flyable, you can always say flyable object equals new duck, open parenthesis, close parenthesis, semicolon. An object assigned to an interface variable can only access the methods defined in the interface, not those specific to the class. So if the duck class has a quack method, the flyable object wouldn't recognize it, since quack isn't part of the flyable interface. When you code this in IntelliJ, it will be flagged as an error, and if you try to compile it, you'll get an error message saying, cannot find symbol of method quack in type flyable in the variable flyable object. You also can't create an object of an interface directly using the new keyword, such as flyable object equals new flyable, open parenthesis, close parenthesis, semicolon. If you try, IntelliJ will flag it as an error, and running it will give you an error message saying, flyable is abstract, cannot be instantiated. This happens because interfaces contain abstract methods, meaning they're incomplete. If you could create an object of an interface, Java wouldn't know what to do when these incomplete methods are called. Makes sense, right? So why go through all this trouble? Well, because interfaces are powerful. They allow you to enforce the creation of certain methods across different classes. This can be incredibly useful when you need to ensure consistent functionality across various parts of your program. Later, you'll learn how interfaces work hand in hand with casting to create flexible and maintainable code. In this video, you learned what interfaces are, how to implement them, and some of the rules you need to follow when doing so. And there you have it. Interfaces in a nutshell. Whether adding cooking skills to your driving robot or teaching your flying robot to walk, interfaces in Java give you the flexibility to combine different abilities. So, if you have interfaces for cooking, driving, or flying, any robot can perform those actions by simply implementing the respective interface. Congratulations on finishing the object-oriented programming module. You're progressing quickly and smoothly through your Java journey. Keep it up. In this video, you'll recap and review all the exciting things you've covered, from methods to encapsulation. A moment ago, you were learning what a software developer does. Now you're learning the essentials of object-oriented programming, or OOP, and prepping for more complex coding challenges. Let's get stuck in. First up, in Lesson 1, you explored the keystones of object-oriented programming, classes and objects. A class serves as a blueprint, defining the attributes and behaviors, while an object is an instance of this class. For example, a car class defines the properties of a car, and individual cars are objects created from this class. You also learned about method signatures, which define how methods are written, including the return type, method name, and parameters. This was a lot of new code and techniques, but like the Java maestro you're becoming, you passed with flying colors. In Lesson 2, you upped your game and dipped your toe into inheritance and polymorphism. Inheritance lets a class inherit properties and methods from another class, encouraging code reuse and flexibility. For instance, a vehicle class can have subclasses like car and bike, which inherit common properties and methods. Polymorphism allows methods to behave differently depending on the object they're acting on. Polymorphism is implemented using method overloading and method overriding. Method overloading allows multiple methods to share the same name but have different parameters. In method overriding, a subclass provides its own specific implementation of a method that is already defined in its subclass. You also explored creating super and subclasses, tracing inheritance paths, and calling methods from the superclass in a child class. So far, so good. At the end of Lesson 2, you could create and utilize super and subclasses and implement polymorphism, all key concepts to prepare you for Lesson 3. Lesson 3 introduced encapsulation and abstraction. Encapsulation involves combining data and the methods that manipulate that data into a single unit, usually a class, and restricting access to some of the object's components. This helps protect the integrity of the data. You learn to implement encapsulation with accessors and mutators, commonly known as getters and setters. Abstraction allows you to hide complex implementation code and show only the necessary features of an object, simplifying the programming process. In other words, it allows you to focus on what an object does instead of how it does it. You also explored the benefits of using abstract classes as design tools. You explored interfaces to implement multiple inheritance that used a hierarchy with interfaces at the top and classes implementing them. So far, so theoretical. But you also engaged in some hands-on coding through the module, putting what you learned into practice. In Lesson 1, you created and used classes and objects to understand their practical application. You also refactored code into methods to make it modular and reusable, saving time and future effort. In Lesson 2's activities, you implemented inheritance and polymorphism to promote code reuse and flexibility. Finally, in Lesson 3, you applied encapsulation and abstraction principles to enhance code modularity. These activities helped clarify concepts and provided key practical experience. Working through the labs, you gained the know-how to apply object-oriented programming principles to real-world problems. By now, you should feel confident in your knowledge of object-oriented programming basics. The OOP skills learned in this module are invaluable as you develop more complex and efficient programs. Keep practicing and continue building on these foundational concepts. Remember, mastering OOP will significantly enhance your ability to write clean, efficient, and maintainable code. Can you believe you've reached the end of Course 1? Well done, and great coding. Although you're probably itching to start the next course, let's spend some time recapping the key takeaways from your Java journey so far. Cast your mind back to the beginning of your journey. Where did you begin? You started in Module 1 by dipping your toe into the world of software development. You looked at what it means to be a software developer, the roles and responsibilities involved, and the different specializations within the field. Remember your discussion on how software development isn't just about writing code. It's about problem solving, creativity, and continuous learning. One of the first significant concepts you tackled was the Software Development Lifecycle, or SDLC. You learned how every software project, from your favorite mobile apps to complex enterprise systems, follows this blueprint. From there, you jumped into the Java programming language itself, starting with the essentials: variables, data types, and operators. These fundamental tools let you handle data efficiently, enabling you to store, manipulate, and perform calculations on various types of information within your programs. You put these tools to work by creating simple programs that manipulate and store information, like keeping track of scores in a game or managing data in a small application. To finish Module 1, you spent time mastering strings. Strings are everywhere in programming, from user inputs to data processing. For example, you use strings to store and manipulate text, like names, addresses, and even entire sentences. You also explored methods to compare, concatenate, and modify strings, which are vital skills when dealing with any text-based data in your programs. Moving forward, you began Module 2, exploring control flow, the backbone of decision-making in programming. Using if, and else statements, you learned how to guide your programs through different scenarios. For example, you created programs that could decide actions based on user input, like recommending the correct ticket price for a visitor based on their age. But it didn't stop there. You also explored loops, for loops and while loops specifically, which help automate repetitive tasks. Your journey got even more exciting in Module 3, as you ventured into Object-Oriented Programming, or OOP. This is where you started thinking of your programs in terms of objects. OOP allows you to create more complex programs by organizing code into reusable and scalable components. By grouping related data and behaviors, OOP makes it easier to keep your code organized and ready to grow. To this end, you learned about classes and methods, which are the building blocks of OOP. Classes act like blueprints, and methods define the behaviors of your objects. You also covered inheritance and polymorphism, advanced concepts that help build flexible and reusable code. Inheritance lets you create new classes based on existing ones, while polymorphism lets objects of different classes be treated as instances of a common superclass, making your programs more adaptable and easier to manage. Towards the end of Module 3, you dipped your toe into encapsulation and abstraction. Encapsulation restricts access to an object's data, ensuring that it can be modified only through controlled methods. Abstraction, meanwhile, simplifies code by hiding complex implementation details and presenting only what is necessary to the user. By the end of Module 3, you were structuring your code to make it easy to manage and expand. To wrap up Course 1, you will apply everything you learned in a final project where you build a zoo management system using Java. This project is your chance to integrate concepts from each lesson into a fully functional application. Through this project, you will demonstrate your understanding of Java programming and showcase your ability to solve real-world problems using code. And after that, it's a wrap. You've come a long way, learning the essentials of Java programming. Remember, this is just the beginning. Keep practicing, keep experimenting, and don't be afraid to make mistakes. That's how you grow as a developer. Congratulations! You've shown remarkable dedication and effort to make it to the end of the course. You've mastered crucial skills and concepts related to Java programming, demonstrating your ability to build and maintain robust applications. By completing this course, you now have a solid foundation in Java programming, starting with an introduction to software development and the essential tasks of a developer. You followed the steps of the software development lifecycle, set up the Java development environment, and learned to write and execute simple Java programs. But that's not all. You also grasped the concepts of variables, data types, and operators, enabling you to manipulate data effectively within Java programs. And let's not forget about control flow mechanisms, such as conditional statements and loops, which are essential for implementing decision-making and iterative structures in your code. Building on this, you were introduced to Object-Oriented Programming, OOP, basics, understanding classes, objects, inheritance, polymorphism, encapsulation, and abstraction. Additionally, you learned how to model real-world entities using classes and objects, utilize inheritance for code reusability, and polymorphism for flexibility in method implementation. Finally, you explored class design, understanding the organization of classes into packages for modularity, and employing access modifiers to control the visibility of class members. By equipping yourself with these essential skills, you are now prepared to build robust and maintainable Java applications. You've done a great job so far and should be proud of your progress. The experience you gain shows potential employers that you are motivated, capable, and not afraid to learn new things. Moreover, you are one step closer to achieving Amazon's professional certificate in junior software development, which gives you a unique edge by equipping you with essential skills to kickstart your career in software development. This certificate not only prepares you for entry-level positions, but also demonstrates your proficiency and commitment to learning. But what comes next? While this marks the end of the course, it should not be the end of your learning journey. You can continue honing your skills and knowledge by registering for the next course in this program. Thank you for your hard work, and best of luck with the rest of your learning journey.
As you learned in the previous course, Java is used heavily in most daily interactions with computers, smartphones, and other internet-connected devices. When you interact with these devices, Java runs in the background, providing instructions that tell the devices what you want them to do through Object-Oriented Programming, or OOP. A good example is when you select Thumbs Up on a social media post, and the thumb emoji appears on screen. It's Java that bridges the gap between these two actions. But how can you program with Java to execute actions like this? In this course, you'll be introduced to Java programming concepts and techniques and learn how to use them to develop exciting applications. By the end of this course, you'll be able to organize and reuse code effectively to access it quickly when needed instead of creating it repeatedly. Apply object-oriented programming concepts within Java to design modular and scalable code that can adapt to your programming needs. And handle errors and exceptions in Java to create robust applications that won't run into performance issues, ensuring a smooth user experience. Let's take a few minutes to explore what awaits you. Before programming with Java, you must understand basic concepts like interfaces, abstract classes, and methods. A strong knowledge of these concepts will ensure you can manipulate objects to achieve your goals. You'll start developing your Java expertise by exploring concrete and abstract methods and learning how to create and use abstract classes. By mastering these basic concepts, you'll be ready to tackle all kinds of great Java projects. Designing a Java program also requires knowledge of building classes and organizing them into hierarchies, skills that you develop in this lesson and practice in a lab setting. Organizing your code using classes ensures you can quickly understand and amend it without issue. The final stage in mastering the basics of OOP is resolving a common problem in Java programming known as multiple inheritance, which you'll explore later in this course. Resolving this issue involves recalling your knowledge of interfaces alongside solutions like abstract classes. Having a good foundation in the basics of Java programming is a great start. But what happens when your programming doesn't work as intended because of errors? This is when you'll need to engage in defensive programming or error handling, the next stage of your Java education. Module 2 explores techniques for managing errors in Java programs. You learn to identify basic Java programming errors like checked and unchecked exceptions. Another skill you develop in this module is catching and handling different exceptions using try-catch blocks. Finally, a great Java developer protects their code using preventative measures such as avoiding, handling, and throwing catch-all, checked and unchecked exceptions. Once you've developed these integral skills, you demonstrate them by applying error handling techniques and defensive programming strategies in a lab. Having completed modules 1 and 2, you'll be adept at the basics of Java programming and producing robust code free of errors. However, Java programming involves working with lots of different types of files. So how do you manage these files effectively? Module 3 explores the skills by reviewing processes for executing file handling operations in Java. Gain experience in these skills, then read from and write to files by exploring code examples that you can test for yourself. As part of the next stage in your file handling education, you work with input and output streams and handle character encoding and binary file. You'll then put your new file handling skills to use by writing different file types in the lab. The module concludes with common file I/O operations every great Java developer needs to know. These include creating, deleting, renaming, and copying files using directories. It also covers the serialization and deserialization processes. You'll show mastery of these techniques by managing sample files in a lab exercise. Finally, you test your newfound skills with a practical project. You'll integrate everything you've learned in this course to upgrade the Zool program you built in the previous course to incorporate file I/O operations and serialize the application's state. Having completed this course, you will be able to program all kinds of incredible Java applications while ensuring your code is well organized, efficient, and error-free. Abstraction is everywhere, probably without you even realizing it. Take a social media messaging app, for example. Do you understand how it sends or forwards messages? Most probably not, unless you are a programmer. As an end user, you are unaware of all the technical details behind the app's functions. These details are hidden, allowing you to focus solely on messaging your friends without worrying about the underlying complexities. This hiding of details is what we call abstraction. In this video, you'll learn about abstraction, discover how abstract classes work, and explore how they use concrete and abstract methods so that you can hide the technical details of applications to ensure smooth experiences for your end users. Imagine a social media startup has hired you to develop the following buttons for their brand new messaging application: send message, like message, and forward message. This is a great opportunity to use abstraction, but it sounds challenging. Where do you even begin? The best place to start is by developing an understanding of abstract classes. An abstract class in Java is a class that cannot be instantiated. Such a class is declared with the abstract keyword. You can use the abstract keyword to declare an abstract button class to create the buttons for your app. This is followed by a pair of curly braces in which you insert the class body. The abstract class can have instance variables and methods like a normal class. These methods may be concrete or abstract. An abstract method is defined with the abstract keyword. It doesn't have a method body and must be overridden by its subclass. You'll find out more about how this works later. It is important to remember that if a class has at least one abstract method, it must be declared abstract. To demonstrate how this works, you can build on the abstract button class to include an abstract method called button press. This method is abstract. Its body doesn't contain any statements within curly braces. But what does the button press method do? This is where you add your concrete method, which defines the abstract method's purpose. Your app requires two concrete methods: setCaption and getCaption. When called, these methods set and retrieve a button caption. You're making good progress on your app. So far, you've created your abstract class, abstract method, and concrete method. Now you need to add a send button for your users to send messages. You can create a send button object using a subclass. However, it's important to remember that you can't declare an object of an abstract class. Java compiler immediately reports an error when you try to do so. As you hover the cursor on the error line, the following error message appears: abstract class is abstract, cannot be instantiated. So what's the solution? With Java, you can declare a class that extends the abstract class. In other words, you can create your required buttons as extended classes. A concrete method in the abstract class may or may not be overridden by the subclass. In Java, the is-a relationship type between classes implies inheritance. In your app, the send button inherits the abstract button class. This means the abstract button class becomes the superclass, and the send button class becomes its subclass. You also need to use the extends keyword to establish inheritance. When you declare any subclass that extends the above abstract class, Java warns you to declare it as an abstract or override the abstract methods. To ensure the send button class works as required, you need to establish the following instance variables. These are message, the message to be sent, and sent to whom the message is to be sent. Now you need to provide a concrete definition of the abstract method button press. You can do this using override. Override is one of the predefined annotation types defined in the java.lang package. It informs the compiler that the method overrides an element declared in a superclass. You can override the concrete method from the superclass if you choose to. Otherwise, the base class method will be used. Finally, you need to design your like and forward buttons. You can do this by designing like button class and forward button class subclasses. These provide concrete implementations of the abstract methods in the abstract button class. Great work! You've learned about abstraction, how abstract classes work, and how they use concrete and abstract methods. And, in doing so, you've helped to put together the foundations of a great social media messaging application. As a developer, you will often have to design multiple types of the same object, like buttons. With abstract methods, you can define a common interface that can be shared across all objects of the same type, like set characteristics for buttons. In this video, you'll learn how to build these common interfaces by exploring the advantages of abstract methods in Java. So, let's begin by asking what an abstract method is. An abstract method is a prototype declaration of the method without the body part. For example, you could use an abstract method that combines two numbers to find their total. Another example is the abstract draw method in a shape class. Subclasses like rectangle, circle, and others must implement this method, each providing its own way of drawing the shape. Similarly, the abstract compute_task method in a person class could be implemented by subclasses such as teacher, doctor, and so on, each calculating taxes according to their specific rules. Neither the abstract class nor the interface can be instantiated, but their subclass can be. A subclass that extends the abstract class or implements the interface must override it to provide a concrete definition of the method. So, why declare the method abstract if it must eventually be overridden? Why not declare it as a normal method in the base class? What is the advantage of using abstract methods? Let's try to understand with a few examples. When designing a hierarchy of related classes, you must start with a top-level view and consider the common minimum features. Take an animal hierarchy as an example. Every animal eats to survive, moves from one place to another, and makes a sound. All of these characteristics change between each type. Some animals eat meat. Others eat plants. Some walk, run, or crawl. And some animals bark, purr, or roar. So the abstract level functionality of the animal class includes three abstract methods: eat, sound, and move. Each animal is also identified by its subclass. For example, tigers, fish, and dogs are all types of animals. But in Java, you can't just state that X is an animal, as the concept of animal is abstract. Each individual example of an animal, like a tiger, must be defined as a subclass to distinguish it from all other examples in the animal class. This means that the animal subclass extends the animal class by giving a concrete description of the abstract methods: eat, sound, and move. This helps to distinguish each individual example. Any other animal subclass must override these abstract methods. Their implementation may differ. For example, in a fish class, the move method prints the message "a fish swims." Or in a horse class, the move method prints the message "a horse gallops." As you discovered earlier, an interactive button is an example of abstraction. In its most general form, a button is an abstract class with abstract methods that describe its purpose. For example, does it create text or an icon? These methods include examples such as setText, setIcon, or onClick. You first determine the common functionality of a button. Then you can declare a subclass as having its own implementation of the abstract methods. For example, you can create a simple button class as an extension of the button superclass. When clicked, the simple button prints the statement, "Hello World." Likewise, you can design a radio button or a toggle button class to perform a specific action that overrides the abstract methods from the button superclass. For example, you could include code that changes the state of the toggle button when clicked. In this video, you learned that the principle of abstraction is important when designing a hierarchy of classes with related functionality, like buttons for an application. Abstract methods help you to define a common interface. Even though each one may have a different implementation in different subclasses, as the animal and button examples emphasize. This knowledge is a great start to your career as a Java developer. Abstract methods allow you to save time coding by using inheritance to build variations of objects. When designing a car, a manufacturer begins by crafting a blueprint explaining how the different parts relate. Likewise, when designing a software application, you must start by designing a class hierarchy, identifying the classes, and determining how they relate. Over the next few minutes, you explore the basics of class hierarchy in Java by learning to identify concrete and abstract classes and the relationships you can establish between them. You'll be able to use these skills to create hierarchies for any kind of project. Mega Games, a leading video game company, needs your help to create a new racing game in which players race against one another in vehicles like cars, trucks, and motorcycles. You can help Mega Games design these vehicles using class hierarchies, identifying the concrete and abstract classes, and establishing the correct types of relationships between the classes. Let's begin by determining the relationships you can establish between the vehicles. The game lets players race cars, trucks, and motorcycles. These vehicles have common characteristics like wheels and engines, but also many differences. Some have larger wheels, and others have more powerful engines. Defining vehicle as a concept or an abstract class makes sense in this context. It represents the broader concept and defines the core functionalities that all vehicles share. However, since it's abstract, you can't directly create objects. Instead, you can create individual vehicle objects like cars, trucks, and motorcycles as concrete classes. Each of these classes can inherit attributes from the abstract vehicle class. However, they can also have unique attributes. For example, you can create a car class with a powerful engine and a truck class with large wheels. Now that you've identified your hierarchy's abstract and concrete classes, you must determine their relationships. Are they an is-are relationship or has-are relationship? In reality, a complex collection of classes involves both types of relationships. Let's identify instances of these relationships in your hierarchy, beginning with defining the relationship between the vehicle parent class and its child classes. As established earlier, a car is a vehicle, a truck is a vehicle, and a motorcycle is a vehicle. So, an is-a relationship exists between the abstract parent vehicle class and the different vehicles or concrete classes that inherit its properties. Now that we've established the is-a relationship, let's identify the has-a relationship. Each vehicle you design has parts like an engine or wheels. And each part can be created as separate class with attributes and methods. So, you can say that this is an example of a has-a relationship. In other words, each car has a part like an engine. In Java, a has-a type of relationship is called composition. A class is composed of something. In this case, the engine class is part of the composition of the car class. As you discovered, Mega Games wants different types of vehicles in its game. They want players to race everything from sedans to SUVs, pickup trucks, quads, and dirt bikes. In Java, the keyword extends establishes inheritance between a child and parent classes. You can use the extends keyword to extend the class hierarchy and add these different types of vehicles as subclasses through a combination of is-a and has-a relationships. This amounts to a hierarchy of classes or multi-level inheritance. In this instance, an SUV is a subclass of car, which is a subclass of vehicle. An SUV is not a truck. Now that we've designed a hierarchy by establishing its classes and relationships, let's code it. Start by declaring the abstract vehicle class with two instance variables, registration number, and the engine object, which in turn is an object of the engine class. The engine object is characterized by its attributes. The first of these is its type, which could be a V6 or V8. The second is its capacity, which might be a 2.0 or a 1.5. Or it could even be a vast 5.6 liter. Next, you must further extend the abstract vehicle class by creating the car and truck classes. Begin with the car class. The car class inherits attributes from the vehicle class, but it also has additional attributes like make, model, color, and year of manufacture. Although car is still an abstract class, it has not implemented the start engine method. You can repeat this process to establish abstract classes for vehicles like trucks and motorcycles. Next, you need to create individual vehicles or car objects. One of the big selling points of this game is that it lets players race sedans. So let's build one. The sedan class is a concrete class that extends the car class. It has additional instance variables like doors. This class must implement the start engine method. Here, it prints a message that the sedan with its details has started. Again, you can repeat this process to continue building different types of vehicles. Great work! You've designed a functioning class hierarchy for mega games, identifying the concrete and abstract classes alongside the is-a and has-a relationships. You can also use these concepts to design class hierarchies for an endless variety of other projects. A family is one unit, but different relationships exist between each member. For example, a son is viewed as a child in his relationship with his father, who is viewed as the parent. Likewise, in Java, different relationships exist between elements of a class hierarchy. Although each element is related, some are parent classes, while others are child classes descended from these parent elements. In this video, you'll learn how to design a simple class hierarchy by exploring how to identify elements and implement relationships between them. You've just been hired as a Java developer by a university to develop an application that provides details of teachers and students. You can use a Java class hierarchy to create the framework or blueprint for this application. You'll first need to identify different objects in the hierarchy and determine their relationships. Since students and teachers are both persons, you can begin by defining an abstract person class at the top of the hierarchy. All other classes like employee, student, and teacher are descended from this person class. The person class also has an abstract getDetails method, which the subclasses must override. When the getDetails method is called, each subclass prints the details of its attributes. Next, you need to create the date class. Remember that there is a composition relationship between person and date. In this case, each person has a date of birth. So the relationship between person and date is a has-a or composition relationship. The date class requires three integer values: date, month, and year, returned using the getDate method. The getDetails method is abstract, meaning it is meant to be overridden by the child classes. Great! Up to this point, you've defined the abstract person class. Since a student is a person, the student class inherits the attributes from the person class, and it may have its own attributes. It also needs to implement the getDetails method in the person class. Similarly, there exists an is-a relationship in employee and person. Employee is a person. The employee class may also have additional attributes. Since it subclasses the abstract person class, it must implement the getDetails method. The next step is to create these classes and further define their attributes and methods. Start with the student class as an extension of the person class. Begin by adding the instance variables subject and teacher. Then, provide a constructor for this class that returns the following information for each student: name, date of birth, teacher, and subject. Since it extends the abstract person class, it must override the getDetails method. The getDetails method in the student class prints the student information on the console window. You also need to define the getters and setters for the instance variables. Remember, there is a composition between student and teacher. The teacher class appears later. So you've successfully created the person and date classes and established a composition relationship between person and date. Next, let's create the employee class, where you will apply these relationships and add specific attributes and methods. This class is an abstract extension of the person class. However, different types of employees, such as teachers, clerks, and lab assistants, may exist. You will need to extend the hierarchy further to incorporate these different types. In addition to inherited members, you must add two variables: date of appointment for each employee's date of appointment as a date value, and salary as an integer value. You also need two abstract getter and setter methods for salary. Here, the setSalary and getSalary methods are abstract because the subclasses of the employee class will have different implementations. Now, you need to create the teacher class. The teacher class implements its ancestors' abstract methods, the employee and person classes. Note that the teacher class extends the abstract employee class, which in turn extends the person class, which is also abstract. Hence, the methods to be implemented by the teacher class also include the getDetails method from the person class. You also need to define a constructor for the teacher class that returns the following variables and related values: name, date of birth, date of appointment, subject, and qualification. Next, override the getDetails method in the teacher class to print out the values of the instance variables. The final task is to create the main class, a runnable class. Inside its main method, create three instances as follows: date 1 for date of birth, date 2 for date of birth of student, and date 3 for the date of appointment of the teacher. Then, declare a student and a teacher object. Call setSalary to assign a value to the salary variable. Call the getDetails method to retrieve the information for both the teacher and the student classes. Now, it's time to test the code. Fantastic! You've defined the person, student, and teacher classes, set up their attributes, and implemented the necessary methods. Run your application to return information for Madhavan, the teacher, and Belinda, the student. Great! The code works, and you have the records you need. You've successfully built a class hierarchy for the university. They can now use this hierarchy to retrieve information about the students and teachers. With your new knowledge of how to design a class hierarchy, you can expand your class tree by adding additional classes to the person class to help store and retrieve information about other employees, like secretaries or administrators. In Java, interfaces offer a standard way to connect different pieces of code, ensuring compatibility and seamless interaction. In this video, you'll learn how interfaces can be used to solve the problem of multiple inheritance. Super Games is developing a new game called Frog Quest, in which players can explore a mysterious forest as a friendly frog character. The frog must be able to crawl, jump, and climb when on land, and swim when the player enters the water. The crawl, jump, and climb movement types are characteristic of a terrestrial animal, whereas the swimming movement characterizes an aquatic animal. So when Super Games develops a frog class, it must inherit these movements from both the aquatic as well as terrestrial classes. So when Super Games programs the frog in Java, it must ensure it inherits from aquatic and terrestrial classes. However, this gives rise to the problem of multiple inheritance, which must be solved using interfaces. But what is an interface and how can it help to solve this issue? An interface is a useful feature in Java that defines a class's attributes and methods but doesn't provide an implementation. Instead, the interface is defined as a collection of abstract methods. Let's learn more about how interfaces can be used to solve multiple inheritance in Java. In object-oriented programming, the feature of multiple inheritance refers to a class subclassing more than one class. However, Java doesn't allow for multiple inheritance. But why is this? It's because it can cause a confusing situation called the diamond problem. Super Games' frog character is an excellent example of this issue. As you learned, the frog character requires the ability to move both as an aquatic and as a terrestrial animal. Super Games can create the frog class, which subclasses the animal class. This, in turn, overrides the abstract method called move. Next, the terrestrial animal class subclasses the animal class and implements the move method that tells the game when the frog must jump, crawl, or run. The aquatic animal class also subclasses the animal class and implements the move method. This tells the game that the frog needs to swim. But the Java compiler indicates an error if Super Games tries to build a frog class that inherits the aquatic animal and terrestrial animal classes. This error is revealed in the error message "class cannot extend multiple classes." This means the Java compiler can't resolve the conflict between move methods inherited from both classes. In other words, the compiler has encountered the diamond problem. Let's take a quick moment to find out more about this concept. The diamond problem is an ambiguity that arises when a single class inherits from two classes. In Frog Quest, the terrestrial animal and aquatic animal classes inherit from the abstract animal class, while the amphibian class, the frog, inherits from the terrestrial animal and aquatic animal classes. When mapped out in a diagram, these inheritances form a diamond shape. This gives rise to the diamond problem name. The terrestrial animal and aquatic animal classes may have different implementations of the abstract move method. This means that the compiler is now confused about which version of move should be copied to the amphibian class. The names of more than one class cannot appear in the extends clause. Any syntax attempting to extend classes B and C via class A is invalid in Java. So, how can Super Games solve this issue and create a frog that can move on land and in water? Java tackles the case of multiple inheritance with interfaces and a subclass that can implement the interfaces. Even though Java only allows a class to extend one superclass, it can implement multiple interfaces. An interface can be used to declare the abilities of a class. The interface, in turn, is defined as a collection of abstract methods. Super Games only needs to specify the method signatures, which include the method name, any arguments it needs, and the return type. Let's take a few moments to explore how Super Games can use this in Frog Quest. Java provides an interface keyword to define an interface. Remove the abstract move method from the animal class and include it in the movable interface. The implements keyword in a subclass's declaration indicates that it is responsible for providing a concrete definition of the abstract method in the interface. You can now declare a subclass that extends animal and implements movable. It needs to override the move method. When called, the move method displays a message that an amphibian animal jumps and swims. The subclass must extend its parent class and then implement an interface. A statement that doesn't do this raises the error expected at the extends keyword. It's also important that a subclass must implement all methods in a given interface. But what if a class only needs to use certain abstract methods in an interface? To learn more about how this works, let's develop an application for an educational institution that handles fees receivable from its students and salary payable to its employees, such as teachers and other staff. In this instance, the person class is the superclass for the student and employee classes. You must provide methods for computing grades and paying the school fee in a student class. There are also methods for calculating salary and tax in the employee class. But you can't place all 4 methods in a single interface. The student class only needs the first 2, while the employee class needs the other 2. To counter this situation, you can have 2 interfaces, a student interface and employee interface, one for each student and employee class. First, create the parent person class. Next, create the student interface. This has 2 abstract methods. Any class that implements this interface needs to provide concrete definitions. The compute grade method determines the grades. The pay fee method handles the fee payment process. The employee interface contains the other 2 abstract methods. The first is compute salary, which the employee class and any subclasses must implement. And there is also the compute tax method. A student is a subclass of person and implements a student interface. The student class defines a constructor for instantiating its object. It has also overridden the getDetails method to print the student details. Then you need to provide the implementations of the interface methods. Put appropriate programming instructions inside the compute grade method and define the pay fee method. In this instance, a simple print statement is used for the sake of demonstration. Similarly, the employee class extends the person class and implements the employee interface. The salary and tax computation procedure varies and can be a complex algorithm. However, the examples in this video are simplistic implementations for demonstration purposes. Next, consider Teaching Assistant as a subclass of the student class. This class already implements the compute grade and pay fee methods from the student interface. A teaching assistant also receives a salary in the form of a stipend. So, this class only needs to implement methods from the employee interface. A teaching assistant also receives a salary in the form of a stipend. So, this class only needs to implement methods from the employee interface. The teaching assistant is generally entitled to a fixed amount as a stipend and doesn't incur any tax. You should now understand how to use interfaces to solve multiple inheritance in Java. Great work! Keep learning about interfaces. You'll soon have seamless compatibility and interaction across your applications. After a tiring day, you relax at home, watching television. You pick up the remote and press a button to change the channel. You've just used the remote's interface to achieve the desired result. As a developer, the software applications you design will need to allow for many such practical interfaces. This video explores some examples of these and demonstrates how they are created in Java. The remote control you just used is an obvious example of an interface. Remote controls are common for devices such as televisions and sound systems. The remote control interface defines the essential buttons such as power, volume, and channel selection. This allows you to control different devices using a consistent interface. A smartphone is another type of interface. Regardless of the manufacturer, each one provides common features such as making a call, taking a picture, or sending a message. Do you use social media? If you do, when was the last time you tagged a friend? Once a post or message is created, buttons and icons allow users to tag friends or add images. Interfaces can be used to define the basic post-creation functionality, while each platform implements it with its own customization. If you've bought something online, then you've experienced another use of interfaces. E-commerce websites such as Amazon offer different payment gateways to customers to facilitate payment. A payment gateway is a platform, such as PayPal or Stripe, that acts as an intermediary in electronic financial transactions. Each gateway has its own processing logic but mainly involves two activities. First, authenticating and authorizing the customer, and then processing the payment. Java itself makes extensive use of interfaces in the standard library. The list, set, and map interfaces define common operations for working with collections of data. These are part of the collection framework, which you will learn about in the next course. Also, the comparable interface allows objects to be compared and sorted based on a preferred order. But for now, let's go back to those very useful remote controls. The buttons on your television remote control might change the channel or the volume. But consider the interface of apps such as a music player, a video player, or an image slideshow. What button functions do you think would be common for all of this? Typically, they would have a start or play button, a stop button, a pause or rewind button, and finally a way to move on to the next song, video, or image. You've recently started working with a social media company called ConnectSphere. You're part of a team developing the software for a new music player app. Your team leader has assigned you a specific task. You have been asked to write the interface code. The code that you build must provide the following three functions: play, pause, and stop. You decide that it should also include ways to control the volume or shuffle the track playing. Let's step through the code which will produce these elements in the correct order. The first step is to design an interface with abstract methods. Here, an interface called player contains three abstract methods: play, pause, and stop. Next, the player interface must be implemented. In this code, it will be implemented by a music player app. That app is represented in the code by the class called music player. Now, you must provide concrete definitions of the three methods. This next piece of code focuses on play. In this code section, the overridden play method contains a string argument that prints out a message for the user. It shows that a track is being played and also lists the track's name. Okay, now the user will have a way to play the track. What's next? Well, the user will certainly need to be able to pause or stop the track. This code defines a pause, and then a stop method to provide exactly that functionality. Now, let's consider what else might be needed. Well, you had already decided that the user should be able to control the volume and also not have to play the same song all the time. This code will shuffle the playlist, and this will control the volume. Well done! The music player class now has three methods from the player interface: play, pause, and stop. In addition, two more methods are defined: the shuffle method, that shuffles the playlist, and the adjust volume method, which controls the sound level. Now, how you can declare an object of the music player class and call its different methods in the main executable class. First, declare the object. Call the play method by passing the title of the track to be played. Adjust the volume of the player to 50. Pause the player app. Finally, stop the app. When you run the code, you are told that the track playing is live might be a deep fake. The volume is set to 50 and the music is first paused and then stopped. Well done! You can now hand over code that provides all of the interface functionality requested by your team leader. And you've added extra functionality to show your initiative. Interfaces are encountered in all areas of daily life. This video has demonstrated some practical uses of interfaces in real-world applications and how they can be implemented in Java code. Abstraction can be achieved in Java using both abstract classes and interfaces. Since both seem to have a lot of similarities, you might wonder, when do I use abstract classes and when do I use interfaces? In this video, you'll examine the difference between abstract classes and interfaces, comparing their features so you know when and where to use each. The social media group Connectosphere is creating a new music streaming service for its users. Coding the service with Java is a complex process requiring interfaces and abstract classes. But when and where should Connectosphere use each tool? Let's quickly review the basics of each, then discover how Connectosphere uses them to build its streaming service. An abstract class is like any normal Java class, but you can't instantiate it. It must be subclassed to use any of the assets, attributes, and methods in an abstract class. So, what purpose does an abstract class serve? The abstract class essentially defines the common structure of a hierarchy of classes. Interfaces, on the other hand, specify the functionalities a class must have. But they don't provide the implementation details. Interfaces tell a class that it can perform actions in the way it sees fit. Unlike abstract classes, interfaces might be implemented by completely unrelated classes. To understand these differences better, let's find out how Connectosphere uses them. As you just learned, you can't instantiate an abstract class. Instead, it defines the common structure of a hierarchy of classes. Each subclass includes additional functionality over and above what the parent class has. Connectosphere wants colorful, floating shapes on screen while music plays. An abstract class is perfect for this. An abstract shape class can act as a parent class for specific shape classes like circles and rectangles. However, the subclass has one constraint. If abstract methods exist in the superclass, they must provide concrete functionality. The shape class doesn't refer to any specific shape. It defines the abstract method's perimeter and area. So, the quadrangle subclass must implement this. This class can be subclassed into rectangle and square classes. Connectosphere doesn't require any quadrangle object. This means it can make this class abstract. This class readily inherits the abstract methods from the shape class. So, any subclass of quadrangle must now override the perimeter and area methods. Connectosphere can follow the same process to build a square class. Connectosphere now has a hierarchy of classes starting with the shape class. The abstract class serves as a base class with shared properties and methods. It works best with a clear is-a relationship between classes. Since it may contain some abstract and concrete methods, enforcing a partial contract with its subclasses is best. Unlike abstract classes, interfaces might be implemented by completely unrelated classes. Connectosphere can use them to let users interact with the streaming platform. It can code a generic controller interface for its platform with start, pause, and stop methods. The music player app implements these methods as per its functionality. Users can call the start method to start their chosen track, call the pause method to pause the track, and call the stop method to close the app. You might already be familiar with the diamond problem. This is when Java doesn't permit you to build a class by extending more than one class, as the compiler suspects ambiguity. However, Java has no problem if a class implements multiple interfaces. This is because multiple inheritance in Java effectively means subclassing a single parent class and implementing one or more interfaces. In ConnectSphere's platform, the buttons you just explored have two distinct categories of methods. One set controls the playback through play, pause, and stop. The other controls the volume level through increase and decrease options. ConnectSphere can code a media controller interface using abstract play, pause, and stop methods. It can also create an audio player class that implements the media controller interface to implement those abstract methods as follows. The play method starts playing the audio. When pause is called, the player pauses. And users can call the stop method to stop playing the current audio. You can't specify more than one class in the extends keyword in the class declaration. But with Java, you can combine interfaces. This means that a declaration like interface A extends B is acceptable in Java. Interface A could be extended to multiple interfaces, like C. It becomes a collection of abstract methods from interfaces B and C. ConnectSphere can extend interfaces on its platform. It starts by declaring the volume controller interface to specify the volume controller functionality. Since an interface in Java can extend multiple interfaces, ConnectSphere can create the audio controller interface that extends the media controller and the volume controller interfaces. It can combine the media controller and volume controller interfaces in audio controller, which the audio player class implements. The audio player class can also implement the combined audio controller interface. Since it's already overridden the methods from media controller, it can provide the functionality for the increase and decrease methods. ConnectSphere has already created the play method that starts playing the audio, the pause method that pauses the player, and the stop method that stops the player. The increase method increments the volume level by a value given as an argument. Similarly, when called, the decrease method decreases the volume by the specified value. All versions of Java from 8 onwards permit interfaces with concrete methods. This means methods with functionality. The interface can have a static method with a method body defined. The implementing class cannot override such a method. One problem with interfaces before Java version 8 is that adding a new method to the interface means providing its implementation code in the same class. As a result, any interface changes resulting from adding a method also change the implementation class. The Java 8 version overcomes this limitation. You can now declare a concrete method with a default keyword. The implementing class does not need to override it, but may do so if needed. ConnectSphere's streaming service interface can use both abstract and default methods. ConnectSphere can add video playback through an interface implemented by the video player class. ConnectSphere service must implement the abstract methods, but it can use the default methods as inherited. This class can be used in the application to let users play, pause, fast forward, and rewind videos. ConnectSphere has now built the basics of a great app using interfaces and abstract classes. You should now understand the differences between both and know when and where to use each. Great work! Well done on completing the first module in this course. You've hit the ground running and there are many more exciting discoveries to come. This video will cover the key concepts covered in each lesson. You'll be able to review and appreciate all the knowledge you've gained. Let's jump straight in. Your learning journey began with some basic building blocks of object-oriented programming in Java. You learned about abstraction, how abstract classes work, and how they use concrete and abstract methods. And it wasn't just theory. There was a demonstration of how this knowledge could be used to begin creating a great social media messaging application. This demonstration introduced you to the importance of the user interface in an application. To build on this, you then explored implementing interfaces more deeply. Using the framework of the same messaging application, you learned what interfaces are. You also learned how to create the abstract class. You discovered how to create an interface to send, react to, and forward a message. Finally, you learned how to implement the interface that had been created. Then, you put all of this new knowledge to work. You created code for an application that would allow users to draw shapes. Another key concept was how abstraction can remove complexities from the end-user experience. You discovered the signature of abstract methods and how they are used in a class hierarchy. Equipped with this foundation knowledge, you moved on to more complex concepts. You explored how to design flexible and reusable code, a skill that you can use in any project. First up was an in-depth exploration of the basics of class hierarchy. You learned to identify concrete and abstract classes and the relationships you can establish between them. You were shown an example of how to design a simple hierarchy and establish relationships. Then, you wrote your own code to create a similar Java hierarchy. This provided a framework for an application that could be used in a real-life situation. Another topic explored was the importance of class design and design best practices. The first of these was choosing a class name that reflects the class's purpose. Another tip is to use smaller classes with just one responsibility and follow the standard of encapsulation. Use the abstraction principle wisely in class design and only expose the user to what is relevant to them. You should also try to reflect the natural relationships between all classes. Classic design pitfalls were also discussed, and you found out more about what you should watch out for. The first was multiple inheritance issues. As you discovered, Java does not support multiple inheritance, which could cause the issue known as the diamond problem. You now know that you can create an interface containing abstract methods that the concrete class can implement. You also know that you can declare multiple interfaces if the implementing class doesn't need to override all the abstract methods in a single interface. Another theme presented was the real use cases of interfaces in software applications. Practical examples of using interfaces in real-world applications provided context. A practical demonstration followed. You were taken through the steps to create code that adds functionality to buttons. This specific example was for buttons to control a music player, but it probably sparked all sorts of ideas. No doubt, you were able to think of other situations where you could use this approach and create functionality for other devices. With this knowledge as a backdrop and foundation, you moved on to exploring more complex interface implementations. You learned about including interfaces in class hierarchy design. Then you had the opportunity to put all that you had learned into practice by writing code in a virtual environment. You began by refactoring the existing code to implement interfaces. You also created a working class hierarchy. This brought everything together. It incorporated many of the elements you had learned about, such as abstract classes, methods, interfaces, inheritance, and polymorphism. As you reach the end of this module, you have learned about advanced concepts of object-oriented programming in Java. This will become a key part of your software developer toolkit. You had an opportunity to create the type of code that you will be building in the future. You've shown your skill, and you're firmly on the path to becoming a creative programmer in Java. You wake up and check the time. To your horror, you realize that you slept through the alarm and you're now late. Perhaps you skip breakfast and rush to get ready and dressed. As you leave home to go to your course or work, you are fervently hoping that there will be no traffic jams or delayed trains. This is not only an incredibly stressful start to your morning, but it will possibly also affect your schedule for the whole day. Because sleeping through your alarm and then having to rush to get ready to leave doesn't happen every day, you could describe this kind of situation as exceptional. Exceptional events can happen during program execution as well. In this video, you will explore the concept of exceptional events in Java more deeply. As a developer, it is important to understand and recognize exceptional events. Knowing why they occur is central to being able to avoid them and prevent your program from crashing. So, what is an exceptional event in a program? It can be described as an unexpected behavior that occurs when your program runs or during program execution. The word unexpected means that it's not something that usually happens, but that it may have occurred for an underlying unknown reason. Just as unexpectedly waking up late could disrupt your entire schedule for the day, in programming, an exceptional event disrupts the normal flow of program execution. Before examining exceptional events, it is important to understand what the terms exception and error mean, both in general and in Java in particular. The term exception can be defined as leaving something out, not doing something on purpose, or not following a rule. An error, on the other hand, is a mistake or an incorrect action. In Java, errors and exceptions are related to some degree and are usually discussed together. However, it is important to be aware that there is a significant difference between them. You have already discovered that an exception in Java is an event or an abnormal condition that could occur during the execution of a program. It interrupts the normal flow of executing program instructions. Exceptions can happen during compile time and runtime. They can also occur in code written by developers. What is important to remember is that exceptions are conditions that can be recovered by using correct exception handling mechanisms. Errors, on the other hand, represent an abnormal condition that cannot be recovered. They usually indicate a serious problem that should never happen. Errors always occur at runtime and usually happen due to the lack of system resources such as memory. They are not meant to be handled in an application using exception handling mechanisms. It is crucial that developers are mindful of them while writing code. Another key concept to be aware of is that there are two classes that represent exceptions and errors. They are also named exception and error. Both error and exception are descendants of a class named throwable. This means that throwable is the superclass of all errors and exceptions, and it represents both. All three reside in a Java package named java.lang, which is the base package included by default in all Java source files. Depending on when an exception or an error occurs, they can be categorized as compile time or runtime. They are also known as checked and unchecked. Exceptions that occur during compile time are known as checked exceptions. This is because they are checked or known by the Java compiler. They may also be called non-runtime exceptions. Exceptions that occur during runtime are known as unchecked exceptions. Errors always occur at runtime, and because of that, they always fall under the category of unchecked. Just as exceptional events, such as sleeping through your alarm, happen in your daily life, exceptional events can also happen in a program while it is in execution. You now know some exceptional events in Java code are recoverable and some are not. Unexpected events will happen, but as you grow as a developer, you can sharpen your skills. With time and experience, you will learn to reduce errors, which are irrecoverable. And even though exceptions are recoverable, if correct exception handling mechanisms are used, you will also find, as your skills develop, that you are able to anticipate and avoid them. Everyone encounters unexpected events in day-to-day life. Some of these might have been avoided. For example, if you had checked the weather forecast before going on a walk, you might have remembered to bring an umbrella and wouldn't have gotten wet. On the other hand, some events can't be predicted. For example, a bus you hoped to take is cancelled by the bus company without any warning. If these types of events occur during the execution of a program, they are known as exceptions. When you are working as a developer, understanding this will help you to create more effective programs. This video provides you with more information on exception types and shows you how to differentiate between them. Have you ever been in an exam and wished that your teacher was sitting beside you to check your answers? With the teacher correcting things, there wouldn't be any mistakes in the answers you submit. As a developer, you are like the student and the compiler is like the teacher. It can check your code and indicate when something is not right. If the compiler is not checking the code written by you, then at runtime, the program can behave in an unexpected manner. In a previous video, you learned about how things can go wrong in a program and were introduced to the term throwable. As you discovered, a throwable represents any unexpected behavior or an exceptional event that occurs during program execution. A throwable can be an exception or an error. Errors and exceptions can fall under two major categories: checked and unchecked. In the case of exceptions, this categorization is based on whether it occurs during compile time or runtime. Exceptions that occur at compile time are known as checked exceptions. Exceptions that occur at runtime are known as unchecked exceptions. There's a specific reason for naming them in this way. In the case of checked exceptions, the compiler checks the code and signals that something is not right and that it needs to be handled. This means these types of exceptions are checked at compile time. In the case of unchecked exceptions, there is no checking by the compiler. So, if there is something that's not correct, it will pass on to the runtime. Then, at runtime, it explodes and everything comes to a standstill. These exceptions are usually caused by programming errors, such as invalid calculations or accessing objects that do not exist. Let's explore how these two exception types might appear in your code. So, what would be an example of an unchecked exception? What if in your Java program you want to open a file on your computer and read it? To do this, you would need to tell the program the name of the file along with its file extension and where to find it in terms of the folder that it lives in. But what if the file has been moved to a different location or deleted from your computer? This is an exceptional situation. This code is designed to open a file in order to read its contents. You'll learn how to work with files in Java later, but for now, remember that using file input stream is the most common way of accessing a file. When you try to create a file input stream for the file that you want to read, the compiler complains that something isn't right. The compiler understands that there is a chance that the file may have been moved or deleted from your computer. So an error is indicated in line 9 of the code where you are trying to create the file input stream. If you hover the mouse pointer over the error, a message appears. The message says, unhandled exceptions, java.io file not found exception. The compiler means that the file you are trying to open may be missing or not found in the location you specified. This is a typical checked exception. The exception is indicated clearly as java.io file not found exception. It also says that it's unhandled. You must handle this in some way because if you don't, the compiler won't compile this code. You'll learn how to handle this kind of exception in a future video. Now, let's examine an unchecked exception. This code is trying to divide 10 by 0. It reads, int number equals 10 divided by 0, semicolon. Since the result of dividing an integer value by 0 is infinity, Java obviously doesn't support it. So, while the compiler isn't currently flagging any issue, it will cause a problem. When the program is run, Java runtime notifies that a division by 0 has been attempted, and it also clearly specifies the line number where it happens. Also, the exception is indicated as java.lang.arithmetic exception. Even though the compiler would not force you to handle this, it should definitely be avoided by using correct coding and testing. You now clearly understand the difference between a checked and an unchecked exception. As you can appreciate, they both need to be handled effectively to prevent issues arising during runtime and interrupting the normal flow of your program execution. Understanding this will help you to write code that runs smoothly and does not create issues later on. Last week, after a long search online, you finally found the perfect gift for someone who is having a significant birthday. Excited, you clicked to add it to your shopping cart, only for the app to tell you that you can't because the item is out of stock. Now you have to find a different present. What a disappointment! But imagine if the ordering system didn't check that the item was in stock and let you complete the order. It might have been some time before you discovered that your carefully chosen gift wasn't available. Perhaps you might not have discovered it until it was too late to order something else. So how does the program handle your request in this situation? When you try to order an item that doesn't exist, you are attempting to perform an invalid operation. Similar situations can occur in programming, and they could cause exceptional behavior. Let's examine some of them. Mistakes do happen while writing code. Just as you end up getting things wrong in your day-to-day work, when writing code, you might end up doing the same. Mistakes in code can lead to unchecked exceptions. So what exactly are unchecked exceptions? Imagine you are writing code that has to divide one value by another when the program is run. That seems simple enough, you think. But what if you haven't allowed for the fact that one of the values could potentially change to 0? Division by 0 results in infinity. Obviously, infinity isn't a thing that can be represented in Java. When you attempt to perform a division by 0 calculation in a program, the Java runtime complains that it is not a valid operation. Developers can unknowingly introduce this and other similar mistakes into their code. Even minor programming mistakes can bring an application to a standstill by causing exceptions. The exceptions caused by such programming mistakes are known as unchecked exceptions. This is because the Java compiler doesn't check your code for these types of mistakes. Instead, it relies on you, the developer, to not make errors in the code. However, the Java runtime detects them and raises exceptions when you run the program. This causes your program to crash or break. This is why these exceptions are also known as runtime exceptions. Checked exceptions can be caught, declared, or thrown from code using the throws keyword which you learned about in a previous reading. However, the throws keyword is not meant to be used for unchecked or runtime exceptions. These exceptions are ideally meant to be prevented by developers with mindful coding and thorough testing. In Java, runtime exceptions are grouped into a hierarchy of classes. The runtime exception class is a subclass of the java.lang.exception class. It includes all the possible exception types that can occur at runtime. This means it is the parent or the superclass of all the different subclass types of runtime exceptions. Subclass types that represent common mistakes in code are arithmetic exception, null pointer exception, and finally, array index out-of-bounds exception. Now let's explore how these particular types of unchecked exceptions could occur in your code. An arithmetic exception occurs when an arithmetic operation results in an exceptional situation. Remember that divide by 0 scenario discussed earlier. Let's observe how that would create an exceptional situation. Create a new Java class named UncheckedExceptions1. Add a main method. In the main method, add code to divide 100 by 0 as int number equals 100 divided by 0. Nothing seems to be wrong here. The compiler doesn't complain about anything. Now run it. An exception is displayed in the console, indicating that an arithmetic exception has occurred in the main method due to a division by 0. In that example, you might have thought that the exception was obvious. However, imagine working with a large program that has many lines of code with many methods. In that situation, it could be difficult to spot this type of calculation error. Another type of unchecked exception is the null pointer exception. In Java, there are two kinds of memory, the stack and the heap. All variables that you create in your Java program are stored in stack memory. The heap memory is a special area of memory that stores objects. Variables can have a data type that could be primitive or non-primitive, which is also known as reference. A variable that has a reference data type would have an object as its value. Put simply, this means that the variable is referring to or pointing to an object. But what if it is pointing to something that is empty? If you try to access an empty reference variable and perform some operation on it, the Java runtime complains with a null pointer exception. This is like the ordering system telling you that the gift you tried to add to the cart is not in stock. This is how it really happens in your code. Create a new class named Unchecked Exceptions To. Add a main method to it. In it, create a string type variable called name. In Java, strings are treated as objects. So a string is essentially a reference data type. At runtime, the variable name is stored in stack memory. Assign a null value to it. This means that the variable name in stack memory is pointing to nothing in heap memory. In other words, it's empty. Now access the string and print its length by calling its length method. Run the code. Notice that there is a null pointer exception. This has happened because the string is null and doesn't point to anything. When coding with Java, it's important to remember that you simply cannot perform any operation on a string that's null. This video has explored and demonstrated the action of unchecked exceptions in your code. You now know that they exist to prevent unexpected behavior in your Java application due to programming errors or mistakes. This knowledge provides a strong foundation for how you will design your code. As you move on in your software developer career, you will gain experience and expertise in designing foolproof and effective code. Tony is planning to take another long trip across the United States. This time, he wants to travel in more luxury and is considering buying a new car. He asks his work colleague, a car enthusiast, for their recommendation. He hears about a particular make of car and its features, such as its engine capacity and how it performs with acceleration or braking power. In Java, an exception object also has characteristics and behavior. This information is extremely helpful when you are dealing with exceptions in your program. This video explains what an exception object is. It demonstrates how and when they are generated by Java. It also introduces you to significant and useful information that you can find contained within an exception object. The car recommended by Tony's colleague is an instance of the car class. Similarly, an exception object is an instance of an exception class. By now, you know exceptions in Java come in a hierarchy of classes. The throwable class is the base of the topmost level parent of all exception and error classes. Exception is a direct subclass of the throwable class. It contains all the different types of exception classes as its subclasses. Remember the previous example of your code trying to open a file that doesn't exist? When this exceptional event occurs, Java creates an object of the specific exception type and hands it over to the Java runtime system. That is what's known as the exception object. The type of an exception object is always the specific type of exception that occurs. You explored a couple of these, null pointer exception and arithmetic exception in a previous video. Another is the array index out of bounds exception. Tony's colleagues recommended a particular make of car, and all cars manufactured by that car brand would have similar features and capabilities. The topmost superclass of all of these exception object types is exception. As a result, all exception objects have a set of common characteristics, features, and behaviors. They give useful information about the exception, including its type, where it occurred, or the exact location in code, such as the method and the line number. You will find this information extremely helpful when you are debugging your program to locate and identify a problem. Let's examine the exception object using some code. This code defines an array of integers that contains 5 elements in it. Note that in line 7 you are trying to access the element at index 5. Run the program. This produces an array index out of bounds exception. This is because the array has 5 elements, which means the last index is 4. There is no 5th element, or index 5, in this array. Remember, computers start counting as 0, so the 5th element is actually position 4. Because what you are trying to do is incorrect, Java creates an exception object and hands it to the runtime system, which is what's printed in the console. The exception object itself contains a lot of helpful information. It shows what type of exception occurred and describes it. The exception object also shows the exact location in the code or the line number where it occurred. In this example, the type of exception is array index out-of-bounds exception. It also clearly mentions that the reason for the exception is the attempt to access a fifth element that is out of the boundary of an array whose length is 5. Then it gives the method in which the exception occurred, main method. It also displays the exact line number in the code, line number 7. Now, let's explore another example. This code declares a string variable named message. Remember, a string in Java is treated as a reference data type, so message is a reference variable that points to an object in the heap memory. However, in this case, message is assigned to null in line 5, which means it's pointing to nothing in the heap memory. Now run it. It produces a null pointer exception. This happened because you are trying to find out the size of the string by calling the length method, but the string isn't pointing to any value. The Java runtime flags the invalid action. Then it creates an exception object and hands it to the runtime system. The runtime system prints it out in the console. Notice that the exception again gives you important and useful information. It identifies the type of exception, null pointer exception. It shows that it happened because you tried to invoke the length method on a string object that's null. It also gives the location in which it occurred, the main method, line number 7. The information that these exception objects contain is extremely helpful when you are debugging your code to locate a problem. Understanding and utilizing exception objects is a fantastic tool in your programming skill set. When problems occur in a program, exception objects can save you valuable time in the debugging process and help you to fix issues quickly and efficiently. This video explained what an exception object is and demonstrated how it is created and used. It also explored how much information can be found within an exception object. You are now aware of how useful exception objects are. But how can you catch them in your code? Don't worry, you will learn how to do exactly that in the next lesson. You worked hard creating your first program, but when you ran it, it terminated with an error. A little disappointed, you sit back and wonder what the best way to handle this is. After a minute, the answer comes to you. Use a try-catch mechanism. You remember the example of a mountain climber using a rope and safety harness while they climb. You realize that you can use the try-catch mechanism as a similar safety device while you're sorting out the errors in the program. Over time, the code you create will be more creative and designed to carry out more complex and adventurous actions. Of course, the daring acts you perform in your code might cause some exceptions. You need to use some protective gear to keep your program safe and prevent it from crashing. This is precisely the role of the try-catch block. It is important to be clear on what each part of the try-catch block does. In your program, the try block should enclose the section of code that could cause an exception. The catch block should contain code that handles the exception. This is the code that needs to run if the exception occurs. As you know, exceptions can be checked or unchecked. Checked exceptions are flagged by the compiler. Unchecked exceptions, on the other hand, are only apparent at runtime. A key benefit of a try-catch block is that you can use it to handle both checked and unchecked exceptions. So, you are probably wondering, how exactly do I write this safety mechanism into my code? Here's your opportunity to observe how you create the try-catch block step by step. To begin with, this is how you can create a try-catch to handle a runtime exception which occurs during program execution. First, create a new class by right-clicking on package L2. Then select New and then Java class. Give the class name as try-catch-test. Press Enter to create the class. Next, type main to add a main method. Select the main method from the drop-down to create it. In this code, you will assume that you need to perform integer division in your program. To achieve this division, you will use the simple division operator /, which takes two integers as input and returns their quotient. You perform integer division in Java by using the division operator. To do this, first declare two integer variables. For example, type int a equals 10 and int b equals 0 on separate lines. Then type int result equals a/b to perform the division. Obviously, it's important that you know if what you've done is correct. The IDE indicates that there is a problem by underlining the code in yellow. To find out more, hover your mouse over the B marked with yellow. The Java runtime notifies you that this operation may cause an exception if you try to divide by 0. This happens because the denominator b is 0. It indicates that this situation should be handled. So what is the next step? This is the point where you can place this statement within a try block. Type a try block to surround the code. Try block is like the safety harness used by a climber. The line of code within it is now protected by the try block. Next, you need to add a catch block that says what to do in this case. The catch block should be typed below the try block. It should have one parameter, which is the type of exception that it handles, in this case, the arithmetic exception. While you could set a catch block to handle the overall superclass type exception, it is best practice to handle the specific subtype of exception if you know it. Type arithmetic exception as the exception class type and E as the exception object as a parameter to the catch block. The catch block can contain any code, but here it will be set to produce a meaningful message. Type system.out.println, open parenthesis, double quote, division by 0 is not allowed, exclamation mark, double quote, close parenthesis. Run the code again. Notice that instead of generating an error, the try-catch mechanism displays your message. This would mean that the program would not be interrupted and crash. This video has taken you through the practical steps you take to add a try-catch block to your code. By familiarizing you with these steps, it has shown you how to handle exceptions whenever they occur. When your program unexpectedly terminated, you were a little disappointed. Now, you can return to it, knowing that your knowledge of try-catch gives you a way to resolve the situation gracefully. You're making great progress with building fantastic Java apps and handling errors to ensure they run smoothly. But what if a single piece of code in your app causes more than one exception? Is it possible to handle only one single exception at a time? Can a single try block handle multiple exceptions? In this video, you'll learn how to use multiple catch blocks to handle different types of exceptions and how these can be used to manage specific exceptions. You've just finished programming your latest Java application. You're now ready to check for errors and resolve any emerging exceptions. But despite your attention to detail and great programming skills, there is always a possibility that your code might be prone to more than one exception. For example, consider this code extract. The second line causes an array index out of bounds exception. This is because it attempts to access index 5 of an array with only 5 elements, starting at index 0 and ending at 4. It also causes an arithmetic exception because it tries to divide 10 by 0, resulting in infinity. But you don't need to worry about this. Java can handle more than one exception at a time, right? Unfortunately not. Only one exception occurs at a given time, and only one exception handler is invoked to handle it. Well, if that's the case, then why would we need multiple catch blocks or multiple exception handlers? Because the same piece of code could cause different exceptions at different times, depending on the data it works with. Just like the one you've recently encountered. In this case, you can use a single try block with multiple catch blocks to handle all the suspected exceptions. Yes, you can write multiple catch blocks for a single try block. If an exception occurs, a catch block matching the respective exception is executed. So, how could you resolve the exceptions you encountered earlier? Let's begin by exploring an example of the syntax for a single try block with multiple catch blocks in Java. Start with the try block as usual and place a code that may cause an exception inside it. Then, include the catch blocks one after the other. Each catch block handles a specific type of exception indicated by its parameter. Here, each catch block should correspond to a different type of exception. Catch blocks should be ordered according to their specificity. A catch block for a more specific exception type should always be placed before the catch block for its generalized equivalent. For example, runtime exception is a generalized exception, and arithmetic exception is a specific type of runtime exception. So, if your code contains arithmetic exception along with other runtime exceptions which you may not be currently aware of, you can deploy multiple catch blocks to handle them. However, you must place the catch block that handles the arithmetic exception before the one that handles the general runtime exception. This is the correct way of handling multiple exceptions in Java. Let's surround the code with a try block. Then define two catch blocks, one to handle arithmetic exception and the other to handle runtime exception. Within the catch blocks, you can place the code to handle these exceptions. The exception object exception gives access to a method named getMessage. So, call the getMessage method on the exception object and print the message. This returns the message associated with the exception as a string. In your code, the arithmetic exception is thrown first with zero division because the assignment operator has right-to-left associativity in Java. This means that the expression is evaluated from right to left. Therefore, the output displays the message divide by 0. Let's try handling the general runtime exception before the specific arithmetic exception. Notice the error at line number 10. Let's find out the cause by hovering over it. It says the arithmetic exception has already been caught and suggests to delete this catch block. Why? Well, because runtime exception is the superclass of arithmetic exception, so we can handle the arithmetic exception also. This is why you must handle the specific exceptions before the general ones. However, if you are aware of all the exceptions that might occur in your code, you can avoid handling the generalized exceptions. For example, you could write a catch block to handle the array index out-of-bounds exception instead of the runtime exception in the previous code. Additionally, if you feel the need to have a catch block to handle general exceptions too, you can add one at the end, such as handling any runtime exception here. Great work! You've successfully handled multiple exceptions in the same code using multiple catch blocks. Your Java app should now run smoothly with no other issues. When working with multiple catch blocks, remember that each catch block can handle one specific exception type. And if more generic exceptions are required, order your catch blocks from most to least specific. Nobody likes to waste resources like electricity. Not only is it bad for the environment, but it costs money too. That's why you always switch off a light bulb or heater when you leave a room. You must also mindfully use resources like files or databases when programming. If your program heavily uses these resources, you must close them after your program is finished. With Java, you can use try with to close resources automatically when finished. In this video, you'll learn to identify use cases for try with resources, learning how they are structured and used. By the end, you'll be able to manage your resources more efficiently. Imagine a large software company asked you to develop a new file reading application. You're progressing well and ready to test the application by reading a test file. You've already encountered the finally block, which can be used with the try block to place any resource cleaning up code. For example, if you open a file for reading, writing, or a database connection, you can close it when finished in the finally block you place below a try block. But this is a manual effort. You might forget to close the file, leave it open, and risk using resources needlessly. The try with resources syntax is an alternative to the traditional try catch finally or try finally syntax. With try with resources, you are not burdened with manually closing the resources. It takes care of closing them once your code has finished using them. Any resources you declare within the try with resources block are automatically closed upon exiting it. So, it does the same job as the finally block in performing resource cleanup tasks, but more robustly. Let's take a moment to explore the process and syntax for creating a try with resource. First, create a try with resource class, adding a main method. Next, open the class using the try method. Then, declare a file input stream using the try method. The input stream must locate the required file by name within the directory. During this stage of the process, you might encounter exceptions or errors. For example, you might encounter a file not found exception or I/O exception. You'll need to resolve this using a catch block. Finally, add code to read the file's contents from the input stream. Once you've finished reading and closed the file, any resources you declared are automatically closed. This is a great high-level overview of the process. But what does it look like in action? Let's find out more by examining the syntax of a try with resource using a real-world example. The resource used in this example is a file from which the program reads data. A file input stream is used for this purpose. You will encounter file handling later on in this course. For now, you can simply focus on its usage with the try with resources. The first step is to create a new class named try with resources and add a main method. Make sure to add curly braces to your code. Now you need to open up the try with resources. Type try to configure the try method. Then open a pair of parentheses followed by a code block with open and close curly braces. Now you must declare the file input stream. You want to read the contents of a file named test.txt in the same directory. So, provide the file name and location to the file input stream. This opens up an input stream to the specified file. You can use the input stream to read the file's contents. It seems this has caused a file not found exception. This error indicates that the file you're trying to open may not exist in the given location. This common compile time or checked exception can occur when dealing with files. The compiler states that you must handle the exception before proceeding, so place a catch block below the try block. The catch block should handle the exception called file not found exception. So, place it in the catch parameter. The compiler suggests that you handle the more generic or top-level exception, the I/O exception. This is because the code you usually put within the body of the try block, which reads data using the file input stream, could also cause the more generic exception type, I/O exception. So, accept the suggestion and replace file not found exception with I/O exception. Add an exception handling code to the catch block and add code to print the exception message. You can then add the following code to read the file's contents from the file input stream a byte at a time until it reaches the end of the file, at which point the read method returns -1. The integer variable content holds 1 byte of data read at a time from the file input stream. The while loop loops through the file's contents until it reaches the end of the file. The file is read by calling the read method of the file input stream, represented by the FIS variable. Each round of while loop execution reads 1 data byte and stores it in the content variable. This continues until the end of the file is reached, which is when the read method returns -1. The value of the content variable is printed to the console. Before printing, the byte value is represented as a character. Great work! You can now read files without checking that you've closed your resources afterward. The try with resource block guarantees that the resources are automatically closed. Imagine you're visiting a pet store, admiring a tank full of colorful fish. A staff member is asked to catch a specific type of fish for you. They use a net, but without much care, they scoop other fish along with the one they intended to catch. The staff member chose the right tool, a net, but used it inefficiently. They must now spend extra time returning the fish they unintentionally caught to the tank and try again. In coding, catching exceptions is like using that net. When you write catch blocks, you are handling exceptions in your code. But if you're not careful, you might catch more than you intended. This brings us to the concept of catch-all exceptions. While the name might suggest that catching all exceptions is a good thing, it's actually something we want to avoid. Just like in the pet store, where you don't want to catch all the fish, in coding, you don't want to catch every possible exception indiscriminately. This video will help you understand what catch-all exceptions are and why it's important to avoid them. By the end of this video, you'll know how to write more efficient and clean code. Let's get started. You already know that Java's error and exception classes form a hierarchy. Here's a reminder of their hierarchy. The parent or superclass at the topmost level is throwable. Both error and exception are direct subclasses of throwable. The hierarchy is extensive, with many subclasses branching out from the main error and exception categories. For example, under error, you have specific errors like out-of-memory error and stack overflow error, which signal serious issues within the Java virtual machine. On the other side, under exception, you find more granular subclasses like file not found exception under I/O exception or arithmetic exception under runtime exception, which are more common in day-to-day coding. You can also download this diagram from the video resources if you wish to examine it more closely. When you are coding, your instinct may be to include a type high up in the diagram to catch everything that might come up in your net. If you catch generic types such as throwable and exception, you'll be catching all their subtypes of exceptions in a single catch block. It's like catching every type of fish in the net when you only want one specific type. Let's explore some examples. According to Java's exception hierarchy, throwable is the superclass of all exceptions and errors. Java allows you to use it in a catch block, but this is not recommended. Again, if you use a throwable in a catch block, there's a risk that your code will not only catch exceptions but also errors. You are not supposed to catch errors in your code. Errors are thrown by the Java virtual machine to indicate a serious problem exists, such as a stack overflow or an out-of-memory situation. Now, consider handling an arithmetic exception. If you specify the generic class exception in your catch block, you catch the arithmetic exception. But you also end up catching all other checked and unchecked exceptions. It's like catching every type of fish in the net when you only want to catch one goldfish. So how can you avoid these types of catch-all exceptions? What should you keep in mind? When creating exception handling code, avoid using throwable and exception as the exception class type in catch blocks. Instead, when handling unchecked exceptions, always try to find the class that best fits the exceptional event in your code. Finally, What should you do if you need to handle multiple exceptions in one try block? What would be the best practice? Place the catch block for the most specific exception in the try block first, followed by less specific ones. This helps ensure you only catch what you need to. In this video, you've explored what catch-all exceptions are, why they are a problem, and how to avoid them. Well done! As you continue developing code, remember to handle exceptions thoughtfully. Just like the staff member at the pet store who needed to focus on catching the right fish, you should aim to catch only the specific exceptions your code needs to handle. Doing so leads to smoother and more predictable outcomes. Imagine you're back in school and your teacher reviews your answers to tough questions. If there's a mistake, it's pointed out, and with some guidance, you fix it. Great! In programming, checked exceptions work similarly. They help you ensure your code is error-free by catching issues early on. In this video, you'll learn how to handle checked exceptions in Java, making your code more robust and reliable. Another way to think about exception handling is to think of it like a game of basketball. When a player catches the ball but can't shoot, they pass it to another player who's better positioned. Similarly, when an exception is caught in your code, it can be passed on to another method for handling. Just as the ball moves to the player most likely to score, exceptions move to where they can be best handled. Checked exceptions are a safety net that ensures your code can handle unforeseen issues, such as missing files or database connection errors. By now, you've encountered various exceptions in a variety of scenarios, like the I/O exception or the class not found exception. Let's dive into how to manage these exceptions using the try-catch mechanism to ensure your applications run smoothly. First, let's explore how to handle the class not found exception, which occurs when you try to load a class that isn't in the class path. Here, a red underline indicates where the exception occurs in the code. To handle it, surround the line of code in a try block as try followed by an open curly brace, the line of code, and then a closed curly brace. Next, you need to place a catch block below it with code to handle the exception. So, type catch, and then open a pair of parentheses to pass the parameter, and then open a pair of curly braces. You know by now that the catch block should define a parameter, which is the exception type it handles. In this case, it's a class not found exception. So, specify the exception class name within the parentheses and give the reference variable name, which in this case is E. The exception handling code should be placed in the catch block. Simply print out the exception message with a print line statement. Specify e.getMessage. Then run the code. It will print out a message from the catch block specifying the name of the class that was not found. This approach ensures your program handles the error gracefully without crashing. Sometimes, you might want to rethrow an exception to pass it up the call stack. Earlier, you learned the exceptions can propagate from a lower-level method to a higher-level one. For instance, if an exception occurs in method M1 and you don't handle it there, you can rethrow it to method M2, and so on, allowing the exception to be managed at a higher level. When an exception occurs, this call stack is searched for an exception handler, starting from the method where the exception occurred and proceeds through the call stack in the reverse order in which the methods were called. When a suitable handler is found, the exception object is passed to that handler or the catch block. Despite the usual behavior, if that catch block doesn't want to handle the exception, it can rethrow the exception using the throw keyword. Doing this propagates the exception to a higher level in the call stack. This technique is crucial when you need a more comprehensive approach to exception handling across multiple methods. Let's explore this with a code example. In this code, method 1 is where the class not found exception occurs. It's called within method 1, while method 2 is called within the main method. So the main method lies at a higher level of the call stack. Let's place a try-catch block surrounding the code that causes the exception in method 1. Now, without handling the exception in this catch block, you can rethrow it using the throw keyword. So, type throw and then the exception object E. You also need to declare that method 1 is throwing an unhandled class not found exception using the throws keyword. So, in the method signature, add throws class not found exception. There is a red underline in method 2, when method 1 is called. This is because the exception has been propagated to the next higher level of the call stack, which is method 2. Wrapping exceptions in custom exceptions allows you to provide additional context. For example, if you're handling a class not found exception, you can wrap it in a my custom exception to include more details, like the specific class path or configuration that caused the issue. This technique not only makes debugging easier, but also enhances the clarity of error messages. Let's explore how this works. Create a new class named myCustomException. It should be a subclass of the exception class. So type in extends_exception. Define a private string field named additional info. Add a getter method for it. Create a constructor that initializes the field additional info. The constructor should also accept a throwable, which is the original exception object. Invoke the superclass constructor within the constructor by typing in superThrowable. That's it! You got it! That's all it takes to implement your own custom exception class. Now, back to the code that causes a class not found exception. In the catch block, you can type throw my new custom exception. You can pass the exception object E and some additional info into it. Assume you have a connection URL. For example, if you have a database connection link like this, you can pass both the error message and the connection link to your custom error handler, which we'll call myCustomException. Finally, make sure to indicate that method 1 can trigger this custom error by adding throws myCustomException to the method declaration. By mastering checked exceptions, you are enhancing your code's reliability and making it more resilient to unexpected issues. Rethrowing exceptions helps you manage errors at the right level in your application, while wrapping them in custom exceptions provides richer, more informative error messages. Just like the basketball player passing the ball to the best shooter, you're learning to pass exceptions to where they can be best handled. Use these techniques to build robust, professional-grade applications that stand up to real-world challenges. Imagine you're developing an inventory management application that helps employees track stock levels. Imagine further that a customer wants to purchase a product and checks the stock availability, but because of an unhandled error, the application crashes. These types of scenarios can disrupt the user experience and even impact business operations, such as causing order delays. Fortunately, by effectively managing unchecked exceptions in your code, you can ensure that your application remains reliable even in the face of unexpected errors. In Java, runtime exceptions are known as unchecked exceptions. The compiler does not catch them, so the software developer must handle them appropriately. In this video, you will explore strategies for avoiding common issues like null pointer exception and array index out of bounds exception, which are subclasses of the runtime exception class. Let's start with the null pointer exception. This is a common programming error that can occur whenever an object is declared but not initialized. This is an unchecked exception because the compiler doesn't explicitly force you to handle it. Create a class named item and add a string attribute called name to it. Inside the main method, create an object of the item class and add a print statement to display the item's name as output. Imagine retrieving an item's name in your inventory system, which hasn't been initialized yet. Let's run the code to observe what happens. Yes, the name of the item is null, because you didn't initialize it. Let's change the print statement to display the name of the item in uppercase as item.name.toUppercase parentheses. Remember, the item object's name was not initialized yet, so when you attempt to run this code, it returns the null pointer exception with this message. It means the program tried to call a method on a null object reference, indicating it hasn't been initialized. Let's continue by adding another attribute price to the item class and define the toString method that returns the name and price. Inside the main method, declare an item object, and inside a print statement, call the toString method on the item object to print the name and price. Note that the object is still not initialized. You've already understood that running this code will again give you the null pointer exception as output. So let's handle this exception as a precaution. Use the try-catch block and put the object creation and print statements inside the try block. Also use the catch block to handle the null pointer exception. Type a print statement that says error : attempted to fetch a null item reference. Now, observe when the code is run that the code prints the message as per your instruction on the occurrence of the exception. Another common unchecked exception in Java is array index out of bounds exception. This occurs when you try to access an array element using an index that's out of the array's bounds. For example, if you have an array with 3 elements, accessing the 4th element will trigger this exception. In the context of the inventory management application, you might have an array storing item details. If you have an array with 3 elements, its lower bound is 0 and upper bound is 2. Trying to give the index beyond these 2 bounds results in array index out of bounds exception. Let's explore this in Java, and let's say our inventory management system is for books. In the item class used in the previous example, let's add a constructor to initialize the object's name and price attributes. Now, in the main method, declare an array of item class with a size of 2. Initialize the 2 elements in the array with 2 products, pen and book, with 10 and 100 as price respectively. Define an integer variable named index to store the array index you want to access, such as 1, and add a print statement to display the item details at this index using the toString method. Run the code and you should get the name and the price of the book as output. Now change the value of the index variable to 3 and run again. Since this index is out of bounds, you should get array out of bounds exception being thrown by Java. To catch this exception, surround the variable definition and print statements with the try block and use the catch block to handle the array index out of bounds exception. Type a print line that says error : the given index is out of bounds. Run the code and you should get the message as output. In real-world applications, effectively managing these exceptions can significantly enhance the user experience. For instance, it's crucial to ensure users don't encounter crashes when searching for products or adding items to their cart. Great job! You've taken important steps to make your code more resilient by learning how to handle unchecked exceptions. In this video, you've learned the importance of handling unchecked exceptions in Java. You've also learned that all the unchecked exceptions are runtime exceptions. That's because they don't violate any Java-specific syntax rules. Addressing the null pointer exception and array out-of-bounds exception ensures your application remains robust and user-friendly. Remember, unchecked exceptions can be managed effectively with try-catch blocks and by providing proper conditional statements. Congratulations on completing defensive programming error handling. It focused on the typical errors and exceptions that can occur daily in Java. But great news! What you've learned in this module will have equipped you to recognize them and to deal with them. Just like the climber mentioned in an earlier video, you have successfully worked your way to the summit. Let's review the route you've taken and recap the concepts and techniques you've learned along the way. At Base Camp in Lesson 1, you were introduced to the concept of exceptional events that can happen in program execution. These are the unexpected behaviors that can occur when a program runs. As a developer, it is important to understand and recognize exceptional events. Knowing why they occur is central to being able to avoid them and prevent your program from crashing. You learned that these exceptional events can be defined as exceptions or errors. They are both subclasses of the throwable class. Exceptions, also known as checked exceptions, can be caught by the compiler and recovered by using correct exception handling mechanisms. Errors, on the other hand, are not caught by the compiler and always occur at runtime. They are not recoverable and are also known as unchecked exceptions. You started to climb a bit higher now. You learned that checked exceptions can be caught, declared, or thrown from code using the throws keyword. Exceptions can also be unchecked, which means that they are not caught by the compiler but appear at runtime. You observed a practical example of a divide by zero error scenario, generating a Java-lang arithmetic exception at runtime. These types of unchecked exceptions do not need to be caught or declared. The compiler doesn't force you to catch them, but their occurrence causes abnormal termination, which could be damaging. Hence, they need to be handled with efficient coding. A lookup sheet for exception types will be a useful resource in the future. It will allow you to check exception names and confirm whether they are checked or unchecked. But you also discovered another useful resource. The information embedded in every exception object can help you debug your program. You were also introduced to the try-catch block, which you can use to gracefully catch and handle an exception and prevent program interruption or termination. The try block encloses the code that might cause an exception, and the catch block is what performs the actual exception handling. Lesson 2 emphasized the importance of catching specific exceptions to handle them appropriately. It focused on handling exceptions in more complex scenarios. It began by using multiple catch blocks to handle different types of exceptions. You are also given a step-by-step demonstration of the appropriate syntax for a single try block with multiple catch blocks. Next up, a new concept, the finally block. As you discovered, the major benefit of the finally block is that its code is always executed. A finally block will always be executed after a try block regardless of whether an exception was thrown or caught. You now know that finally blocks are ideal for cleaning up code that performs actions, such as closing open files or database connections. It could also contain important information, such as status messages. And there is no danger that the code will be bypassed. Next, you learned about the concept of try with resources. The try with resources syntax is an alternative to the traditional try catch finally or try finally syntax. As you know, the finally block can be used to close files and other resources. But any resources declared within the try with resources block are automatically closed upon exiting it. So it does the same job as the finally block in performing resource cleanup tasks, but more robustly. Then you had the exciting opportunity to put what you had learned about try-catch blocks into practice in your virtual lab environment. You were asked to make existing code error-free using try-catch blocks. Well done on successfully meeting that challenge. You were now 2/3 of the way up the mountain. Lesson 3 of this module focused on preventative measures and best practices. You already knew from Lesson 1 that error and exception are both subclasses of the throwable class. But now you were introduced to the larger hierarchy of subclasses that branch out from the exception and the error classes. If you catch generic types such as throwable and exception, you'll catch all their subtypes of exceptions in a single catch block. Also, if you use throwable in a catch block, there is a risk that your code will not only catch exceptions, but will also catch errors. And catching throwable doesn't give you the exact reason for the exception. This catch-all approach is not the best practice and is definitely not recommended. Another technique introduced was rethrowing. As you discovered, this is a useful approach when a method is not equipped to handle an exception. Using the throw keyword propagates it up the call stack until it finds a suitable handler. This is a more comprehensive approach to exception handling across multiple methods. Wrapping exceptions in custom exceptions was also explored. Again, keep best practices in mind. Rethrowing exceptions helps you manage errors at the right level in your application, while wrapping them in custom exceptions provides richer, more informative error messages. Finally, you put everything together in a practical lab where you were asked to program defensively to avoid or handle unchecked exceptions. You used try catch, finally, throw, and throws, and all in pursuit of a good cup of coffee. So, having reached the summit, you can pause and consider all of the useful and practical information you have gained on the way. You have learned fundamental concepts and skills that will enable you to adopt efficient defense mechanisms against potential errors in a program. And you can be confident that they are in line with best practice. Good job! You're playing an exciting new video game, advancing through levels, and achieving a high score. In fact, you're enjoying it so much you've taken the time to create your own personalized character. Imagine how you would feel the next time you logged in if all that history and customization had disappeared. So what ensures that you can continue right where you left off? Files and file handling is the key to having the game save your scores, progress, and settings between sessions. You've already worked with files, so you know that a file is a container for storing data on a storage device such as a hard drive or flash drive. Files can contain many types of data such as text, images, videos, or programs. Your game would contain both program files and settings files. Files are organized in folders or directories to make data easy to find. Understanding files helps you to understand how data is stored and managed on your computer. For example, file names don't just help you identify the file you want to open. They also provide other key information because they consist of two parts: the name itself and a file extension such as .txt. This file extension shows what type of file it is and indicates which program should be used to open it. File names may contain upper and lowercase letters, but operating systems handle them in different ways. This can cause confusion if you're moving files between different systems. On Windows, file names are case insensitive. This means that despite the use of uppercase letters, these three file names, which have combinations of upper and lowercase letters, are all considered to be the same file. On Linux, file names are case sensitive. So these three file names, which have combinations of upper and lowercase letters, are considered three different files. On Mac OS, file names are case insensitive by default. However, Mac OS can be configured to use a case-sensitive file system, where the three file names would be considered different files. Files can be different in a more fundamental way. They can be text-based or binary-based. Text-based files store data in a format that can be read and understood by humans. The content of these files is stored in a plain text and can be opened and edited using a simple text editor or other text processing software. Binary-based files store data as a series of bytes. They hold content such as videos or executable programs and often require a specialized software to open and manipulate. So, what common types of text-based files are you likely to encounter or work with? Perhaps the most common is a text file, which is a simple unformatted file that stores plain text and has a .txt file extension. You will also work extensively with JSON files. These files store structured data using a specific format. They are commonly used for transmitting data in web applications. For example, a user.json file containing user details might be used as a resource in your application's login process. You will also frequently work with log files. They record events, processes, or messages generated by software, for example, to log access requests on a server. As a developer, you will use them to help you monitor performance or to debug your code. You want your game to remember that you reached level 42 in the last session, or a word processing application to remember what language you use. Settings and preferences are often stored in another text-based file type, XML files, which store structured data using custom tags. You run a .exe file to install your game. This is an example of a binary-based file. If you've ever had to store or transmit large numbers of data files, you might have created compressed files such as zip files to reduce their size. These are also binary-based. As a software developer, knowing if a file is text-based or binary-based helps you to decide how to handle it. What common types of file handling operations will you need to allow for? You will have to open or read a file to access its contents. You will also need to modify a file by saving or writing data to it. You also might need to add data to the end of an existing file without overwriting its contents by appending. You will also have to delete temporary files or old log files to free up space, or rename a file after processing to avoid overwriting it. Of course, you will also have to manage files and directories. You will need to create them, list their contents, and delete them when they are no longer needed. Understanding these types of tasks and file handling in general is a crucial part of programming as it influences several key functions. In many applications, data needs to stay available even after the program ends. For example, your game needs to save your character customization so you can use it again. And a word processing application saves content in a document so you can continue editing it later. Files are a common way to share data between different programs or systems. For example, a .txt file created in one application could be opened in another. Programs often rely on configuration files to determine settings. For example, a Java application might read database configurations like username and password from a configuration file. Programs often create log files to track errors or important events. You can analyze these logs to understand the program's behavior or to diagnose issues. This video has demonstrated that file handling is a vital aspect of programming. It enables the structured and efficient storage, retrieval, and manipulation of data. By understanding and effectively managing file types, you can create powerful programs to interact with the real world. So, as you settle down for another gaming session, you're not back at level 1 because the game developer understood the importance of file handling and storing data beyond a single session. At Super Games, you're part of the development team working on an update for the company's most popular game. The update will allow players to customize their game settings, including controls, graphics quality, and sound levels. The game must locate the correct settings file, regardless of the operating system or installation directory. After discussion, you decide to utilize Java's file class to achieve this, and the file path will be a key piece of information. So, what is a file path? A file path is a string that represents the location of a file or directory in the file system. In programming, file paths are critical for locating files on your computer's file system, whether you're reading, writing, or deleting them. File paths can be absolute or relative. An absolute path is like giving directions from a central point. It specifies the complete path to a file or directory, starting from the root of the file system. In a Unix-based system, the root directory would be the /. In Windows, the C:\drive letter is the root directory. A relative path, on the other hand, is like giving directions from your current location. It specifies the location of a file or directory relative to your program's current working directory. If documents is the current work directory and there is a file called test.txt within it, the path to the file would simply be test.txt on both Windows and Unix-like systems. However, if the file is in a subdirectory of the current working directory, then the relative file path is different. For example, the working directory is documents and the subdirectory is called your details. On Unix-like systems, the path would be documents/your details/test.txt. On Windows, the path would be documents/your details/test.txt. As you sit at your desk working on the code for this new update, you are very aware that you will have to handle file locations regardless of the platform. Luckily, you know that the file class in Java is a flexible way to work with file paths and files. It greatly simplifies file handling and manipulation. The file class in Java represents files and directories and provides methods for performing various operations on them. These operations could include creating, deleting, renaming, and checking properties such as whether a file exists, if it's a directory, and its size. The leader of the development team for the Game Update development team has assigned you your first task: create code to organize all the project's documentation. There are different types of files stored in two main folders. The Documents folder contains one subfolder called Images. It also holds a text file called notes.txt and a PDF file called project.docs.pdf, which contains formal documentation. The Image subfolder holds an image file called diagram.png, which will be used in this documentation. You need to create a file path example class, which will manage this project's documentation folder. Your first step is to import the file class from the java.io package. This class provides methods for working with files and directories. Next, define the file path example class, which contains methods to check file and directory paths. The main method serves as the entry point of the program. Now you need to define the file path for the two files contained in the Documents folder, notes.txt and project.docs.pdf. But remember that the Documents folder contains a subfolder called Images, which contains an image file that also needs to be accessed. Define the path to the directory and then to the diagram.png file saved in it. Next, you should check if each of these already exists. Print its absolute path and determine if it's a file or a directory. Create a method to check if a file or directory exists. It should also print the absolute path and verify if it's a file or directory. Next, create a file object representing the file or directory at the specified path. Now use if and exists to verify whether the file is present. If the file is found, print the absolute path. Next, you need to determine if the path points to either a directory or a file and print the appropriate path. If the path does not exist, then ask for a message to be printed confirming this. Finally, print a blank line for readability in the output. Well done! Your code is created and now it's time to test it. Great! All the paths point to the directories and files as you planned. In this video, you've learned how to use the file class in Java to manage files and directories. By checking if files exist, retrieving their absolute paths, and determining whether they are files or directories, you can ensure that your Java program interacts with the file system effectively. Now you can smile and tick off a task on your to-do list. The launch of this game update now seems just a little bit closer. ConnectSphere is developing a new social media app for players of its most popular game. The app will allow users to upload their own text files and images. Correct handling of these files will be central to the app's success when it is released. In Java, two critical tools for handling file input and output are byte and character streams. In this video, you'll explore the differences between these two types of streams and learn how to choose the right one for your task to ensure your applications run efficiently and effectively. First, what is a stream? In general, a stream is a path along which a certain resource flows. In a computer system, the data moves from one place to the other in the form of a stream. You can simply state that a stream is the flow bytes from one point to another. In Java, a standard input stream is where the data entered by the user through the keyboard flows into the system memory. In a Java program, this would be the data flowing into the program. The standard input stream is called system.in. It represents an object of the printStream class that's pre-configured to take input from the keyboard by default. The data moves from the computer's memory to the display monitor or printer through a standard output stream. System.out represents the standard output device, which is usually the console. It's a printStream object designed for displaying information on your monitor in a formatted way. System.err is also a printStream object. It is normally used to display error messages, making it easy to separate regular output from program problems. Data can also enter and exit memory through other streams, such as a disk file or a network socket. Here, you can observe how the same process of input and output streams can be applied to different types of sources and destinations. Input stream and output stream are abstract base classes that define the foundation for all byte streams in Java. Character streams are built upon the foundation provided by the reader and writer abstract base classes. Streams will handle the image and text files uploaded by players using ConnectSphere's new app. There are two primary types of streams: byte streams and character streams. Byte streams are used in Java to handle raw binary data. They read and write data 1 byte at a time. They're versatile as they can work with any data type regardless of its format. Byte streams are particularly useful for processing files containing binary data, such as the app user's image files, audio files, or other non-text content. Byte streams preserve the integrity of binary data and ensure that the data is transferred exactly as it is. Byte streams used for reading are called input streams, and for writing they are called output streams. In Java, they are represented by the abstract classes an input stream and output stream. There are many byte-based stream classes. Among these classes most appropriate for file handling are file input stream and file output stream. In the code, the file input stream object, name in, is used to read from a stream of bytes from any binary file, whether it's an image, audio, video, or other binary data. And the file output stream object is used to write bytes to a disk file. If you're copying a file byte by byte, the read method of the file input stream class reads and returns the current byte available in the stream. The write method of the file output stream class writes a byte passed to the write method as a parameter to the given disk file. Here, they're used with a try with resources statement to ensure that the stream objects are closed properly so that even if an error occurs, it prevents resource leaks. Recall, a try with resources statement is designed to automatically close resources when the block finishes executing. Character streams are explicitly designed for handling text data in Java. Rather than working with individual bytes, character streams handle all types of characters, including Unicode, using the Unicode standard by default. Other encodings can also be used if needed. They manage the conversion between characters and their underlying byte representations, using the character encoding schemes such as UTF-8 or UTF-16. The app user would lose confidence in the app if their files and images did not upload correctly. Character streams process text data accurately, preserving its formatting and encoding. This prevents issues such as misinterpreted characters or corrupted text, which can occur if binary-oriented byte streams are used instead. Byte-based streams don't indicate character size, which can cause handling issues. Encoding isn't stored in the file, so ensure the same encoding is used for reading and writing with character-based streams. When using character-based stream classes, those classes which are used for reading are called reader classes, and for writing are called writer classes. There are many character-based classes. Among these character-based classes, two of the most appropriate for handling files are FileReader and FileWriter. FileReader reads characters from the source file, while FileWriter writes characters to the destination file. This ensures the content is transferred exactly as it is, preserving the integrity of the text. The FileReader object reads a single Unicode character from a stream of characters in a text file. An object of the FileWriter class is used to write all types of characters, including Unicode characters, in a text file. The read method of the FileReader class reads and returns the current character available in the stream. The write method of the FileWriter class writes a character to the given disk file. The developers at ConnectSphere must also take into consideration the performance implications of using these two streams. Byte streams process data in its raw form without the overhead of character encoding or decoding. This makes them faster and more memory efficient when dealing with large files or binary content. Character streams introduce an additional processing layer for character encoding and decoding, which makes them more suitable for text files. However, it can also lead to a slightly slower performance than byte streams, especially for large files. So if the choice of byte streams and character streams depends on the application's specific requirements, what would ConnectSphere choose? Byte streams are the correct choice for uploading binary image files. For text files, where encoding matters, character streams are the better option, despite the slight performance overhead. In this video, you've explored the critical differences between byte and character streams in Java, and how to apply them effectively. You can ensure that your applications handle file input and output efficiently, just like ConnectSphere does with its file upload features. You're part of a team working with health provider HealthWave Technologies to develop a new patient record system. Patient records will be shared across all their international healthcare facilities. If a patient record arrives with garbled text or information, it could lead to serious medical errors. Incorrect character encoding could cause just such a dangerous situation. Your role on the team is to ensure that special characters in patients' information are consistently represented. To achieve this, you must understand the concept of character coding and how to implement it correctly. First, let's find out more about character encoding. This is the mechanism that allows computers to store and transmit text by converting characters into a specific binary format. It ensures that data is accurately represented across different systems, which is crucial in global applications. There are several common character encodings, each suited for different purposes. It is important to be aware of the features of each one so that you can select the most appropriate type to use in your program. For example, UTF, Unicode Transformation Format, is a standard for representing characters, including letters, symbols, and emojis across different systems and languages. There are various UTF formats. The first is UTF-8. This versatile encoding represents each character in 1 to 4 bytes and is capable of encoding over 1 million valid Unicode code points. It's the most common encoding used on the web and is compatible with many languages, making it ideal for international systems. The 8 in UTF-8 indicates that this encoding uses 8-bit, 1 byte, blocks at the minimal unit for encoding characters. The next is UTF-16. This uses 1 or 2 16-bit code units to represent characters, which can be more efficient for languages with large character sets. It's commonly used in environments that require non-Latin characters, which include all characters outside the Latin alphabet, A to Z. HealthWave Technologies is an international organization, so the patient records contain international characters. It is vital that these characters are encoded correctly to avoid any misinterpretation of patient information. Because of this, you decide that your program should use UTF-8 or UTF-16 encoding. You might also encounter another encoding standard called ASCII, the American Standard Code for Information Interchange. It uses 7-bit binary numbers to represent 128 characters, primarily from the English alphabet. It's efficient for simple text, but since it lacks the ability to handle characters outside the basic Latin set, it would not be appropriate for the international scenario in HealthWave Technologies. Finally, there is ISO 88591, where ISO represents the International Organization for Standardization. This is part of a series of ASCII-based standard character encodings that offer broader character support. It encodes 191 characters from the Latin script. It's used throughout the Americas, Western Europe, Oceania, and much of Africa, and is the basis for most popular 8-bit character sets and the first block of characters in Unicode. Now that you've determined which character encoding would be the most suitable for this system to share patient records, how do you implement it? In Java, you can specify the character encoding explicitly while declaring objects of InputStreamReader and OutputStreamWriter classes. Remember that the default encoding may vary by platform. Specifying the correct encoding can prevent issues such as garbled text or loss of special characters. If you don't specify the correct encoding, your Java application might misinterpret the text data, leading to errors when reading or writing files. HealthWave Technologies is asking for a meeting to discuss the project, and you need to present code that will demonstrate your approach to the issue of multiple language character sets. Let's step through creating this sample code. First, you use an output stream writer wrapped around a file output stream to write data to a file named patientrecords.txt. The static method writeUTF-8 declares an object of outputStreamWriter class to write data. The UTF-8 parameter ensures that the file is written using UTF-8 encoding, since that can handle international characters. The write method adds patient names, including those with special characters like José Álvarez, to the file. Each name is followed by a new line character, open parenthesis, \n, close parenthesis, to separate them. Note that the file operation is enclosed with a try-catch block. Call the writeUTF-8 method from inside the main method. This will create a patientrecords.txt file in the project folder. Check the contents by opening the file. To read back the file, define a static method readUTF-8. Open the patientrecords.txt file with InputStreamReader. The InputStreamReader, wrapped around a file input stream, is used to read the data from the same file. Again, the UTF-8 parameter ensures that the file is read using the same encoding, so the characters are interpreted correctly. The read method reads the file character by character and prints each one to the console. This loop continues until the end of the file is reached. Reads the file until its end with the help of a for loop. The names of patients will be displayed on the console. Well done! This sample code will demonstrate to HealthWave Technologies that the new system can handle information for international patients correctly. But of course, you have to anticipate that converting the text may not always progress as smoothly. What issues might arise? If the encoding used for writing and reading data is mismatched, special characters might be misinterpreted, leading to unreadable text. If ASCII is used to write data that contains non-ASCII characters, there might be loss of data as they are replaced with different characters, which might result in unreadable or incorrect text. When systems use different encoding standards, text data can be converted from one encoding to another. However, this process can be tricky, as data corruption can occur if it is not done correctly. You anticipate that the HealthWave representative will ask about this issue. You decide to prepare a sample piece of code that will demonstrate clearly the issue and the possible data corruption. The sample shows what will happen if a file is written with ISO 8859-1 encoding but written into a file with UTF-8 encoding. Define another static method in the main class named readISO. To read the file with ISO 88591, use it as a parameter to the InputStreamReader object. Declare a string builder object named content, and use the append method to add each character from the patient record file to it, accumulating the file's content in memory. Now write the file contents collected in the string builder object named content to another file, patient records UTF-8.txt. It now has the UTF-8 encoding. When opened, the contents will show some garbled text, as the encoding while reading, which was ISO 88591, and writing, which was UTF-8, didn't match. You are now confident that you've sufficiently prepared on the issue of character encoding for your meeting. You can assure them that particularly sensitive information like patient records will be accurately represented and preserved across diverse systems. This video has demonstrated that understanding and applying the correct encoding in your Java programs not only prevents data corruption, but also facilitates seamless international data exchange, which is crucial in today's globalized environment. The HealthWave team is developing an application to handle large amounts of sensor data from patient monitoring devices. HealthWave is a global company with a large number of international healthcare facilities. The application will handle thousands of sensor readings from different countries. Storing this data in plain text would be slow and take up too much space. However, reading and writing this data as binary reduces the file size and improves processing speed. This ensures that the system can handle real-time data streams without missing a bit. In this video, you will examine the concept of reading and writing binary files using Byte streams, learn why they are used, and explore their advantages. Why is reading and writing in binary format more space efficient and faster to process? Text files store data as characters using the default encoding of the operating system or software being used, which takes up more space than binary bits. On the other hand, binary files store data in the exact format in which it is held in memory. Binary file operations ensure that the data is stored compactly and can be accessed quickly. This is essential for maintaining real-time data monitoring and analysis for HealthWave's patients. In Java, data output stream and data input stream classes are used to write and read primitive data types to and from a byte stream. These classes are included in the java.io package. To read data from a binary file, an object of file input stream referring to a binary file is used as a parameter for the constructor of data input stream class. The HealthWave team might use data input stream to read sensor data from a binary file using some key methods it provides. The readInt method reads 4 bytes from the input stream and interprets them as an int, a 32-bit signed integer. This could represent a unique identifier for a sensor. Before moving on, it's important to understand signed and unsigned data types. Signed types can hold both positive and negative values, while unsigned types hold only positive values. In Java, numeric data types are always signed. A 32-bit signed type uses 1 bit for the sign, 0 for positive, 1 for negative, leaving 31 bits for the value. The readFloat method reads 4 points and converts them into a float, which is a single precision 32-bit IEEE 754 floating point. This standard uses 1 sign bit and 31 bits for the value and can represent decimal numbers. This could represent the actual measurement from the sensor, such as temperature or pressure. The readUTF method reads a string encoded in modified UTF-8 format from the input stream. Modified UTF-8 is a variation of standard UTF-8 designed for the Java virtual machine to handle strings during file manipulation and serialization. Serialization is a technique to save an object's state of values to a file and later recover it with the same state. For example, it can be used to record the time sensor data was captured. Similarly, to write data in a binary file, an object of file output stream, referring to a binary file, is used as a parameter for the constructor of data output stream class. The HealthWave team may use data output stream to write sensor data to a binary file. This ensures that the sensor data can be accurately and quickly retrieved when it is needed. They can take advantage of some key methods. The writeInt, in parentheses, int_v method writes 4 bytes representing the specified integer value to the output stream. This could write the sensor ID as an integer to the binary file. The writeFloat, in parentheses, floatv method writes 4 bytes representing the specified floating point value to the output stream. HealthWave could use this to write the sensor measurement, such as temperature or pressure, as a floating point number. Another method, writeUTF, in parentheses, string str, writes a string to the output stream using modified UTF-8 encoding. It writes the timestamp as a UTF-8 encoded string. This would enable HealthWave to store complex text data such as dates and times. After reading the necessary data, the program processes this information. This could involve storing the data in a database, performing calculations, or updating a user interface. As part of the HealthWave team developing this application, you will have to know how to write and read from a binary file in Java. Let's step through an example. To write a binary file, you need to declare an object of data output stream class and pass it to an object of file output stream that refers to a binary file to be written. The HealthWave application will store the variables sensor ID, sensor value, and a timestamp. Generate a random float value for the sensor value using the random class. Remember, we are generating random values to simulate test data. In real software, random values are typically used only if required by the software specifications. Assign an arbitrary timestamp to be saved. The methods writeInt, writeFloat, and writeUTF of data output stream class are called. The try with syntax is used here to ensure that the file is properly closed after the writing operation. All the activity is done inside the public static void binary write method. Call it from the main method and run the main class. The file sensordata.bin will be created in the project folder. Since it is a binary file, it will show garbled data if you open in a text editor. Next, what about reading a binary file? In a similar way, a public static void binary read method is defined to read back the data from a binary file. You need to use the data input stream class with an object of file input stream as a parameter to its constructor. Call the readInt, readFloat, and readUTF methods inside a loop till the end of the file is encountered. Finally, call the binary read method from main and run the application. The sensor data is now displayed on the console. HealthWave must safeguard its critical patient information and sensor data by following best practices and ensuring it is reliably stored and retrieved without errors. First, always ensure that streams are properly closed after operations to avoid resource leaks. You can use a try with statement to ensure the data input stream is automatically closed when the try block completes. Robust error handling is crucial when working with binary files. Common exceptions include I/O exception, which can occur due to issues like file not found or read-write errors. In this example, any I/O exception during the write process is caught and handled appropriately. This ensures that the application can log the error and take corrective action, such as retrying the operation or alerting the user. It's also essential to anticipate and handle data corruption scenarios, which can lead to partial reads or writes. You must ensure the system can recover gracefully. Checksums or validation processes during both read and write operations can help detect and correct errors, ensuring the data remains consistent and reliable. Before HealthWave writes the data, a checksum is calculated. A checksum is a value generated by custom logic that consistently produces the same result for a given input. Here, checksum is calculated on the sensor value and is stored with the sensor data. Later, during the read operation, this checksum can be recalculated and compared with the checksum value to ensure the sensor data has not been corrupted. You've explored the essential techniques for reading and writing binary files using Byte streams in Java. You've learned to handle large data efficiently, ensuring performance and integrity. With this knowledge and keeping best practices in mind, you will become a key member of the team developing HealthWave's new application. Have you ever wondered how a file management system like Microsoft SharePoint works? With SharePoint, you can create, move, delete, and rename files while maintaining data integrity and performance. How does this relate to Java? Java handles file operations by using its file class or the more advanced Java NIO. Whether backing up critical documents or organizing large volumes of files, mastering and understanding these two options is essential for your system's reliability. In this video, you'll learn the essentials and compare Java's file class and the more advanced Java NIO, or New Input/Output. We have already explored the file class, which is a fundamental tool for managing files and directories, with straightforward methods for creating, deleting, renaming, and checking the existence of files. It is your go-to tool for basic operations, like allowing a user to manage their files. It abstracts file and directory handling, simplifying file operations and hiding technical details, and allows you to interact with the file system without knowing the specific details of how it operates underneath. As your application scales, the demand for more efficient file handling grows. That's where option 2, the Java NIO, comes in handy. The Java NIO provides more advanced file management features than the traditional file class, including non-blocking I/O, that is, I/O operations without waiting delays, and a wider range of file operation tools. Imagine you have to develop an application similar to SharePoint. The application needs to handle thousands of file operations concurrently, such as backing up user data or syncing files across different servers. Java NIO's Files class, combined with the Path interface, which we will see in further lessons, provides more efficient and flexible tools for managing files. Back to the development of your own file management system. With methods like files.copy and files.move, you can easily manage complex file operations, and NIO provides more detailed exceptions. It is thus easier to diagnose and handle errors during file operations. First, you must decide between using the file class or the NIO. To help you choose, keep the following in mind. First, for simpler synchronous operations, like managing small-scale user file uploads, use the file class. Conversely, NIO's non-blocking nature is more suitable if you have large-scale operations, like server-side file processing. Second, if you need better performance in high concurrency environments, then NIO's non-blocking I/O and advanced features are the best choice. And lastly, the file class is easier to implement for basic operations, while the NIO offers more powerful methods that pay off in complex scenarios. Let's navigate to IntelliJ and compare the file class and the NIO library in terms of creating, deleting, and renaming a file by introducing 3 scenarios. First scenario: a user uploads a new document to your application, and you need to create a new file to store it using the file class. The method createFileForUpload creates a new file in a specified directory with a given file name. It checks if the file already exists and returns a message indicating whether the file was successfully created or if it already exists. Therefore, the expected output of the createFileForUpload method depends on the state of the file system at the time the method is called. The output will be one of 3 possibilities. 1. If the file with the specified file name does not already exist in the given directory, the method will create the file and return file created successfully, absolute path to the file. Second, if a file with the specified file name already exists in the given directory, the method will not create a new file and will return file already exists, absolute path to the file. And thirdly, if an error occurs during the creation process, it catches the exception and returns an error message. Second scenario: what if you have to delete temporary files that are no longer needed? The file class makes this a simple and straightforward way to manage the deletion of temporary files in a Java application. The deleteTempFile method checks if the specified file exists at the given path and attempts to delete it. If successful, it confirms the deletion with a message. If unsuccessful, it notifies that the deletion failed. Last scenario: what if a user decides to rename a document? The renameFile method is designed to rename a file by changing its name from an old one to a new one. The method checks if the renaming operation was successful and provides feedback by printing a message, confirming whether the operation was successful or not. So how do these 3 scenarios relate to the NIO library? Let's explore. First scenario: a user uploads a new document to your application and you need to create a new file to store it. You can create the path object with paths.get to get the relative path and indicate the file's location as user_documents/uploadedfile.txt. Then, the files.createFilePath method attempts to create the file at that location. Second scenario: deleting temporary files that are no longer needed. With NIO, the files.delete method is used to delete the file at the specified path. As with the file class, NIO checks if the specified file exists at the given path and attempts to delete it. A message will be displayed in the console indicating success or error. Last scenario: a user decides to rename a document. NIO will rename the file by moving it from the old path to a new path using files.move. A confirmation message will be displayed in the console. What if your application needs to create regular backups of user files? This can be done with Java and I/O as well as file class. A file is copied from one location to another by creating path objects for the source and target. For example, user_documents/userfile.txt and backup/userfile_backup.txt. The files.copy method then copies the file. The standard copy option .replace_existing option ensures that if the target file already exists, it will be overwritten. Finally, a message is displayed in the console confirming the file copy operation. File operations can sometimes fail due to issues like file permissions, missing files, or other unforeseen errors. Handling these exceptions is crucial to ensure your application remains robust and reliable. Proper exception handling not only helps in diagnosing and addressing issues quickly, but also ensures that your application can continue to operate smoothly without unexpected crashes or data loss. By anticipating and managing potential errors, you can maintain the integrity and stability of your application, providing a better user experience. In this video, you learned that you can use two methods to create a file management system: the file class and Java and I/O. While the file class is perfect for simple, straightforward tasks, your file management needs might evolve. The Java and I/O offers the performance and flexibility necessary for more demanding environments. By understanding both approaches, you can design your application to efficiently manage files, ensuring reliability and performance across various use cases. Whether you're handling basic user uploads or complex file synchronization tasks, Java provides the tools to get the job done effectively. Do you have a journal where you capture your to-do list? Imagine that the entries from yesterday disappear while you write in the journal. That will be frustrating. In this video, you'll explore appending data to existing files with the File Writer class, which allows you to add new data while retaining existing data. Connectosphere, a communication and networking solutions company, wants to create a new feature that appends each new activity log to an existing log file. This ensures that every interaction is recorded without overwriting previous data, allowing a complete history of user activities. Let's explore how to implement this feature by using a method that appends data to the file efficiently and reliably. Appending data is when new information is added to the end of an existing file without deleting the existing content. This is commonly used when continuous data logging or updating is required, like maintaining logs, transaction histories, or adding records to a data file. With Connectosphere, appending data is crucial for user interaction. For example, logins and profile updates that is recorded in sequence without losing previous entries. Therefore, maintain a complete and accurate history of all user activities. The File Writer class in Java is fundamental in writing data to files. With the File Writer object, you can specify to append or overwrite an existing file. For example, you can set the append parameter within the File Writer constructor to true. New data will then be appended to the end of the file. How does this relate to Java and Connectosphere? Connectosphere needs to preserve user interaction history. For example, login or profile updates are added to the activity log file. Let's explore how to add a new log entry to an existing file. Import the File Writer and I/O exception classes from the java.io package. The Activity Logger class represents a simple Java program that appends a new log entry to an existing log file named user_activity.log. It generates a log message with the current timestamp. Thereafter, a File Writer class in append mode to write this log entry to the file without overwriting any existing content. If the file doesn't exist, it will be created. The class also handles potential I/O exception errors that might occur during the file writing process, ensuring that any issues are properly reported. When you run the activity logger file, the data in the user_activity.log file will be updated, returning the message log entry added. The buffered writer class enhances the efficiency of file writing operations by buffering the characters before writing them to the file. This reduces the number of disk accesses, which is particularly beneficial when dealing with large amounts of data or frequent write operations. For ConnectSphere, using a buffered writer with a file writer class can significantly improve performance, especially in environments where the system needs to remain responsive under heavy load. In this example, buffered writer wraps around the file writer class, buffering the data before it's written to the file. This reduces the number of write operations, making it more efficient, especially in high-volume logging scenarios like those in ConnectSphere, where user activities are logged frequently. When you run the efficient logger file, the data in the user_activity.log file will be updated, returning the message log entry added efficiently. When appending data to files in Java, challenges like concurrent access and data integrity can arise. If multiple processes write to the same file simultaneously, data corruption may occur. Implementing file locking mechanisms is essential to prevent this. File locking ensures that a process has exclusive access to a file, avoiding conflicts and maintaining data integrity. This is particularly important in environments with frequent concurrent access, as it prevents conflicts and ensures accurate data, especially in systems that depend on reliable logs for auditing or tracking. Let's explore how to perform file locking. The SafeLogger class is a Java program designed to safely append a new log entry to the user_activity.log file, ensuring that concurrent access to the file is managed correctly. The program generates a log entry with the current timestamp and then uses a file channel to open the file in append mode. Before writing to the file, it acquires a file lock using file lock to prevent other processes or threads from modifying the file simultaneously, ensuring safe concurrent access. The log entry is then written directly to the file using the file channel object in append mode. By using file channel in combination with file lock, we ensure that only one process can write to the file at a time, preventing data corruption and maintaining safe concurrent access. Throughout the file writing process, any potential I/O exception errors are caught and handled appropriately. This includes acquiring the file lock, writing the log entry, and releasing the lock in the finally block. In this example, file locking ensures that only one process can write to the file at a time. This approach is crucial in the ConnectSphere platform to prevent data corruption when multiple parts of the system attempt to log user activities simultaneously. When you run the SafeLogger program, the data in the user_activity.log file will be updated, and the message log entry added with safe concurrent access will be returned. When appending data to files, it's important to follow best practices to ensure the reliability and maintainability of your code. These include 1. Always close file streams. This prevents resource leaks that could cause performance issues or crashes. 2nd, use try with resources. This Java feature automatically closes resources, making your code cleaner and less error-prone. And 3rd, handle exceptions gracefully. Ensure your program can handle errors without crashing, providing a smooth user experience. By implementing these best practices, ConnectSphere maintains a robust and reliable logging system, ensuring that logs are consistently accurate and that resources are managed efficiently. In this video, you learned how to effectively append data to files using the file writer and buffered writer classes in Java. You explored common challenges like concurrent file access and best practices for ensuring data integrity and resource management. By applying these techniques, you can ensure that your applications, like ConnectSphere, maintain accurate and complete logs, even as new data is continuously added. Searching for a file or folder on your computer often becomes a frustrating experience, especially when you are unfamiliar with the file hierarchy. It feels like hunting for a needle in a haystack without knowing which haystack to check. You might struggle to remember where you saved or need to save a file, or accidentally bury it in an unexpected folder with an unclear name. Navigating through countless folders and subfolders quickly becomes overwhelming. Without a straightforward method, you can lose your way clicking through one folder after another, hoping to uncover the missing file. In this video, you'll learn Java file navigation with the file and files classes to traverse directories and list files. This will help you develop programs that effectively manage and organize large file systems. ConnectSphere, a communication and networking solutions company, must optimize server space by archiving old media files. The development team must create a Java program that navigates directories to locate and move outdated files to the archive folder. This process is crucial for maintaining efficient server resource usage and ensuring optimal system performance as user data grows. ConnectSphere organizes its files within a primary directory named user_data, which contains various files and subdirectories. Therefore, effective file navigation involves traversing directories and files within a file system with programming techniques. In Java, the file class provides methods that allow developers to navigate the file system, retrieve information about files and directories, and perform operations such as listing directory contents and checking file properties. Therefore, ConnectSphere needs efficient file navigation to identify and archive outdated media files. First, let's define directory traversal. In Java, directory traversal involves moving through the contents of a directory with files and subdirectories. This is important for programmatically managing file systems. The file.listFiles method allows for simple directory traversal, returning an array of file objects representing the files and directories within the specified directory. For more complex cases like traversing large directories or accessing nested subdirectories, the files.walk method is more powerful. It provides a stream of path objects that can iterate over directory contents, making it suitable for large directory structures. Let's navigate to IntelliJ and explore directory traversal. In this example, the file.listFiles method is used to retrieve an array of file objects representing all files and directories within the user_data directory. This code iterates through an array of file objects, checking whether each object is a file or a directory. Based on the file type, it then prints the name of each item. While this method provides a straightforward way to list the contents of a directory, it only displays the files and directories at the top level, as it doesn't recursively traverse the file system. Therefore, the output doesn't indicate the files within the subdirectories. Another option is recursive directory traversal. The files.walk method is used to generate a stream of path objects that represent all files and directories within the user_data directory, including all its subdirectories. The filter method is then applied to this stream to include only regular files, excluding directories. The forEach method prints out the full path of each file. The try with resources will ensure that the stream is properly closed, preventing potential memory leaks. Since the code filters out directories like photos and docs, only the regular files will be printed. The full path for each file, starting from the user_data directory, will be displayed in the output. The files.walk method is ideal for handling complex tasks. Why? Because it simplifies recursion to browse directories. Normally, you'd need to write your own code to navigate through directories. But files.walk does that for you, going through each folder and generating a stream of path objects, making your life much easier. Secondly, files.walk is built to handle complex directory structures. Whether you're dealing with a deeply nested folder system or symbolic links, files.walk is designed to handle the intricacies of real-world file systems. There are also best practices for filtering and managing files. For example, when listing files and directories, it's important to note that you can apply advanced filters to retrieve only specific types of files by specifying the extension. The files.newDirectoryStream method allows you to filter which files are included. Conversely, the files.walkFileTree method offers a more complex and customizable approach for advanced directory traversal. It provides precise control by enabling custom actions at each step of the process through the File Visitor interface, ideal for tasks that require detailed handling, like error management, skipping certain files, or processing directories in a specific order. When applying filters and managing files, you can follow two best practices. 1. Filter files as early as possible to reduce the number of files for processing, especially with large directories. This approach helps avoid unnecessary processing that can degrade performance. And 2. Always ensure that streams are properly closed after use to prevent resource leaks. Using try with resources is a reliable way to handle this automatically. In the connected sphere scenario, these best practices enabled the program to focus on relevant media files, ensuring that only those meeting the criteria were moved to the archive, thus optimizing storage usage. In this video, you learned how to navigate directories in Java using methods like file.listFiles and files.walk, manage subdirectories recursively, and filter files effectively. These skills are essential for handling large and complex file systems, as demonstrated in the connected sphere scenario. By applying these techniques and best practices, you can ensure efficient and reliable file management in any Java application. Have you ever wondered how file management works on a computer or cloud storage platform? You can create, delete, and rename files and folders to keep an ordered hierarchical system. For the system to work, data cannot get lost or corrupted. In this video, you'll learn how to manage directories in Java, from creating and deleting directories to renaming and resolving conflicts, ensuring your file system stays organized and efficient. Let's revisit Connected Sphere, a communication and networking solutions company that wants to implement a new online platform for users to join and interact. Upon registration, this feature will automatically create a dedicated directory for each new user, where their profile information and uploaded content will be stored. Therefore, careful creation, renaming, and deletion of these directories are necessary to keep the system organized and to ensure that no data is lost or corrupted during these operations. In Java, these operations are primarily handled using the file class, which provides methods to manipulate directories, ensuring efficient organization and storage of files within a program. The file class provides a simple and straightforward API for basic file and directory operations, making it suitable for quick tasks and legacy code. However, it lacks flexibility and advanced features like robust error handling and support for modern file systems. Conversely, NIO with its path and files classes offers a more powerful and versatile framework. It supports more complex file operations, better performance, and improved error handling through exceptions. NIO is better suited for modern applications that require advanced file system manipulation, like handling large directories, symbolic links, and atomic operations. Let's return to Connectosphere. As a programmer at Connectosphere, you will need to use NIO in the development of directory management features. The advanced capabilities of NIO will allow you to efficiently handle user data, ensuring that directories are created, managed, and maintained in a way that supports the platform's scalability and reliability. While file is useful for basic tasks, NIO is preferred for robust and scalable file management in Java, particularly in a high-performance environment like Connectosphere. So, if NIO is so powerful, why not always use it instead of the file class? Well, it depends on the task. The file class is simpler and works well for quick, lightweight operations, like basic file creation, renaming, or deletion. If you're working on smaller projects or legacy systems that don't need advanced features, the file class gets the job done with less overhead. Let's look at the Connectosphere platform. A directory is created for each user upon registration, using the Create Directories method from the NIO files class. Before creating the directory, the code checks if it already exists to prevent overwriting any existing data. This precaution is essential for maintaining data integrity on the Connectosphere platform. The directory example NIO program attempts to create a directory structure at the specified path user_data/Joe_Gray using the NIO files.createDirectories method. This method tries to create the directory named Joe_Gray along with any necessary but non-existent parent directories. Under typical conditions, where the directory does not exist and permissions are sufficient, the most likely output when running this program for the first time is a message confirming the directory is created successfully. If the directory user_data/Joe_Gray already exists, the program will detect this and print a message confirming this. If the directory creation fails, for example, due to insufficient permissions or an invalid path, the program will print a notification that the directory could not be created. Renaming directories is necessary when data identifiers change, such as when a user changes their username. The associated directory must be renamed to reflect this change, ensuring consistency across the platform. In Java, while the file.renameTo method can be used to rename a directory, it has limitations, such as not supporting cross-file system renaming, like if the source and target locations are on different file systems, such as different partitions, drives, or networked file systems. Instead, NIO's file.move method provides a more robust solution that overcomes these limitations. The directory rename example NIO program attempts to rename a directory from user_data/John_Doe to user_data/John_Smith using the NIO files.move method. The output depends on several factors, such as whether the source directory exists and whether the name operation succeeds. If the directory user_data/John_Doe exists and there are no issues with permissions or other factors, the most likely output when running this program would be if the directory user_data/John_Smith does not exist, the program will print a message confirming the directory is successfully renamed. If the rename operation fails, for example, due to insufficient permissions, the target directory already exists, or an invalid path, the program will catch the exception and print an error message. Additionally, it will print the stack trace of the exception to provide more details about the failure. Deleting directories is crucial for cleanup operations, such as when a user deletes their account on Connectosphere. Proper deletion ensures that no residual data is left behind, maintaining the system's cleanliness and performance. The NIO files.delete method is useful for this purpose, but it's important to note that it only works for empty directories. If the directory is not empty, the method will throw an exception. This method provides detailed error handling, allowing you to catch and manage exceptions if the deletion fails due to non-empty directories, permission issues, or other factors. Let's explore the NIO files.delete method. This directory deletion example program attempts to delete a directory at the specified path user_data/Joe_Gray using the files.delete method. If the directory is successfully deleted and the directory is empty, the program will print a message saying the directory has been successfully deleted. If the directory deletion fails, for example, the directory is not empty, the path is invalid, or there are insufficient permissions, the program will catch the I/O exception and print an error message. This example highlights the use of NIO for directory deletion, demonstrating its ability to provide detailed error handling. In ConnectSphere, robust error handling is essential to maintain the platform's reliability. For instance, when deleting a user's directory, the platform must ensure that all associated files are deleted first. If an error occurs, it should be handled gracefully to prevent data corruption or loss, which is critical for maintaining user trust. When performing directory operations, the code first checks if the source directory exists before attempting to rename or delete it. This avoids errors related to non-existent directories. The files.move method is used with the standard copy option .replace_existing option, ensuring that the operation can overwrite an existing directory if necessary. Exception handling with a try-catch block ensures that any issues during file operations, such as I/O exceptions, are caught and managed appropriately, preventing unexpected crashes and preserving data integrity. In this video, you learned how to manage directories in Java, from creating and deleting directories to renaming and resolving conflicts, ensuring your file system stays organized and efficient. Mastering directory operations in Java enables you to manage and organize files efficiently, ensuring data integrity and system reliability. By applying these skills, particularly in scenarios like the ConnectSphere platform, you can create, rename, and delete directories effectively while gracefully handling potential errors. These practices are vital for maintaining a scalable and dependable application. Playing video games is fun until you've cleared a tough level and want some snacks to celebrate. But before stepping away, you pause the game to make sure everything stays exactly as it is. Your character's position, inventory, and even the enemies. How does your game remember all this? In programming, this ability to save and restore the state of an object is known as serialization and deserialization. In this video, you'll explore how to use these concepts in Java to save the state of your objects and bring them back to life when you need them. Let's start with serialization. Serialization is a process of converting a Java object into a byte stream, which can be easily saved to a file, sent over a network, or stored in a database. The byte stream represents the object's state, making it possible to store it and reconstruct it later. Ready to see how this works in Java? Let's dive into some code. First, create a project named Adventure Game and define a simple player class with a few attributes. Right-click on the SRC folder, select New, click on Java Class, write the name of the class as Player, and press the Enter key. Define 3 attributes for the player. 1. Private string name. 2. Private int level. And 3. Private int score. You'll need a parameterized constructor to initialize these attributes and getters and setters. Right-click inside the class, select Generate, and choose Getter and Setter. In the new window, select all three attributes and OK. The getters and setters will now appear in the class. Now, let's override the toString method. Right-click in the class again, select Generate, and choose toString. Select all three attributes and OK. Your player class is now ready. Now the player class is ready. Let's prepare this class to be serialized. To make this class serializable, you need to do two things. First, implement the serializable interface in your player class. Second, define a serial version UID variable, which should be private, static, final, and of type long. The JVM verifies that the saved and loaded objects are compatible during serialization. If a serializable class doesn't declare a serial version UID, the JVM will generate one automatically at runtime. The serial version UID is used in Java's serialization mechanism to ensure that a deserialized object is compatible with the version of the class that was used to serialize it. Now, let's serialize an instance of the player class and save it to a file. For this, let's create a main class with the main method. First, create a player instance with the reference GameMaster13, passing the appropriate arguments to the constructor. Now, add a try-with-resources block and initialize a file output stream object. Pass in the name of the file as player.ser to the constructor. You can use any file extension here. Add the appropriate catch blocks to handle any potential exceptions. Inside the try block, initialize an object output stream object, passing the file output stream object to its constructor. Then, call the writeObject method on the object output stream instance, passing in the GameMaster13 instance as an argument. This will serialize the player instance and write its information to the player.ser file. Run the code and observe the output. It will create a new file called player.ser. Remember, the serialization process converts all attribute data into a byte stream and saves it to a file. However, attributes declared as static, like the serial version UID, are exempt from serialization. If any attribute contains sensitive data that you don't want to save, you can use the transient keyword to exclude it from serialization, like private transient string password. Next, we'll move on to deserialization, which is the reverse process of reading a byte stream and converting it back into an object. This is how you restore the state of your object, just like resuming that paused game. Now let's see how to read back the object you just saved. To deserialize an object in Java, the object input stream class is used to read the byte stream from the file and convert it back into a Java object. Create a new player instance and name it restoredPlayer. Initialize it with null. Add a try-with-resources block and initialize a file input stream instance, passing the name of the file where the player instance is saved as player.ser. Create an instance of the object input stream and pass in the file input stream object as an argument to its constructor. An object input stream deserializes primitive data and objects previously written using an object output stream. Now, call the readObject method on the object input stream instance. Add a catch block to catch the class-not-found exception. Cast the restored object into a player instance and store it back in the restoredPlayer object. Finally, you can print the restoredPlayer object to visualize that the state of the object has been restored. Let's run the code. you'll notice that the player object has been successfully serialized and deserialized, maintaining its state across different program executions. Although serialization and deserialization are powerful tools, there are a few things to watch out for. First, not all objects can be serialized. Transient fields, for instance, aren't saved as part of the object's state. Second, also be cautious with versioning. Changes to your class structure can break the deserialization process. Always include a serial version UID in your class to avoid unexpected issues during deserialization. And third, remember, serialization should be used thoughtfully, as it can introduce security risks if not handled properly. In this video, you learned that serialization and deserialization are essential tools in Java that allow you to save and restore the state of your objects. Whether you're pausing a game or saving user preferences, understanding how to serialize and deserialize objects is a valuable skill. Now that you know how it works, why not try serializing and deserializing your objects? Happy coding! Congratulations! You are past the halfway mark of this course. There must have been times when you felt overwhelmed and unsure of what to do. But rest assured, you are closer than ever to becoming a junior software developer. Let's recap the concepts and techniques you've learned on file handling. Mastering file handling is essential for building robust and efficient applications as a beginner Java programmer. Whether you're storing game progress, managing user data, or organizing system logs, understanding how to interact with the file system is crucial. This module covered various operations you can perform on files and directories, from basic tasks like reading and writing to more advanced operations like serialization and directory management. Lesson 1 started with introducing files and directories. You began with the basics, learning what files are and why file handling matters. You now know that files act as containers for storing data on devices like hard drives and come in two main types: text files, which store human-readable data, and binary files, which store data in a computer-readable format. Java provides you with classes like file, file writer, and buffered reader to manage these files effectively. Next, you learned to perform standard file input and output, or I/O operations. These include creating, deleting, renaming, and copying files using the file class. This class gave you a simple API for basic tasks, making it easy to create a new file when a user uploads a document or rename a file as needed. You discovered that Java NIO, or New I/O, offers better performance and flexibility for more complex scenarios, especially in high concurrency environments where efficiency is key. Therefore, you learned how to use file writer and buffered writer to write and append data to text files. When logging user activity, you preserve existing logs while adding new entries by setting file writer in append mode. This allowed you to add new data to the end of a file without overwriting the existing content. However, for frequent write operations or large data volumes, you can use buffered writer to buffer data before writing it to the file, reducing the number of disk accesses and improving performance. This approach is particularly beneficial in scenarios where system responsiveness is critical, such as in a communication platform logging user interactions. Beyond individual file operations, you also master directory management, another critical aspect of file handling. You learned how to create, delete, and rename directories using the file class and Java NIO. For example, when a new user registers on a platform, you create a dedicated directory to store their data, ensuring it is organized and easily accessible. The file class offers straightforward basic methods for directory manipulation. However, Java NIO, with its path and files classes, provides a more robust solution for modern applications, and I/O supports advanced operations like handling large directories, symbolic links, and atomic file operations, features that are essential for maintaining data integrity and system reliability in complex applications. In Lesson 2, you were introduced to streams through which data flows between your program and the file system, a vital part of file handling. Streams like file input stream and file output stream allow your program to read from or write to files. Then you learned the importance of managing streams properly to avoid resource leaks, which could cause your application to crash or behave unpredictably. By using Java's try with resources statement, you can automatically close the streams after use, whether an exception occurred or not. This feature ensured that resources were released promptly, preventing memory leaks and maintaining application stability. As you progressed through Lesson 3, you encountered more advanced topics like serialization and deserialization. You learned to serialize an object, converting it into a byte stream so you could save it to a file or transmit it over a network, and then deserialize it back into an object. This concept proved particularly useful when you needed to persist the state of an object, such as saving game progress. By serializing the game state, you saved it to a file and later deserialized it to restore the game exactly where you left off. Throughout the module, you followed best practices to ensure your file handling code was efficient and reliable. You consistently closed file streams to prevent resource leaks, used try with resources for cleaner code, and handled exceptions gracefully to allow your application to recover from errors without crashing. When dealing with concurrent access to files, such as when multiple processes write to the same file simultaneously, you implement file locking mechanisms. These mechanisms prevent data corruption by ensuring only one process can modify the file at a time. By mastering file handling in Java, you've laid a strong foundation for building reliable, efficient, and scalable applications. From reading and writing files to managing directories and serialization, you now have the knowledge and tools to handle files and directories effectively in Java. By following best practices and leveraging Java's advanced file handling APIs, you can ensure your applications are robust, efficient, and capable of managing data to support current and future needs. Happy coding! You have reached the end of another course. What a great achievement, and you've worked so hard to reach this point. During this course, you learned fundamental concepts in Java and developed coding skills that will form a solid foundation for your career. Let's take a few minutes to review the highlights and key takeaways of this course. You began in Module 1 by exploring some need-to-know advanced object-oriented programming concepts. First, you were introduced to the idea of abstraction, how abstract classes work, and how they use concrete and abstract methods. Interfaces were also covered, and you discovered their importance in facilitating code flexibility. You learned how to create and implement them, and you also had an opportunity to apply this knowledge in a practical example. Next, you tackled the key concepts of class hierarchy and relationships. You found out how a class hierarchy can be a mixture of concrete and abstract classes and about the different types of relationships. Stepping through real-world examples, you learned about the importance of class design and possible advantages and pitfalls. Practical demonstrations showed you the importance of naming a class to show its purpose and meaning. You also learned Java doesn't support multiple inheritance, which can lead to the diamond problem. You examined the difference between abstract classes and interfaces and how to make the critical decision on when and where to use them. Providing real-world context was a guiding principle of this course, and at every stage, you were given the opportunity to put your knowledge into practice by writing code in the virtual environment. Here, you refactored the existing code to implement interfaces and created a working class hierarchy. Module 1 focused on key concepts and foundational knowledge. Module 2 focused on the more practical issues of what can go wrong and avoiding or handling issues. First, you learned about the nature of errors and exceptions that can occur. You now know that a checked exception is checked at compile time and it must be caught or declared using the throws keyword. Unchecked exceptions become obvious at runtime and are often caused by mistakes in code, as some practical step-through examples demonstrated. You were also given a useful glossary of all the exceptions. But don't forget, this module is called Defensive Programming Error Handling, so the next lesson focused on how to handle these errors and exceptions when they occur. The first key technique introduced was using the try-catch block mechanism to handle both errors and exceptions. Once the exception occurs, the code in the catch block allows you to control the next action. If a single piece of code in your app causes more than one exception, you learned that you can use multiple catch blocks to handle multiple exceptions of different types. You also learned about the importance of cleaning up resources like database connections and file handles. Failing to do this correctly could cause your program to stall or ultimately crash. A finally block is a practical way to carry out this resource cleanup or to perform any other essential tasks. Another more elegant approach that you learned is to use a try with resources block. This closes resources automatically once your code has finished using them. Applying knowledge in a practical way, you created try-catch blocks in the code for a student management system that is in development. Next up was something to avoid: the catch-all expression. While it might seem like a good idea to use it, you learned you could end up with too many exceptions and errors in your fishing net. If an individual catch block can't manage an exception, you discovered you could handle it by declaring or rethrowing the exception. Module 2 gave you comprehensive knowledge on recognizing and handling errors and exceptions. Module 3 focused on file handling, beginning with an exploration of the nature of files. File paths are critical for locating files to perform actions such as reading, writing, or deleting them. You learned the difference between an absolute file path and a relative file path. You also learned how to manage files and directories using the file class. And you were shown step by step how to check if files exist, how to retrieve their absolute paths, and how to determine whether they are files or directories. Next, the focus moved to reading from and writing to files. The key information and techniques demonstrated will help your Java programs to interact efficiently with external data sources. You explored how a Java program reads data files using key classes in the Java I/O API, such as file input stream, buffered reader, and file reader. You learned how to create files programmatically and discovered the differences between using file output stream for byte data and buffered writer for character data. Next came the critical differences between byte and character streams in Java. You now know how to apply them effectively using byte streams for uploading binary and character streams for text files where encoding matters. You learned more details about different types of character encoding, such as UTF-8, UTF-16, ASCII, and ISO-8859-1. Putting this information into a more practical context, you were shown step-by-step examples of performing read-write operations on text files using Java's reader and writer classes and different approaches to handling character streams. You also explored the essential techniques for reading and writing binary files using byte streams in Java. Then, in the virtual environment, you had the opportunity to create and manipulate both text and binary files to store various types of data. Next, two methods to create a file management system were explored. The file class is perfect for simple, straightforward tasks, and Java NIO offers the performance and flexibility necessary for more demanding environments. You discovered how to effectively append data to files using the file writer and buffered writer classes in Java. You also learned how to navigate directories, manage subdirectories recursively, and filter files effectively. Finally, another key concept and technique introduced was serialization and deserialization. This will enable you to save and restore the state of an object in your programs. What an exhilarating coding journey! This course has equipped you with valuable information and skills that you will use throughout your career. But before that happens, you have an opportunity to apply them in one final project. This is your chance to showcase all you've learned. Go for it! Congratulations! You have completed the Programming with Java course. Your dedication and hard work in mastering advanced Java programming techniques have paid off. In this course, you've taken a deep dive into advanced object-oriented programming, or OOP concepts, significantly enhancing your ability to design and develop sophisticated Java applications. You began with an introduction to interfaces and abstract classes, mastering how to use interfaces for multiple inheritance and abstract classes to design robust class hierarchies. You then tackled exception handling, learning to manage various exceptions using try-catch-finally blocks, ensuring your programs run smoothly under unexpected conditions. Moving on, you gained proficiency in file I/O operations, understanding how to read from and write to files efficiently, and utilizing different types of streams for effective file management. Additionally, you explored serialization and deserialization, learning how to save and reconstruct object states, which is crucial for maintaining application data between runs. With these advanced skills under your belt, you are now exceptionally well prepared to develop robust, efficient, and scalable Java applications. The journey you've undertaken is a testament to your commitment and growing expertise. You've made outstanding progress, and your accomplishments in this course reflect your ability to conquer complex programming challenges. Your continued advancement in your Java programming journey indicates your potential. While this course may be complete, your learning journey is far from over. Continue to build on your solid foundation by exploring more advanced topics and exciting projects in Java. Keep the momentum going. You are now another step closer to achieving Amazon's professional certificate in junior software development and kickstarting your career in software development. This certificate prepares you for entry-level positions and demonstrates your proficiency and commitment to learning. Continue to hone your skills and knowledge by registering for the next course in this program. Every step you take brings you closer to achieving your goals. Thank you for your hard work and commitment. Best of luck with the rest of your learning journey as you refine your Java programming skills.